Hello and welcome everyone to ZaranTech. Did you know that professionals using data analytics can boost business efficiency by 40%? That's a huge advantage in today's competitive market. Data analytics using Python involves analyzing data to uncover patterns, insights, and trends. Python is a powerful tool for data analysis because it's versatile, easy to learn, and has a vast array of libraries and frameworks. Python automation helps streamline data processes, making your workflow more efficient and less prone to errors. Python data analytics boosts productivity by 30% and speeds decision-making. Data-driven firms are 23 times more likely to gain customers, 6 times better at retention, and 19 times more profitable. Mastering data analytics and automation is vital today for informed decisions, opportunities, and problem-solving amid big data's rise, enhancing careers and business success. In this course, we'll cover Python basics, data analysis techniques, and automation tools. You'll learn how to use libraries like Pandas, NumPy, and Matplotlib for data manipulation and visualization. We'll also explore real-world applications and case studies to give you hands-on experience. Before we begin, please make sure you subscribe to our YouTube channel and hit the bell icon for regular updates from us. Now let us look at the agenda. 1. SL classification. 2. Simple linear regression. 3. Multiple linear regression. 4. Decision tree. 5. Polynomial regression. Let's dive in.
So here we just mostly talk about the different classification algorithms. So if you see that these are the algorithms which we covered earlier, the simple linear regression, multiple linear regression, decision tree, random forest, and the polynomial regression. And if you come about the classification algorithms, so the first classification algorithm we are going to discuss, so that's the logistical regression. So then once the logistical regression is done, so we'll be going to the next. So overall, we are going to discuss 6 algorithms. So one is the logistical regression, and the second one is going to be KNN, K nearest neighbors. Third algorithm we are going to discuss is naive-Bayes algorithm. Then it's after that it's going to be support vector machine, decision tree, and the random forest. So out of that one, the decision tree, random forest, and the KNN. So we have covered the regression part of that. And the classification is going to be an extension of all these 3 algorithms. And whatever we are going to learn here, the logistical regression, support vector machine, and the naive-Bayes, so that is new. And what we are going to cover here, the logistical regression, again, this is going to be an extension of linear regression. So to a certain extent, this is going to be an extension of the linear regression. So theoretically, if you say that one, so the first of all, we need to understand what's the difference between the regression and the classification. So I'll just give you a couple of examples. So the regression, the data, if you see, it is going to be a continuous variable. So the result correct, what we are going to predict, so that's going to be a continuous variable. So for example, we are trying to predict the salary of a person. So the salary, if you can see that one, there will be minimum salary, and there will be maximum salary will be there, and it can have any number between the minimum and maximum. So in between the minimum and the maximum, it can have any number. So maybe correct another small example. If you want to predict the student's mark in an exam, obviously correct the marks, if you see that one, it is between 0 and 100, and the students correct, they can get any mark between 0 and 100. Again, if you talk about the sales, so for example, if you want to talk about the sales figure, so the sales figure also correct, it can be any number. So maybe correct, it can be any number. There will be minimum sales in a year and the maximum sales will be in a year, and it can have any number. So that's again a regression problem. Again, similarly correct, if you see about the profit, so the profit also there will be some minimum, maximum will be there, and it can have any number of values between the minimum and the maximum. But if you talk about the classification problem, so it will have the distinct values. So maybe correct, if you see the marks of a student, so we are getting 0 to 100, it can have any marks. So maybe correct, the next one, if you want to predict the grade, so the grade is something like it's going to be a classification, or you can have distinct grades. So it is not like that you are going to get any grade. The grade is something like A plus, B, B plus, etc. So there are 4 or 5 grades will be there. You will be able to get one out of that grade. So that's a classification problem. So maybe correct another thing if you want to predict. So maybe if you're pass or fail the exam. So this is again going to be a classification problem. So you have two options. Either you will pass the exam or you will fail the exam. So there are only two options here. So it is not like in between the pass and fail, there is no possibility. Again, if I want to group the students in a school, so based on the different house systems are there. So maybe if you want to group them in 4 different groups, obviously correct, that is going to be the classification problem. Again, if you want to predict whether it's going to rain today or not. So there are two possibilities are there. It may rain or it may not rain it. So maybe correct if you want to predict whether some match is going to happen. So the possibility is that it's having yes or no. So that way correct, if you have the distinct set of outputs, so we want to predict it. So that case, so we will be using the classification problem. So is it clearly, did you understand what's the difference between the regression and the classification? So based on that, we need to decide it. So normally correct if we get a data set and whatever the variable we want to predict it, so specifically correct the y variable. So we want to decide whether we want to use a regression or the classification algorithm. So any questions here? The difference between the regression and classification? So maybe the group of people, so maybe the company, the employees, if you want to classify based on their level. So there will be software engineers, there will be senior software engineer, then there will be team lead, senior managers, senior executives, etc. You want to classify them, it's going to be a classification problem. So then I'll directly go to the slide, and here some of the examples which is specified for the logistical regression. And the logistical regression, theoretically we will use a sigmoid curve to split the data. So whenever correct we want to split the data, so we can use the sigmoid curve and we can split the data, and it will have two outputs mostly. It will have the 0 or 1. So here you can see that one. So there are some students score, CGPA score is specified, and the score can be any number. So any score you may get between 0 and 10. So but correct what you want to predict, you're going to get the admission. So maybe correct the higher studies if you want to get the admission. So the possibility is that you will get the admission or you will not get the admission. So these are the two possibilities we have. So if you get the admission, it will be 1. If you're not going to get the admission, it will be 0. So how it is deciding? So the CGPA rating can be any number. So based on this particular number, there will be some threshold will be there. So in this example, you can see that when all these marks, all these grades below 5.5, you are not getting the admission. And all the grades which is above 8.2, you can see that when you are getting the admission. So obviously in this case, you can see that when the threshold or the cutoff. So that's a number between 5.5 and 8.2. So because from here, so we are not clear what is the cutoff, but in between there's a cutoff will be there. And here you can see that once your X or the grade is below the cutoff, you will not get the admission. And whenever you just cross the cutoff or at the cutoff, you are going to get the admission. So that's what you are able to see. So in this case, you can see that you have only two outputs. So theoretically, it says that your X value, what you are going to represent there in the X-axis, that is the score, CGPA score, whatever be the score, if it is start from -infinity till the cutoff value. So maybe correct consider scenario if you have some negative marks, etc. So then also correct, obviously you're not going to get the admission. So it will start from -infinity to cutoff work. Whatever be the case, your status is going to be 1. So whatever you want to predict it, that is going to be 0. Once correct, you cross the threshold or the cutoff value, it is not necessary that it will be exactly there in the middle. So whatever be the cutoff value, once it crosses that one, you will be getting the admission. So that means from the threshold to plus infinity, you will be able to see the output as 1 here. So that way the logistical regression is going to work. So if I just plot a graph here, so quickly correct, if I just plot here, so this is what you're able to see. If I just plot my x-axis here, and once it reaches my threshold, it will go up, and after that it will be continuing there in 1. So this is going to be 0, and this is what you're able to see as 1. So as long as correct, somewhere here you will get the threshold, and after that it is going to be 1. So there are two possibilities are there. So the question will be that why can't we use a linear regression model here? So if you want to create a linear regression model, so you know that when whatever the result which is going to predict, it is going to predict a straight line. So whenever correct, if I want to predict a straight line for this particular data set, maybe correct the straight line may go something like this. So that's what you are able to see. Or maybe correct the straight line can go like this. So whatever be the case, always you will be able to see an error. So if the straight line, assume that in this particular form, you can see that whenever the x value is going to decrease it, you definitely see that when this gap is increasing. So that means the error is increasing. Again, if you see the x-axis is increasing, obviously this line is going up, and you can see that when this gap is increasing. And here and you can see that when there is some gap will be there, that will be the error with the linear regression model. And these type of scenarios, the linear regression won't be a fit. So the linear regression won't be the best fit in this type of scenarios. So that's the reason we are going with the logistical regression here. So that is one of the example is specified. So you want to check the admission based on your score. So maybe correct another point if you want to check. So how much time you spend your studies, and based on that, if you want to decide whether you will pass or fail the exam. So here what we want to predict. So to output, the possible outputs are either you will pass the exam or you will fail the exam. So there are only two possibilities. But the input, if you see that one, it can have a number of values it can have. So maybe correct, you spend 10 hours for your studies, 50 hours for your study, 30 hours for your study, 33 hours for your study, 35 hours for your study. So how much time you will spend it? So irrespective of the time you spend, the output, if you see that one, that is going to be 2. So there should be some threshold will be there, because the hours of study and pass percentage, it is not directly related. So with this one correct, we might not be able to make a threshold. So there are other parameters also you might need to consider it. But this hours of study, if you see that one, this is a continuous variable, and you can have any number, any values here. But the output, if you see that one, the output is going to be distinct. So either you will get 0 or 1. So it's going to be a classification problem. So now correct, if someone is going to contest in an election, and what will be the output you will get it? Either you will get win or you will get defeated. So there are multiple factors is going to affect your so affect maybe during your election. So maybe one of the parameters that how much money you spend. So that is one of the parameters. So maybe correct, what's your qualification? Again, which party you belongs, political party which you belongs. Again, how long you are there in the politics. So maybe correct, currently you're an existing MLA or MP or you're a minister. So there are so many factors which is going to determine the chance of your winning that election. But the output, if you see that one, it will be 2. So either you will win or you will not win. So this is the two possibilities you can see. So this is what you can see. There are multiple input variables are there, independent variables, and the result, if you see that one, it's going to be 0 or 1. So these type of scenarios, we can use the logistical regression here. So this is the diagram which I specified. And this is going to be the linear regression curve. And here, obviously, if I want to predict 0 and 1, you can see that one, the error will be there. So that's the reason we are going with the sigmoid curve. And this is going to be the sigmoid curve, you can see. It's something like an S-type curve. Again, another example is specified. If you want to check whether you have a disease or you don't have the disease. So there will be a lot of tests we'll be doing. So there will be scanning will be there. There will be a blood test will be there. Again, the multiple tests the doctors will do or the hospital do. And the outcome, what you're going to get. So whether you will have the disease or you are not having the disease. So that's another example it is specified here. So now if you talk about what is going to be the equation for the logistical regression. So this is going to be an extension of the linear regression equation. And here you can see that why do I say that this is an extension of the linear regression? Because if you see this right part of this particular equation, so this equation is same as that of linear regression equation. So the linear regression equation you will be knowing. If your multiple variables are there, corresponding to each variable, there will be a coefficient will be there. And here the coefficient is specified as B1, B2, etc. corresponding to each x variable, and there will be an intercept will be there. So the intercept, what you can see here is C. The C is going to be the intercept. So based on that, correct, we will predict the y value. And this is the part which is related to the logistical regression, that is equal to log of y divided by 1 minus y. So that is what you can see here. And how we are deriving this particular equation. So this is derived from the sigmoid function. So we are deriving this particular equation from the sigmoid function here. So this the derivation is specified.
Can you explain the activation function, the sigmoid function, to the team? Why we have used the sigmoid for the logistic regression?
Okay, so this is what you can see. This is the sigmoid function you can see. And if you want to talk about the derivation, how we can derive it. So if you see here, this is the sigmoid function which I have 1 divided by 1 plus e to the power minus y. So this is what you are able to see. And the explanation, if you see that one, how I can derive it. So this is equal to 1 divided by 1 plus e to the power minus y. And here, what I just try to do as a first step, I'll just try to multiply with e to the power y. So both the denominator and the numerator, if I just try to multiply, so here you can see that one, it is going to be e to the power y divided by the denominator. If you try to multiply with e to the power y, so that is equal to e to the power minus y. So that is what you are able to get from the sigmoid. And again, you try to multiply e to the power minus y and e to the power y. So obviously correct, both minus and plus. You can see that would get cancelled. So if I just show here how it is getting cancelled, so maybe correct if I want to multiply 10 to the power 5, or maybe correct, I'll take it as 10 to the power 3. And if I just try to multiply 10 to the power minus 3, obviously it is going to be cancelled out and it is going to be 1 here. So this is what you can see, 10 to the power minus 3 here. And what is 10 to the power 3? So 10 to the power 3 is equal to, it's equal to 10 3 times. So that is equal to 1000. And 10 to the power minus 3, that is equal to 1 divided by 1000. So that's what you are able to see. So obviously 1000 divided by 1000. So that's what you are able to get the result as 1 here. So that's the same logic we applied here, e to the power minus y. So multiplied by e to the power y. So both minus y and the plus y, it will get cancelled and we are able to get 1 here. Again, this 1 we are multiplying with e to the power y. So this is what you are able to get. So e to the power y divided by 1 plus e to the power y. So now if I just move this part to the left side, so p into, if you multiply this part, so this is equal to p into 1, that is equal to p plus p into e to the power y. So that is equal to p into e to the power y, and the numerator will be as it is. So now here what we'll try to do that when this part will move to the right. So once you move this part to the right, it is going to be p equal to e to the power minus e to the power y minus, because this is the plus here, and once you go to the right side of this one, this is what you're able to see, e minus p e to the power y. So now here you can see that one e to the power y is common here. So if you take this as common, so this is going to be 1 minus p, because e to the power y, so that is common here. So now if you just take it up e to the power y, and this is what you are able to see, the p divided by 1 minus p. So this is part correct. This is e to the power y into 1 minus p. So and this is what you just bring to the left side. This is going to be p divided by 1 minus p. So now if you take the log, they are in the both the sides. So this is what you are able to see, log of e to the power y. And we are taking the log of this part as well. So the log of any value if you are going to take, so the exponent correct, if you are going to take the log of this value, obviously you are going to get y. So y equal to log of p divided by 1 minus p. So that's what you are able to see, p divided by 1 minus p. And this is the equation for the linear regression. So this part we can directly replace with the linear regression equation. And that is what it is specified here. So that is equal to log of y divided by 1 minus y. That is equal to y. And this is correct. It is going to derive it here. So again, the y. So this is the derivation which is coming for the logistical regression here. So is it clear, the derivation part? So this way correct, we can derive from the sigmoid function the logistical regression equation and how we can equate with the linear regression. So now there are some differences between the linear regression and the logistical regression. These are some of the differences specified. So the first difference is that the linear regression, if we want to use that one, so we need to have a continuous variable. Again, the logistical regressions, we need to have the categorical variable. Again, if you draw the line, it is going to be the straight line. but the logistical regression, it is going to be the curved line, etc. So there are some relations, the differences are specified. So you can just go through it as well. So next I'll go to the example. So how we can create the model with the logistical regression if you don't have any questions. And I want you to do in parallel so that we'll get an idea how we can apply the logistical regression model. So I'll suggest you to open Jupyter Notebook and I'll wait. So we'll do it together so that at least a couple of examples you will get an idea. And I hope you would be knowing how to open Jupyter Notebook. In your search bar, you can just give Jupyter Notebook and you will be able to get it. And this is the data set which we have. And there are around 400 records are there. So not a huge data set. And here we want to predict the column E. So the column E is what we want to predict it here. And what we want to predict, so we want to predict the result as 0 or 1. So that's what exactly we need to do. And based on what we want to predict, so we want to predict based on the gender, age, and the estimated salary we want to predict it. The first column, you can see that this is a user ID. And obviously, this a continuous number. You can definitely ignore this particular column. You don't need to consider it. So we can just consider the age, estimated salary, and we can just try to create the model here. So that's what we try to do it right now.
How you will go through the conditions for the logistic? Like the dependent variable has to be categorical. It will be through your exercise?
Yes, correct. So we will be creating the variable X, Y, etc. And I will showing so how we need to load this particular file, how we are creating X, how we are creating Y. All these is correct. Eventually, how we are doing the predictions and how we can check the accuracy. All these things correct we'll be discussing. Okay, so this is the data set which we have. And here you can see that one. So here what we want to predict, we want to predict the purchase column. So the purchase column, there are two possibilities are there. Either the purchase can be 0 or 1. So these are the two possibilities. That's what we want to predict it here. So the same thing that we want to predict by using the two columns. So that means we are going to consider the two columns. That's the estimated salary. And we are going to consider the age column here. So the first of all, correct, as we discussed there in the data pre-processing steps. So we need to import all the record libraries. So what are the different libraries which we learned earlier? So we were discussed about NumPy. So we will know import NumPy as NP. So import NumPy as NP. So in parallel, you can do this. Again, import pandas as PD. Then also correct, we try to import OS. So why do we need to use the OS? Because if I want to make some folder as the default folder, etc. So we can use this OS statement. So we can do the change directory. All these things correct we can do with the OS command. Again, if you want to plot any graphs, etc., we can use matplotlib. So import matplotlib.pyplot as PLT. So these are the different libraries, so which we are importing it for the time being. So the next one, what we need to do, so we need to load this data set. So we can see the data set which is used here. And this is around 400 records. That's what you're able to see. And if I want to load this particular data set, obviously correct, I need to ensure that I'm just rightly pointing to the folder where the data is available. So any point, if I want to know which is my current active working directory, I can use a statement os.get current working directory. So here correct, you can see that this is going to be the current active working directory. So now I need to point to the place where the data set is available. So my data set is available in this particular folder. So I want to make this as my default folder. So that's what I try to do it right now. So if I want to execute this command, I can use os.change directory. So os.change directory chdir, and I'll just make this as my default folder. And if you're not doing this one, you can just give the full path while you're reading the file. Again, this should be there in either single quotes or double quotes. So that's what you're able to see here. And always, so we need to give 2 slashes. Obviously, we know that one, why we need to give 2 slashes here. The same I explained as well. So now if I just execute this statement, I can see that when my default folder is changed to the folder where the data set is available. So next, I want to load a particular file and I need to check what is a file type. So I want to load this particular file and you can see that this is a CSV file. The CSV file is the comma separated file. It is not an Excel file, even though it shows it's an X here. It's not an Excel file. The extension, you can see that this is a CSV file. It's a comma separated file. So if you just double click it, it will open it there in an Excel, but it is not necessary that it should be a CSV file. It's not necessary that it should be an Excel file. Now, if I want to open this file, I can just right click, and to ensure that it is a comma separated or any other delimiters, etc., semicolon or the tab separated, etc., you can try to open with Notepad here. So whenever you try to open with the Notepad, this is what you're able to see. Each column is separated by comma here. So this is going to be the header line. And you can see that one, it is separated by comma. And this is what you are able to see. This is my first column separated by comma. Second column is separated by comma. Third column is separated by comma here. At any point in the data set, if this particular value is not available, so this is what corrects. So we need to give an extra comma. So that shows that when this particular value is not available, and whenever the system tries to read this data, the system will try to read this data. So other than comma separated file, if you want to load the file or if you want to open the same file in an Excel or something, so what we need to do. So for example, if you just double click, you might not be able to open a semicolon separated file. Directly, you won't be able to open it. So in that case, so we need to load the file by using the data. So you need to open. I'll just show you how we can open a comma separated file, semicolon separated file in an Excel. So you can directly go to the data tab. And here you can just select this option from text. So this is what really we need to choose it. If we want to open the data from other format, other than comma separated, semicolon, etc. So you can rightly go to the folder where the data is available. Directly go to the folder where the data is available. And from here, I want to open the data set. So this is the data set which I want to open it. I just click on import here. And this is the place you need to specify what is going to be the delimiter. So here I can specify whether it can be a fixed width or it can be the delimited. And I can just click on next. And this is the place you can specify what is the delimiter here. If it's a semicolon separated, you can specify a semicolon. And here you can see that this is a comma separated file. So you can just specify this as comma. So once I select the separator, obviously correct. Earlier you can see that when the data, everything is coming together. So now if I click on next, when I will select the right separator, you can see that when the data is coming in separate columns. And now this is what you're able to see. Then you need to click on finish. You need to specify which location you want to load the file. You're able to get the file here. So by default, if it is a comma separated file, you will be able to open. So other than comma, if some other format it is there. And if you want to open it to an Excel, this is the way you can just open it. You can go to the data and you can just open it here. So now, so I just moved to this particular folder and I want to read this particular file. So if I want to read this particular file, I can use a df. I'm just creating a variable and you can just specify any variable here. And after that, I want to specify PD. So the PD is for the pandas and I want to read a CSV file. So if I want to read a CSV file, I can use the read_CSV. So read_CSV. And there are other formats also there. And if you're not sure what you need to use it here, so you can press tab, shift tab, you can press it. You can press tab and you will be able to get from the drop down. You can select here read CSV because this is a CSV file. And after that, we need to specify the file name with extension. So that is mandatory. So if you just specify the file name, you will not be able to get it. So you need to specify the file name with extension. So here by default, it is a delimiter, the comma separated. So you don't need to specify any other parameter. Otherwise, correct, if there are some other format, the semicolon, etc., we might need to specify the delimiter. Again, if you don't want, and your file doesn't have in the heading, so specifically correct. If you don't want to read this headings, etc., there are specific commands are there. And I'll just explain you that later. So whenever the appropriate files we are reading it. So this is what we are doing. So we are using pd.read CSV. We try to read this particular file, and this is a comma separated file. And next, correct, I want to view the file. I can just give here as display df here. So you can see that one, the files is visible right now. So can you try up to this step, at least 3-4 steps till reading the file, or it's already done? I'll wait for a couple of minutes so that you can execute up to here.
Yeah, just wait.
Yes, sure. And I'll ping the script there in the chat as well. So this is the place you need to specify your own folder name where you're copying the file. So let me know once you finish it. So next, what is our next step? So we want to split this data. So normally correct the regression also we did the same. So we split the data between independent and the dependent variable. So for the first time, I'm just considering only these two columns as my independent variable, and this is my dependent variable. So I'll just extract these two columns as my X, and I will be considering this column as Y. So obviously correct this column, the user ID is not required because this is a continuous number, and you can definitely include the gender column as well. So if you're including it, you need to convert this to 0 and 1. You can do the label encoding, or you can just use the map function, etc. You can convert it. So this is what I have extracted, these two columns, X and Y. And after that, correct, what we need to do. So we need to do the train test split. So that means whenever you do the train test split, the system will randomly take certain number of percentage of records as the training data set, and the remaining it is going to be the test data set. Now, what is the percentage you're specifying? So that's a 3.3. So that's a 30%, etc. That is going to be the test data set. That is going to be the test data set, and the remaining 70% will be the training data set. So it is going to be the random split. So the system will try to do the random split here. So before doing that one, I want to get my X and Y created. So I'll be creating X. So how can I extract this X from here? I want to extract these two columns. So can anyone mention the command for that? There are different ways I can do that one. I can use the location, I can use the ilog, etc. I can specify the column name. So there are different ways we can do that. I'll just go with the ilog function. I'll directly go here ilog. So that is equal to index location. And what is the location corresponding to this? The location corresponding to this is 0, 1, 2. So that means I need all the records. That's what I'll specify here, all the rows, specifying the column, and not specifying the starting and the ending row here. So that shows that when it is going to pick all the rows. And the next parameter, I want to specify the column. So I want to specify the column. I want the second column up to second and third column I require it. So I can specify 2:4 here. And if I try to print X here, so this is what you're able to see. You're able to get the age and the estimated salary. 2 columns you're able to get. So now correct, if I want to create an array out of that, I can just use a statement dot values. So you'll be able to create an array here. So we can get an array here. So next correct, I need to get my Y. So Y is the variable which I want to get it. And that is my last column, which I want to use it. So if I want to get the last column, so here I can specify the -1, the -1 related to the last column, or directly correct, I can specify the column name, column number. So if I'm using the ilog, or you can directly specify the purchase, the column name also you can specify. So whatever way correct we want to extract it, you can do it. Here I'm going with the ilog, and here I'll just name the variable as Y. And I want to extract the last column, so I can specify here as -1. And this is what you're able to see. I'll just try to display Y. So I'm able to get my Y variable here. So now here also, if I want to create an array, I can just give here as values. So I created my X and Y here right now. This is a two-dimensional array, this is a one-dimensional array. We extracted the data here. And I'll just give the script as well. Again, what is the next step you can do here? So here you can see that one. So this is a 2-digit number and this is a 5 or 6-digit number is coming. So we need to standardize the data. So there are 3 methods we learned to standardize the data. One is standard scaler, min-max scaler, and the normalizer. So that is what we learned as a part of the data pre-processing steps. So obviously so we need to check are there any null values, etc. But obviously this data set doesn't have the null value. So that's the reason we just skip that one. And so here we just try to standardize the data. So to ensure that all the data they're in the same scale. And we try to use the standard scaler, and the standard scaler is based on the standard deviation formula. And all the values will be rearranged between -3 to +3 range. So most of the values will be in that particular range. So if I want to use the standard scaler, so you can use sklearn.preprocessing import standard scaler. So we can just import it and we can just execute it. So this is going to be the statement which we can import it. sklearn.preprocessing import standard scaler. This is the library, we can use it. And after that, what we can do, we can just create one variable. I just create one variable standard scaler. And I want to call this standard scaler here. And I don't want to pass any additional parameter right now. So that's fine. So next thing that I need to do a fit and transform. So I need to do a fit and transform. You can do it in 2 steps or you can do it in 1 step. Just give it a fit underscore transform here. So this is what you can do. And what I want to transform here, which data I want to transform it. I want to transform my X data here. This is what I have done. So now this is what you have done here. And similarly, if I want to use the min-max scaler, obviously you can use that one. So instead of standard scaler, we can use the min-max scaler. Both will do the same. So, but the representation or the formula will be different. The min-max scaler, if we use that one, the data will be split between 0 and 1. The minimum value, which is there in this column, that will be the 0, and the maximum value will be 1. So if I want to use the min-max scaler, I can just give here min-max scaler. And instead of standard scaler, I need to call min-max scaler here right now. So if we apply the min-max scaler, we can see that on the value will be split between 0 and 1. So I hope this is the smallest value in that particular column. This will be 0, and the highest value in that particular column will be 1. And that will be applicable to both the columns here. So so it is not necessary to do both. You can do one out of this one. So I'll just go with the standard scaler right now. I'll do the standard scaler and I'll do fit and transform. And my X need to be updated with the transformed value. So that's what I try to do here. X equal to se.fit transform X. And I just try to display X here. So I'm just displaying X here. So this is what we have done. We transform the X, standardize the X, and the X is in the same scale. So now what we do the next step, we'll do the train test plate. So the same thing what we did there in the linear regression. So we will be doing the train test split here. So we'll try to import the same. So that's what we try to do, try to import it here. So we try to import the train test split here. So we just try to import sklearn.model selection, import train test split. So what it will try to do, it will randomly split the data between the training and the test data set. So that's what you can do here. And again, it is going to be the same process. So I can use the train test split here. And what I need to split, so I have 2 variables right now. I have X and Y. So this is what I want to do here. So I want to do the train test split X comma Y here. So now if I execute it, so this is what you are able to see. So there are 2 set of variables are created. So actually the X is going to split into 2 and the y is again going to split it into 2. So I need to create the different variables which we can hold the x comma y. So I can use x underscore train, comma. So the x need to be split into 2. X underscore test, I can specify here, and I can specify y underscore train. Again, I can specify the next variable that is equal to y underscore test. So these are the different variables which we created right now. And now this is completed. So now correct, I want to know how many records are there in X train. I can just give here a shape. It is going to give you the number of records there in X train. So here I'm doing the train test split, just passing the value. Under the default percentage for the train test split is going to be 25%. So if you're not specifying the split percentage, it will go with the default percentage. And if you want to know what is the default percentage, etc., you can just press the shift tab. You will be able to get the detail. And this is what you're able to see the test size. The default, it will be set to 25. So that means total we have 400 records, and the 25% of that is going to be 100 record. So the 100 record is going to be the test in this case, and the remaining 300 is going to be the training. So any point correct, if you don't want to go with the default percentage, and if you want to give your own percentage, I can specify my test size equal to 0.2. So I can specify my test percentage equal to 20% here. So now if I execute it here, and if I just print xtrain.shape, you can see that 320 records will be there in the training, and the remaining 80 records that will be there in the test. So this way, correct, we can do the train test split. And if you want to check the count, xtest.shape. So these are the number of records that are in the test set, and the x train and the y train should have the same number of records. So obviously correct. So that's the reason we are giving it together. So that's the reason we are giving it together. Y train.shape here. So 320 records are there, and y test.shape, if you just give, it will have 80 records here. So this is the folder we can do it. So here, correct, I split between x and y, and after that I did the train test split. So if you want to do the train test split first, then if you want to split between x and y, that's also possible. There is no issues. Again, after the split also, if you want to do the standardization, we can do that one. But after the split, if you're standardizing it, so you need to ensure that you're doing the standardization to x train and the x test. So can you execute these steps? So I know that we stopped the point where we load the data set. And I'll just specify the script here. So this is what we are creating, x and y. So this is my x and y here. And we are just doing the standardization, standard scalar. So this is a step we do the standard scalar. And after that, correct, we are doing the train test split here. This is what you're doing as a part of train test split here. And let me know if you're getting any error as well. So let me know if you're stuck somewhere and any help required to write the previous statements, etc.
So, Noble, the primary purpose of doing this split is to have the data set on which we will run our model, right? Or algorithm.
So we are just splitting it so that a portion of the data I can use it to create the model, and a portion of the data I can use it to test the model. So sometimes, correct, if you are two set of data already available, so you no need to do the train test split. So the splitting is not required. So one of the data set directly you can use it for the training the model, and another set you can use for the testing the model.
So, Noble, it will be foolish if we do tests as well as train the model on the same data set, right? That will be foolish, right?
So then correct, there will be an issue for the overfitting, etc. Correct, if you want to test it. So it does not make any sense, correct, if I create the model, test it with the same data set, and obviously correct, we need to test with another data set, then only we'll come to know if there's an overfitting, etc. there. Obviously correct, you created the model with one data set, then you do the predictions out of that one. So obviously you will get a better accuracy because you use the same data. Again, if you use another set of data, then only really will come to know that when there is an overfitting there. So I'm using.
What exactly do you mean by overfitting?
So the overfitting is the scenario where you create a model and the accuracy of the model, if you see that one, whenever you, so normally correct, we have a training set and we created the model, we check the accuracy of the training set and you are getting maybe around 95% of accuracy. So now correct, if you get some different data, you're getting a test data and there you can see that when the accuracy is very poor. So maybe correct, you're getting only 70% of accuracy. So this type of scenarios are called the overfitting. So we are creating a model. In that scenario, it is behaving well. And whenever you come with some new data set, their correct accuracy is poor. So that shows that correct, your model is not properly created. So that is called the overfitting case.
Usually in any data science project, we follow the practice of test and train. And there's one more thing, that is out of time validation. But usually the principle is 80 to 20 when we talk about the test and the train. 80% will be your train data and 20% will be your test data. And why we do this? Because your 80% of your data is the data on which you perform, you do hyperparameter tuning, you do a lot of feature engineering, like you train your data, you do the smoothing in your data, you build your model on that 80% of data. So you do a lot of you perform a lot of statistical techniques also on your 80% of data. And once your model is built on 80% of data, then on the same results, on the same what you have built, you test on your 20% of data. So as the Noble highlighted, that if your training data sets gives you the 95% of accuracy and your test data gives you 70% of accuracy, in that case, it should not be the case, because you have already trained your 80% of data, right? So the accuracy should be around somewhere same, like 95 or 90, 92%. Then only you can say that you have constructed a robust model. So in order to test your model, you always keep 20% of data to test your model precision and accuracy. And to understand that whatever you have built, whatever logics you have taken in your 80% of data is perfectly fine and doing the justice on your rest of the 20% of data. And why we do all these things? Because the model building is not the one-time exercise, right? There's a lot of data which keep floating after. For example, if you just took 3 years of data in your data in the consideration, but post that, what the client will be using it to the next year data, right? So it's important, whatever you have built, you test it and then you deliver to the client. I hope.
Thanks, Umang. So Umang, now when we get the data for the 4th year, that will also get added as a train data, right?
No, here correct. You can see that we have all the data here. So here we have around 400 records here. The same data, that is what I try to use it to create the model. And from that one, I'm just keep selecting a certain percentage of the data. That's around 80% of the data I'm just picking up. And by using that 80% of the data, I'm just creating the model. Obviously, correct. In any case, if you create one code, the code need to be tested, right? So it can be the unit test or whatever the test is. So that's the reason. So that is what correct. We are keeping a 20% of the data to test the model. So that is actually we are going to do as a part of train test split, split the data, we keep it separate. So technically, if you ask me, can I create the model with the full data set? Obviously, you can create it. The algorithm will not give you any error. You can test the complete data set. You can test it. It will not give any error. But the testing we are doing ensure that one. So the model is going to behave different scenarios in a consistent manner. Because I don't know, correct, I created a model with some certain percent of the data. And tomorrow, if I test the model, or maybe correct use with the different data, and here I am getting 90%, and there I am getting around 50% of accuracy. Obviously, correct, the people will question it. What is the model you created it? So to avoid that one, so we need to test it multiple times. There are different techniques which is used for testing it. So there are here itself, we have some cross validations, etc. there. So we'll come to that the later point, but just assume that on what's the data we are getting it. So for certain percent, we are keeping it for the training, and a small portion of that one we are used to test the data. So then, correct, you can just compare the result. Whatever is predicting from the model is matching with the actual result. So I can do the training, or I can predict the test data set. I can predict by using the training data set. I can predict for all the 400 records, and I can show you that. So maybe there will be slight difference there in the accuracy. So there are different techniques are there. So then, correct, so you will ask, so can I randomly pick it? So do I need to do the train test split completely? So maybe, correct, some cases you have totally different data set. The client itself supplying you to test it. You can use that data and you can test it. So it is not necessary that you need to use the same data for the same test split. That's again scenario based. If you already have, the client is giving you one data for the training, one data for the test, you no need to do the train test split here. So in this case, we have only one data. That's the reason we are doing the random split. Or maybe, correct, some other case you are randomly picking some data. And why do I need to use a train test split? So that is randomly it is going to split. So can I manually split it? Obviously, I can do the manual split. But if I do the manual split, obviously, correct, I may take first 300 record, and the remaining 100 I will keep for the testing. Then there might be chance that the mix might not be proper. So maybe, correct, if you're getting the data in a particular order. So maybe if you are getting the data for 4 regions, and the first 100 region will be East region, remaining 100 will be the West region, remaining 100 will be the South, and the remaining is the fourth. If you take first 300 records for the training, and if you keep it separate 100 record for your testing, what will happen? You will not have the data for the last region for the training the model. So that's the reason you are using this train test split. It will randomly pick the data. So that's the only thing. So how we can split the data? Manually also we can split it. There is no problem. A different data set we can do it, get it, no problem. But this is the process they normally follow it of the train test split.
No. Manually, we don't recommend to split the data. The reason why, if the data is a time series, we should not split manually. Okay, so we should always.
So that's what I told you, correct. We cannot split it manually in this case. The challenge will be that we can technically split it. There is no problem. But the challenge is that the region, the first 100 record is for my north region. Again, the remaining 100 record is for my south region. Again, the remaining 100 record is for in the east region, and the remaining 100 record is for into the west region. If you do the manual fist, obviously, correct, the first 300 records, I have the data only for this. Again, whenever I test it correct, I'll get only west region. Obviously, this is not going to, this will not give you the said result. That will be the challenge for the manual splitting. So that's the reason we are going with the train test split. The train test split, correct, it will randomly split it. So maybe, correct, 25 records, it will pick it from here, another 25 here, another 25 here, another 25 here. So that means, correct, based on that, it will run one algorithm and it will pick it up. And there is one more parameter is there, that is called the random state. So based on that, correct, we can adjust the split, the frequency, etc. correct, how frequently we want to rotate it. So that also we can adjust it. So that's again another parameter, the random state. So maybe, correct, the coming exercises, I will use that parameter also. But here I'm using very basic things. That's a test size. And it's about the explanation for the underfit and the overfit. So here, correct, if you create the model and look that one, this is my data set. And if you try to do the prediction here, so the actual data is something like, you can see that one, this is the dotted line. The prediction line, if you see that in this straight line. So obviously, correct, you can see that there is a huge deviation. So these type of scenarios are called underfitted model. So the accuracy will be very less. And here, this is the best fit. You can see that when it is going to the central part. So now, correct, you can see that one. You can see this is going here. And this is an overfitted model. So this is going to each and every point. But consider scenario, correct, if a new point comes here, and if a new point comes here, am I going to get the 100% of accuracy for that point? Obviously, no, right? If a new point comes here, my predicted line is here, obviously there will be differences will be there. So that is what the overfitting model. Whenever I created the model with the training data set, I am getting a good accuracy, but some new data is coming. It is not overlapping with the existing one. With some minor deviations, etc., you will get the error. But here you can see that one somewhere in the middle, this line is going. So that's what the training also will give and the test also will give. This is the definition. If the model performed well on the test data set, that's a good model. And if the model performed well on the training data set, then it's going to be an overfitting model. And otherwise, this is going to be an underfitting model. So this is about the overfitting and underfitting. And I hope I have covered the earlier class. So these are some of the techniques we can do the underfitting, overfitting issues. And we will talk about all these things in the coming classes. What's the cross validation? How we can train with more data, correct? Obviously, we need to increase the number of reports. How we can remove the features. So we removed some of the features whenever we are doing the ordinary least square method, some of the backward eliminations method. Again, wherever correct. So there is a multi-collinearity there. So we removed some of the features, etc. Correct. So we can do that. So these are some of the techniques through which we can address the overfitting. And I show you the difference between whenever I use the random forest, the decision tree and the random forest. I showed you that when my decision tree gave me 100% accuracy. But whenever I created the random forest with multiple decision trees, the accuracy was a bit less. But that was capable to predict for multiple conditions. So that's what we already covered there in the random forest regression as well. So these are some of the techniques so which we were using it. Okay, so any questions on the train the split? So have you all completed the statement? Any error you are getting, you're not able to do? I hope all of you are doing it right now. So this is the part we done. So next, correct, I have done the train the split. So now if I want to see the data, correct, how it looks, if you want to plot the graph, etc., correct, you can just plot the graph. So I didn't do that one. So my X and Y, correct, how it looks, plt.plot. So specifically, correct, if I want, what is my X? The X is my age and the estimated salary. So if I want to get some relation, this is equal to df. And I can specify here age. And I can specify df. The next column, I can use it here. Estimated salary. So this is what you are able to see this way my data looks, and the data is fully scattered here. So I am not able to really get any relation. And whenever I try to do the prediction as well, might not be able to get the right result. So because the data, if you see that one, it is fully scattered. So this is what you are able to see the data. So I have 0 and 1. So you can see that when both the value belongs to 0 and 1, it just overlapped here. So whenever correct we try to do a logistical regression, I might not be able to get the proper result here because it's fully scattered. So the same data set, we can use it in all the algorithms. So definitely we'll be using multiple data set. So you can see the difference, how it is going to behave there in each algorithm. So the same data set. So if you see that on just the data, this is my x-axis, age, and the y-axis. You will be able to see my salary. And here this is corresponding to the cluster. The clustering is nothing but the 0 or 1. So that's what I used here to plot the graph. So now if I want to use the model, So I did the train test bit here right now. So next correct, I want to use the logistical regression model. So if I want to use the logistical regression, again, I need to import it. skn.linear model.
I don't know when you're trying to plot this.
Are you getting any error?
Yes.
What's the error you're getting? Can you go down equal to the x must have the same. So here it shows that the size is not matching. So can you go a little up? Okay, so here you specified right the age and the estimated salary. So there you need to give DF bracket, you need to give estimated salary. Try to give, yes. So these are two independent columns, right? We just give only the column name. And the plt.show open and close bracket.
Okay.
So this is a line graph is coming. The data is fully scattered, so the line is too much. Too many lines are there. So you can plot a scatter plot. You just change instead of plt.plot, just give a statement plt.scatter. So this is what I just did here. The skn.linear model, import logistical regression. And I can create one variable logistical regression. And I'll just call logistical regression here. Open and close bracket. I just want to create the logistic regression model. So this plotting and everything, right? So this is to view the data, how the data looks. So how many times, how many different forms, if you want to plot the graph, definitely you can plot it. Otherwise you can skip as well. But obviously, correct, to get the insight of the data, we need to get some representation. So how the data scattered, etc. So now what I have done, I just imported logistical regression model. So this is correct. Again, the linear regression, logistical regression, etc. comes there in the same place. If you want to import the linear regression, it comes under skn.linear model, import linear regression. The same place we have the logistical regression as well. And the process is going to be the same. Create one variable called logistical regression, open and close bracket. Then after that, we need to create the model. So create the model, what we were using earlier. So I hope you remember whenever we are using the standard scalar, etc., we used one command that is called the fit and transform. So we can use the same statement here, but we won't be using the transform here because I want to create the model. I don't want to transform the data here, right? So I can just create the model by using the fit, lr.fit. And what I need to use to create the model, I need to use the training data set. I can use x underscore train, comma, x underscore test. No, sorry. So the training of x and the training of y. So that's what I need to use it here, y underscore train here. So this model is created. The same thing I can just assign the variable lr equal to lr.fit. And I can just display lr here. I just created the logistical regression model here right now. So these three steps, you can execute it. Then after that, so my model is ready. Now I want to predict the result. So I want to predict the result. So for that one, I can use the model name, that is lr.predict. I can use it. And what I want to predict it. So I have kept a separate data, correct? I created a test data to validate it. So that's what I can do here. I want to predict the result for the test data. I can just specify x underscore test here. And I can just store the predicted value to variable y underscore pred. I can just give it here. And this is what you're able to see. So this is correct. You can give any variable name. This is what you're able to see the predicted values here. So the linear regression, whenever we try to do the prediction, you're getting a continuous numbers. So whatever we're predicting, we are getting the distinct salaries. But here, if you see that one, this is what you're able to see. So the prediction, either you will get the predicted value of 0 or 1. So now this is my predicted value. And here, correct, again, if I want to see the actual result, equal to y underscore test here. So here you can see that in many cases it is matching. Again, these are the cases correct is not going to match. So everywhere you are able to see it is coming as 0. And so next thing correct, we want to check the accuracy. So the accuracy also, there are different methods to check the accuracy here. One is confusion matrix, classification report, accuracy score, etc. Different methods are there. First, I'll go with the accuracy score. So the accuracy score is similar to R2 score. They're in the linear regression model. And I can directly use the accuracy score here. So while creating the accuracy score, it need to compare the actual and the predicted result. So this is my predicted result. This is my actual result. And it will compare and you will be able to get the accuracy here. Again, the R2 score and the accuracy score comes from the same place. So if I want to use accuracy score, sklearn.metrics, import R2 accuracy score. And I hope you remember we were using R2 score in the linear regression. So that also correct is coming from the same place. Import R2 score here. That's what you can use it. So this is be used for the regression, but classification. So we need to use accuracy score. And if I want to check the accuracy, we need to compare these two variables, y test and the y predicted variable. So the test is the actual value, and this is going to be the predicted value here. So now I can use this accuracy score, the variable I can use it, and I want to pass to input based on what I want to check the accuracy. This is what I can use it here. This is equal to y test, and this is going to be the y pred. Two variables it will use it, and it will find the accuracy. So here you can see that it is 62.5% of accuracy. That's what you are able to see. Again, there is one more method to check the accuracy. That is called the confusion matrix. So the confusion matrix also used to check the accuracy. It is again going to be the same way. So this is what you are able to see. Again, sklearn.metrics, import confusion matrix. And here again, correct, if you want to check the accuracy, you can just call this confusion matrix, and we need to pass the same parameter, y test and the y pred, and you are going to print the accuracy here. So here it is not directly going to give you the accuracy. So we need to calculate the accuracy. So to calculate the accuracy, the formula will be, we need to add all the diagonal values divided by the total number of records. So you need to add all the diagonal values. That is equal to 50 plus 0. That will be 50 divided by the total number of records equal to 80. So that is going to be the accuracy you'll be able to get. That is 0.625. Both correct accuracy score and confusion matrix. The accuracy will be the same, but it is going to be a different way representation. And they will call it as a true positive, true negative, etc. I'll explain that as well. So any questions here? Are you able to get this up to this point? Create the model, try to do the prediction. I did the train the split, just creating the model here. After that, I try to do the prediction. Then I'll try to print my accuracy score. And I'll try to print my confusion matrix as well.
Hello, Noble.
Yes, tell me.
Yeah, so when we are splitting the data and we're doing a random split, so every time we run all the cells, the accuracy score will change based on the split, right?
Yes, correct.
So in this case, we have a small data, but in case of large data, what is the range of the change in the accuracy score? Because if it is changing dramatically, so we cannot rely upon it, right?
If your model is good, it will not change much. Maybe 0.5% it is going to change.
Okay.
So if your model is good, right? If you're changing it, well, the small data, no, the small data, there might be changes will be there. Even if it is going to be the 500 records also, it should not change much. If it is some 10 records or 20 records, you will be able to see huge deviation. And if you have some 500 or 1,000, 10,000 records, and if you execute it, do multiple times if you execute it. And if you see huge deviation, then that model is not proper. So that obviously correct. The model is not behaving properly in all the scenarios. And each and every time, if you are executing it multiple times, if you want to get the same data in your training and the test data, one more parameter we need to specify, that is called the random state. If you specify that parameter, obviously correct, each and every time it is going to be the same value. So that's what you're able to see. But the problem is that it should not change.
Noble, can you please also tell like what all assumptions we need to consider while applying this logistic regression or the linear regression? Assumption in terms of the data, like how our data should be, and then we should think of applying logistic regression.
So there are set of assumptions we need to do, that is called the data cleaning. So there are set of data pre-processing steps are there. And so these are some of the steps we need to see. So we need to clean the data. So specifically correct, there should not be any junk characters, there should not be no outlier. All these things correct. So the data should be there in the proper format. All these things will come under. There should not be no missing values. If there are some missing values are there, so we need to address the missing values by using outlet.
Sorry, Noble. Actually, I'm asking specifically for logistic regression. Like we should consider the this let's say the multi-collinearity, and we should also see if there is no correlation kind of thing. So those kind of assumptions, especially for logistic regression, that I'm asking.
So that the assumption is not only for the logistical regression. So that's what I just come to know. So we need to ensure that when there are no missing values, if there are some missing values are there, how we can address it. So if the missing values and if the data there is no outlier, we need to go with the mean, median. And if the categorical values, if there are some missing values are there, we need to go for the data imputation. So the data imputation, we need to go for the mode. So that means the value which is going to repeat it. Again, this comes to the table encoding, one-hot encoding, then the standardization, normalization, all these things correct. So we need to do as a part of the data pre-processing step. And in addition to that, whatever the data which you see, any data if you see, these are the other aspects. So we need to consider here. So there should not be no multi-collinearity if you talk all these things. And if there should not be no autocorrelation. So I hope correct, I didn't talk about all these things because it's already covered. Even if correct, if I want, I can explain about the multi-collinearity. So just want to know correct, how many of our first time attending this course? Okay. So there are a couple of things. So we need to see. It's called the data pre-processing steps. So here it is not applicable. That's okay. So here you can see this is a small data set, and consider correct. I want to do some predictions here. I'm not going to take any big data set here. And based on this particular data, I want to predict. So the prediction, what I want to do, whether the person is going to purchase or not going to purchase. That's exactly I want to do. So if you get this particular data set, what should be your first approach? And one more thing that you already, those who are anyone other than that, anyone is new, I hope you already installed as well, because that's the reason I skipped the installation part as well, with the assumption that you already have the Jupyter notebook, etc. So if anyone is new, and if you want to install the software, you can go to this anaconda.com. This is the website you need to go. So you need to go to the products, individual edition, and you can just go to install Anaconda. And this is the installation by default. It is for Windows 10. And if you are using any previous version of Windows, so there is a folder from where you can install all the archive Anaconda versions, etc. So everything is there. So anyone want to install it, I'll just give this as well. So this is what I can give for the installations perspective. Again, the installation is going to be a simple step. So the first you need to choose your operating system, download it. then after the download the exe file. So this is the data. This is the data set which we have. So consider correct. So I have a data set, and here I just picked up only 10 records so that easily I can just explain it. So if you get a data set like this, so first of all, you can see that this is the purchase column. This is what I want to predict it. So till this point, you know that there are two things. One is my independent variable and the dependent variable. So the independent variables are the variables which I am used to do the prediction, and this is the dependent variable. So what I'm just going to predict here. So in our case, so we were predicting 0 and 1. So that is y. And here you can see that this is going to be x and this is going to be y here. Now, if you see the data set here, so there I'm not able to see data in all the cases here. So you are able to see there are some missing values are there. So obviously, correct, if you pass this data to the machine learning algorithms, so what will happen, you might be able to get the error. It will not work properly. So it is mandatory that, so we need to address the missing values. So the basic thing, if you want to address the missing value, so there are a couple of conditions specified. If there are no outlier there in the data, we can just go with the mean and we can address the missing value. So for example, in this case, there are no outlier there in the data. So the outlier is something like some of the values which are coming there in the very high level and which is there in the very lower level. So here there are no outlier there in the data. Obviously, I can use this average, that is 39.8. So that is going to be the average which I can use to fill this missing value. And consider scenario, if there are some outlier there in the data. So the outlier means, so maybe correct, I can see maybe an age like 150. Or maybe correct, another age maybe correct 120. So these are the ages correct. I won't be able to consider this as an outlier because this is actually a wrong data because there is no possibility to get the data, the age with this range. So obviously we need to correct this data. So that's what we need to do it. And consider scenario, if there are some age which is coming here, maybe at 60 or 65. So this is a valid age. So maybe correct a small firm and there would be some people. So maybe correct some, it's not the direct working people, maybe other people, they are at this particular age. So now what will happen if I try to use the mean to populate this average? The average, the mean, if you use it to populate this missing values, what you are able to see that one, the mean I'm just getting 43. The 43, obviously you can see that one, this is higher than the normal range. So in that case, we can go with the median to populate the missing values here. So that's what you need to do. So based on the data set, you need to think whether you want to go with the mean or median. So now consider this is the case. So here you can see that when the data is text. So if you just go with the text, I cannot apply the mean or median here. So what is approach we need to use here? So we need to go with the option that's the most frequent. So that's the approach we need to use it. The most frequent means correct the value which is going to repeat maximum. That is what we want to fill it here. So now consider scenario, if you have around 1000 records and out of that one, so maybe correct around 200 records, the column is empty. Or maybe correct around 300, 400 columns, it is empty. Obviously correct, this technique might not work here. So that is something we need to do it. And the normal guideline says that one, the missing value is around 15 or 10 to 15%, maybe you can just go with maximum. And other than that, correct, so the more values are not available. So obviously correct, it is not the right approach because, so based on some assumptions, we try to fill the data. So that's the thing we need to have in your mind. Next, in this case, if you want to fill the missing value, we'll check how many times each values are repeating it. So the France you can see here, it is repeating 1, 2, 3, 4 times the France is repeating. And the next value, if you see that one, that is Germany. So Germany, if you see that one, it is repeating 1, 2, 3 times it is going to repeat it here. And the next one, if you see that one, the Spain is going to repeat 1, 2. The 2 times it is going to repeat it. So what you can see that one, out of that one, the France is repeating maximum here. So that is equal to 4 times it is going to repeat it. So in that case, what we need to do, we need to populate this part with the France is repeating maximum. So that's what we normally do in case of the categorical data. So we need to use the most frequent option to fill the value. Or maybe correct, if you want to count manually, not the manually correct, by using the command, you can identify the maximum repeated value and we can just fill it out. So that's about the missing value treatment. Again, the next part, if I want to talk about, so whenever we are passing to the data to the machine learning algorithms, so I cannot pass any text data. So here, correct, I cannot pass any text data. So here you can see that on the country, we have the different names like France, Germany, etc. Then the purchase, we have the values like yes or no. So somehow, correct, I need to convert this to a number. So if I want to convert this to a particular number, so what is approach they will do? The most commonly used approach, it is called the label encoding. So there is a sklearn dot pre-processing the label encoder is there. So we can directly use that one. So there are other methods to do the label encoding. So one is we can use the cat codes, etc. But at this point, I am discussing about the label encoder. So whenever we try to use the label encoder to convert this to 0 or 1 or the numeric value, what the system will try to do, it will try to get the distinct value from here. What are the distinct values? We have the distinct values like France, Germany, and Spain. So these are the distinct values we have. System will alphabetically order them. So obviously, correct, this is alphabetically ordered. So after that, correct, it will try to give the number like 0, 1, 2. So that is what it will do as a part of label encoding. So now once we did the label encoding, so you can see that one, the country, wherever the France will be there, it will be represented as 0. This is what you're able to see. It will be represented as 0 here. This is what you can see. It is represented as 0. And now onwards, wherever the Germany is there, you can see that when it is represented as 1. So here again, it will be represented as 1. It will be represented as 1 here. So that's what you're able to see. It is represented as 1. And again, this France, it will be 0. Again, here the Spain, you can see that one, this will be represented as 2. This will be represented as 2. So this is the concept is called the label encoding. So now, correct, if I talk about another example, maybe correct, if I want to talk about the different sales in India. So we have this states like Maharashtra, MH. We can have the sales like 500. So maybe correct, we have Karnataka, KA. The sales may be around 400. So now, correct, I have another state. So maybe correct the TN. So if I can use maybe 500 here. So maybe again I can use GA. Maybe correct around 200 here. Now if I use MH here and I can use 400 here, then I can use KA here. So again, it is going to be 450, etc. So now if I want to do the label encoding, system will try to get the distinct value. What are the distinct values? We can get it here. It's equal to MH. Then it is going to be KA. Again, the TN. These are the distinct values. Then GA will be the distinct values what we have. So next step, correct, the system will alphabetically arrange them. So obviously KA will come. GA will come first. Then it is going to be KA. Then it's going to be MH. And again, it is going to be TN. And the system will try to give the number like 0, 1, 2, 3. So this is what we'll be able to get. So now, again, if I want to convert this one to label encoded value, so wherever the MH is coming, the corresponding value equal to 2. So it will be 2 here. This is again 2. Then the KA value, if you see that one, this is going to be 1. Again, this is equal to 1 here. Again, the GA, if you see that one, this is going to be 0. G8 is going to be 0 here. Then the TN, if you see that one, it is going to be 3 here. So this is what correct. You can see the label encoded value here. Now there is a problem with the label encoding. So the problem with the label encoding. So for example, in India, there are different states are there. And obviously correct, if you have the sales for all the states. So obviously correct, some of the states like TN or the West Bengal, they will have the numbers like 25, 29, 30, etc. That will be the numbers you will be able to get. But again, whenever the system will try to find the relationship, specifically correct the correlation of any of the concept, if the system will try to apply, system will have the feeling that, so whatever the high number, so that is better than the earlier number. So for example, the AP maybe have a number like 0 or 1. And obviously, correct, the West Bengal is having the value as 29 or 30, it will be there. So that's obviously, system will have the feeling that that is a very high number and the states are better than the other states. But that is not the real scenario, correct? All the states we need to have give the equal weight, because why this numbering has come? This numbering has come based on the name. So the name, based on the state name, the numbering has come. So to reduce that impact, so what the system will try to do, there is one more concept that is there, that is called the one-hot encoding. So the one-hot encoding is the technique where we'll try to split the data into different columns. So that means, correct, corresponding to each column, we are going to create, corresponding to each distinct value, we are going to create separate columns. So there will be one column for GA. So there will be one more column for KA and one more column for MH. Again, there is one more column for TN. So that's what you're able to see. And so that is what it is specified here. So now this is going to be the sales. So now how the data is going to represent it here. So this is what the data is getting represented here. This is equal to sales. And here you can see whenever correct the data. So this record belongs to which state? So this belongs to MH. So you can see that one, this will be 1 and all other values will be 0. So whenever correct we do the one-hot encoding, in one record, if you see that one, all these distinct values having either 0 or 1 value. The one shows that one, the data belongs to that particular state or the particular category. Again, the corresponding to KA. So here it will be 1 and all other places it will be 0. So here you can see that one, this will be 1. Again, this is what you're able to see. This will be 1. Again, MH. So this will be 1 here. And this is again KA. So this is again going to be 1 here. And all these values, you would be able to see 0 here. So that's what you're able to see here. So this is going to be 0. This is what you're able to see here. So this is the what? The 0, 0. So this is actually called the one-hot encoding. Another concept corrects we need to do wherever we are going to do the label encoding. We need to do the one-hot encoding. So now the next concept we need to talk about, that's called the standardization. So why do we need to standardize the data? So consider, correct, if I just try to plot a graph and I just want to keep some relation. So maybe correct the x-axis, I want to keep my experience, and the y-axis, correct, I want to keep my salary. So normally, correct, the experience is going to be 1, 2, 3. Assume that this is the years of experience. And the salary, if you see that one, here you will be able to see something like 20K. Then it will be 40K. Again, the salary equal to 60K. So this is what you are able to see here. So now consider, correct, if you want to find some relations, correct. So specifically, correct, if you want to find some relations between these 2 points. So any point, correct, if I want to find the distance between these 2 points, so what's the formula we can use it? Obviously, correct, we can use the formula x2 minus x1 and y2 minus y1 all square. So that's the formula we can use it. The formula equal to a square plus b square, that is equal to c square. So if I want to find the distance of this particular 2 points, it is going to be the square root of a square plus b square. So in this case, correct, if I want to apply that particular formula, so how it looks, my c is equal to square root of, what is my a square? What is my a here? The a is nothing but, so this is going to be the distance. So what is the distance you can see here? Consider this is 60K and this is equal to 20K. That is equal to 60 minus 20. It is going to be 40K here. So that is equal to y2 minus y1 square. That is equal to 40 square plus what you're able to see this distance. The distance is going to be 3 minus 1. So that is equal to 2. So 2 square is equal to 4. So now, correct, if we just add this, find this number, that is 40,000 square. And if you add 4 to that one, and if you take the square root, there is no difference as such. So that is almost same like 40,000 square root of 40,000. So that is almost same like 40,000 square. And if you are taking the square root. So in this case, correct, you can see that one, the value is not at all significant. So can I assume that when this experience doesn't have any relation to do the prediction of your salary. So obviously correct, this experience and the salary, it is related. So I cannot say that one, there is no relation. So why I'm not able to get such a relation here? Because this is a very high number and this is a very small number. So what we need to do the next step? So we need to do the next step is that we need to make this is in a common standard. So there are predominantly three approaches are there to make both X and Y there in the common standard. That is called the standardization. And the next one is called the normalization. And the third one is the min-max scalar. The standardization is working based on the formula. And this is what you're able to see the formula for the standardization. That's equal to X minus mean divided by standard deviation. And obviously correct, it is based on the standard deviation. And here the min-max scalar, this is the formula we can use it, X minus min of X divided by max minus min. The min-max scalar, whenever you apply here, you would be able to see that one, the smallest value there in the column will be 0 and the highest value in that column will be 1. So here correct, what is going to be the smallest salary? That is going to be 0 and the highest salary will be 0, 1 here. So that way correct, the min-max scalar is going to work. So now correct, if you talk about the normalizer here, it is going to happen based on the row wise. The smallest value in that particular row will be 0 and the highest value in that particular row will be 1. So that way it is going to work. But the standardization is going to work in a different way. So this is the example, if you can see the same example. So here correct, we just apply the standardization to this particular column. And these are the different values it got converted. So we find the average of the age we populated here, and this is what we are able to see the standardized value. And this is again the min-max value. You can see that on the small value in this particular column, that is 27 is 0, and the highest age in this particular column 50, that is 1, and all the values are arranged between 0 and 1. So that's a min-max scalar. Similarly, correct, if you see the salary column, this is a standardized value, and this is a min-max scalar value. So obviously correct, we no need to manually calculate it. So we can, as I specified today, we can import the standard scalar and the min-max scalar, and we can use it here. So now if we talk about the multicollinearity, so the multicollinearity is another concept. So whenever we try to do the prediction, so here correct, again, I'll just take the experience of your age and the years of experience. So specifically correct, I want to predict my salary. So if I want to predict my salary, so this is what you are able to see, there will be experience will be there and you have the age. These are the two columns which we are going to consider. So based on that correct, if you want to predict your salary, so maybe correct, whenever you try to join it here, you can see that your salary equal to 50K. So consider this is the salary and your experience equal to maybe 1 year and your age equal to 30. So as you know that one, the formula corresponding to that, again correct, as I specified, y equal to m1 x1 plus m2 x2 etc. There will be the coefficients associated with that one. So consider I have two columns here, there will be two coefficients. So consider correct, my experience coefficient equal to 5000 here. And my age coefficient equal to 3000 here. So what this coefficient means that one, whenever there is a single unit change in your experience, so that means correct, your experience is increased by 1 year, keeping all other variables constant. So that means correct, I have this particular variable which is constant. So but the real scenario correct, so that is what, so whenever you are increasing your experience by 1 year, keeping your age is constant, you are supposed to get 5000 increase in your salary. So that's the meaning of this one. So now if you apply that one, and obviously correct, you just increase your experience by 1 year. So it becomes 2 years right now. What you're supposed to get, you're supposed to get around 55,000 salary. So that's what you're supposed to get, 5,000 increase in your salary. But what it's really going to happen, indirectly your age is also getting increased. Obviously correct, I cannot keep this as constant. Obviously correct, the age will become 31 here. So whenever the age becomes 31 here, so you are able to get the coefficient corresponding to the age also here. So altogether, you are going to get 8,000 increase in your salary. So that is what correct, to a certain extent, you are going to get an inflated result. So this is what the correlation there. And this is correct. So both the variables are correlated. So here, if you see that one, this is my x1, this is my x2. Both of them are correlated here, and it is causing an inflated result. So that's an issue with the multicollinearity, and that is what it is explained here. So the marginal effect in salary of one additional year holding the other variables constant. But here that is not the case. So whenever you increase it, other variables are getting increased. So now correct, if I want to check the multicollinearity, etc. So there are two methods which we can use it. One is the correlation coefficient. So that's what we can use it. And there is one more check is there, that is called the VIF. The VIF is nothing but the variance inflation factor. And this is the formula we can use it. So normally correct, the VIF value, the threshold is going to be 5. And if you are getting the VIF value greater than 5, so normally correct, we'll assume that when there is a multicollinearity existing. Again, if you see about the correlation coefficient, so here correct, I have three variables. So here correct, I have the data set. I want to use this x1, x2, x3. These are the three variables. And based on that correct, I want to predict it. So now if you check my correlation matrix, this is what you are able to see x1 and x1, because there is a 100% correlation will be there. And x2 and x1, you can see that when this the correlation is very close to 1. So that shows that when there is a collinearity existing between x2 and x1. That is one method by using the correlation matrix. So similarly, correct, if you see the x3, you are able to see that when this is somewhere equally distributed, somewhere in the middle, you are not able. So here, correct, the x3 is not related to x1 or x2. But here you are able to see there is a correlation. So similar to that, there is one more technique available that is called the variance inflation factor. That's a VIF check. So here also, correct, we try to check the correlation here, where the x1 that is related to x2 and x3, and we will do the VIF checks here. So there you can see that one, there are two cases. Whenever I check between x3, x1 and x2, there are no correlation. That's what you are able to see. Again, whenever I check between x1 to x2 and x3, you are getting a VIF value equal to 21.64. So we are able to see that when there is a correlation here. So wherever correct, where the value is greater than 5, we'll assume that one there is a multicollinearity existing. And what normally we do, we can exclude such variables. So wherever correct, we can write a for loop and we can exclude such variables wherever there is a high VIF value is present. And there are some of the techniques, so we can do the multicollinearity. The first thing is that correct, wherever there is a multicollinearity existing, we can remove such columns wherever there is a multicollinearity is existing. So one out of that one, we'll remove one out of that one. Again, the second one is that, so we will not consider it as a separate variable. So both the variables correct will consist a single variable and we'll have the correlations or coefficients corresponds to that. Again, the third one, what we will do, we'll get the coefficients and that coefficients will be equally going to distribute it. So that is what it's called the multicollinearity concept. So as much as possible, so it is better, we need to avoid the multicollinearity there in the data.
All right, let's test your knowledge. Here's a question for you. Which Python library is primarily used for data manipulation and analysis? Option A, NumPy. Option B, Matplotlib. Option C, Pandas. Option D, scikit-learn. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, want to master data analytics and automation? Our Advanced Data Analytics with Python course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about data analytics and automation with Python. It's like a toolbox for handling data, from analyzing trends to automating tasks. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is really affordable. Ready to become a data analytics pro? Sign up on our page now. And for more info, check out ZaranTech's website.
Logistical regression algorithm, so which we try to do the prediction. So I'll just revise it, let others join in between. So I'll just quickly go through that yesterday's example. So we will discuss on the logistical regression again. So the first of all, So those are not clear, you can just interrupt me, no problem. So the first thing what we need to do, we need to import all the required libraries. So these are the different libraries which we were using. So the first one was that NumPy, Pandas, Matplotlib, Seaborn. Then we were using OS. Then we were using confusion metrics. The confusion metrics is used to check the accuracy of the model. Then we were using the logistical regression. And after that, we were using the train test split. So this is actually used to split the data between the training and the test data set. And this is going to be the random split. So the NumPy is used whenever we want to keep the data in the form of an array. The pandas is used to read the data, and whatever the data will read from the pandas, it's called the data frame. And the data will be kept there in the form of a table that is with the rows and columns. Then Matplotlib is used to plot the graph. Again, Seaborn is another tool. So through which if you want to plot some advanced plot like heat map, pair plot, etc. If you want to plot it, we can use Seaborn. So these are the different libraries we are importing here right now. So it is not necessary that you need to import all the libraries together. So whenever it's required, you can just import. So that's also you can do it. So this was the data set we were using yesterday. So based on the age, estimated salary, so we want to predict whether the person is going to purchase the product or not going to purchase. So that's what we want to use it. So now if I just go further, the next thing that I want to load this particular data set, and I just update my directory. So specifically, correct, I kept this is my default directory. And after that, I was loading this particular file. So if you want to load the file directly, we can give the full path here. So there is no problem. So here I made 2 steps. So first thing what I did, I made this folder as the default folder. And after that, I'm just loading the data here. So if you see the data, there are 400 rows and 5 columns here. And if first thing is we need to split the data between independent and the dependent variable. So based on the age and the estimated salary, we want to predict whether the person is going to purchase or not going to purchase. So that's what we are trying to do here. So the next thing, so we need to create X. X is my independent variable. And I just pick 2 columns from here. So that is equal to age and estimated salary. And that's what I'm just creating. So these are the 2 columns which I'm using here. Age and the estimated salary. So next what I will do, I'll just create my Y. Y is the variable which I want to use. So that is going to be the last column which I want to use. So I'm directly giving the column name. So even if correct, if you want, you can give the column name. And here I'm just giving the column position. So the position I'm just giving it as 2. Or even if correct, if you want to give this as the last column, I can give the -1. So whatever you want, you can just give it. Or even if correct, if you want, you can directly give the column name as well. So which is convenient, you can give. And once I get the data, again, if you want to plot the graph any point, so specifically correct, if you want to have a look how the data looks, etc., I can just plot the graph. I can use plt.scatter and the df1, the age and the estimated salary, and just plotting a graph here. So here you can see that when the data is fully scattered in this data set. Again, I'll just do a feature scaling here. So this is the step. So we need to ensure that when the data is there in the same standard. So here you can see that when this is 2-digit number, and this is again a 5 or 6-digit number. To ensure that when the data is in the same standard, I'm just doing the standardization here. So you can see that when all the data is arranged between -2 to +2 range. So this is the formula what we are using it. So based on the standard deviation, the data is getting calculated, all the recalculated here. So now we will do the train test split here. And we are taking around 20% of the data is my training the test data set. Remaining 80% will be the training data set. And after that, we are going to create the model. So we are just going to create the log model here. So we are going to create the logistical regression model here. So that's what you're able to see. So once the model is created, if you want, you can do the prediction here. So based on the test data, I have done the prediction here. So now correct, if you want, you can see that one. Now there is a mismatch happened there in the data. I need to consider this column as my Y variable, the last column. So I'll just go ahead and take it here. So this is equal to column number 0, 1, 2, 3, 4. I need to consider my fourth column here. So this is what you're able to see. I'll just repeat it. And this is what you're able to see the predictor record. So now currently we are doing the prediction for the test data set. Try to do the prediction for all the if I wipe it, you're able to see the prediction for all the data here. So now the later point, if you want to check the accuracy, so you can do that one. So if you want to check the accuracy, you can use confusion matrix. So here, correct, whenever you're using the confusion matrix, so you need to ensure that one you are giving the same size. So here, my wipe rate based on that. So here you can see that when my wipe rate is having all the records. So it has done the prediction for all the data set. But whenever I'm trying to use the confusion matrix, I use the white test here. So I'm just getting an error here. The reason is that the inconsistent number of samples. So one of the variable which I'm passing around 80 records, and the other variable which I'm passing, there are around 400 records. So that's the reason I'm getting this error. So obviously correct, I did the prediction for the complete X variable. So that means I did the prediction for all the 400 variables. So whenever I'm going to use the confusion matrix, I should not pass Y test here. I need to pass the complete Y here. So this is what you're able to see. Again, here, if you want to check the accuracy, so we need to add all the diagonal values divided by the total number of records. So that's exactly we need to do. So this is the part we have done. Again, so now correct, I have X here. Again, I have Y. Then I have did the prediction. So now if you see that one, all these variables are separate variables. So any point, if you want to consolidate them to a single data frame, etc. So what we can do, we can use the data frame, the concatenate option. So I can just concatenate everything together. So that's what you're able to see. So here, the first thing, if I want to concatenate by using the data frame, so my wipe rate, the variable which I have predicted here, this is an array. So I need to convert this to a data frame, because if I want to convert by using the data frame, I can convert this to a data frame here right now. So that's the step we try to do. We're just converting this particular column wipe rate to a data frame. So that's what we have given here. And after that, we are just concatenating it. So my original data set, if you see that one, that is df1. And to that one, we are just concatenating the predicted value here. And if you are using the concatenation, it need to add an additional column. So that means it need to do the concatenation basis on the axis equal to 1. So if I'm not giving this option here, what will happen? The wipe rate details, so that will come below the df1. So this is something like a union. So if I want to do the column addition, so obviously correct, this is one of the parameter we need to specify, axis equal to 1. And if I execute this, so you would be able to see my original data set, and this is my actual data, and this is my predicted data. And you can do the side-by-side comparison here. So next, again, if I want to do any further analysis, and I want to export this data to an Excel sheet, etc. So this is a command which I can use it, to_Excel. Or if I want to update to upload to a CSV file, I can use to_CSV, etc. So if I want to read, I can use read CSV, read Excel, etc. And if I want to write to an Excel CSV, etc., I need to use to_Excel. And here I need to specify the data frame dot. But while reading, we are reading pandas dot. But here we are giving the data frame dot to Excel. So we can give the complete path. And if you're not giving the complete path, in your default directory, which I set there in the top, os.change directory, this is the default directory, there the file is getting created. So now since I have specified a different folder, that's the place the file is getting created. So any further analysis, if you want, you can open the Excel file, or maybe correct if you want to share with someone, we can do that. So this is the file which I exported right now. And here I have the complete data set with the predicted value. So you are able to get it here. So any questions on this? So any steps which you are not clear? So I hope you are getting the recordings as well as the data set for you to practice it, including the code. So if there are no questions, I'll go to the next algorithm. So the next algorithm is called the KNN. And the KNN is again, it is having both regression as well as classification. The KNN is going to work. So if I just keep a data set here, correct, you have set of data here. And if I just group them together, so this is what you're able to see. So this is going to be one group, and this is going to be the other group of data. So now the KNN is going to work. So k nearest neighbors. If a new data point is going to come here, so there is one more parameter we need to specify, k. So k, what we are going to specify, number of nearby points we need to check. So number of points it need to check here. So consider scenario if k equal to 1. So consider scenario if k equal to 1. What will check? It will check where is the nearest point. So consider that this is the nearest point. So what will happen? This point also will be considered as part of this group. So consider this is A and this is B. Whenever a new point comes here, whenever k equal to 1, it will check the nearest point belongs to which group. So if the nearest point belongs to this particular group, you can see that this point is getting assigned to this particular group. So consider the point is coming here. So where is the nearest point? The nearest point is from this group. So obviously correct, this point is part of this particular cluster. So the group B. So now whenever the k equal to 3, or maybe correct if you consider k equal to 5, and it will check a point here, and it is going to check 5 nearby points. So you can see that when this is point number 1, this is the nearest one. So maybe correct, this will be the second. Again, this is the third, this is the fourth one, and you are able to see that when this is the fifth one. Out of 5 near points, you would be able to see that when 3 belongs to the group A, obviously correct, this point will be part of this group, the group A. So out of 5, 3 is part of this particular group. So obviously this point will be part of group A here. So consider scenario, in this point, if k equal to 1, and whenever this is the nearest point, so this is having the shortest distance, and whenever correct the k equal to 1, obviously correct, this is going to be part of B. So what it means by that one, whenever we change the k value, the number of nearby points we need to check, so there will be slight difference there in the result. So maybe correct, whenever you give the k equal to 1, you will get a different accuracy. For example, correct, the points which is coming here, there is no change. So consider a point which is here. So whenever k equal to 1, obviously correct, this will be part of this. Again, whenever k equal to 2, obviously this will be part of this group. 3, 4, etc. There won't be no difference. But some of the points which is somewhere that the border or it is coming. So such point. So that is going to be the problem with the K. So we need KNN classifier. So any questions on this? What is KNN? So these are examples specified for KNN. And here you can see that when I have 2 sets of data points, one belongs to class A and another set of points belongs to class B. So whenever k equal to 3, it is going to check 3 nearby points. So out of these 3 nearby points, you can see that one 2 belongs to class B. So obviously correct, this point will be part of this particular class. Again, the next example is that whenever k equal to 6, so you can see that one out of 6 points, 6 nearby points, the 4 points belongs to this particular class, the class A. So that means this star will be part of class A. So that's what you can see whenever the k changes, the values are getting changed here. So how the distance is going to calculate it? So the distance between the 2 points, it is calculated by using the distance formula, and the formula which it is uses here is the Euclidean distance. The Euclidean distance, it is based on the Pythagoras theorem. And this is what you are able to see. So this is again the distance between these 2 points. And that is equal to the square of this distance. That is 5 square equal to 4 square plus 3 square. And obviously this distance equal to square root of this distance plus this distance. So that's what you can see here. If you see here, this is the point, the x-axis, y-axis, if you see this is 1, 1. And here if you see the point equal to the x-axis point, you can see that this is 5, y-axis point equal to 4, and the distance is going to be x2 minus x1. So what is x2 here? That is 5, and the x1 equal to 1. So that is 5 minus 1. That is equal to 4 square plus y2 minus y1. So what is my y2 here? 4 minus 1. So that is equal to 4 minus 1 square. That is equal to 3 square. So that is 16 plus 9, 25. Square root of 25, that is 5. That's the distance you are able to get. So this is called the Euclidean distance. And similar to that, there is one more distance formula is there. That's the Manhattan distance. And here we'll take the absolute distance. So here, if you want to find the distance, it is going to be x2 minus x1, and we'll take the absolute, because there might be chance that it will be negative as well. So we don't want to keep that distance as negative. So that's the reason we are taking the absolute value here. So that is this point equal to 5, 5 minus 1 equal to 4, absolute of 4 plus this is equal to absolute of 3, the 7 is going to be the distance. So that's what you're able to see.
Yeah, but if you do the two distances, like one is coming out to be 5 as a coming 7.
So these are the two different methods. So the two different formulas are used. So there are different methods are there. Euclidean distance, Manhattan distance, there is a cosine distance, etc. will be there. So the cosine distance, if you see that one, so we are going to take the cos angle. So obviously, correct, you need to specify what will be the distance formula we want to use it.
Yeah, but actually, I think it is Euclidean distance which is correct, right? Rest, I don't know when we will use it.
Based on that, correct, it may vary as well. So that is a mathematical concept. Again, correct, there is one more distance formula that is called, so for example, right, cosine distance. So if you want to find the distance, the cosine distance here, the distance between, obviously, correct, this is going to be the cos angle of this value. So this angle equal to 30, if it is coming from here. If there are 2 points are there, and there is another distance which we normally use, so that is equal to cos 30 here. So for example, this angle equal to 30. So if you see that even the cosine distance, it will be ranging from -1, 0, 1, -1, 0. So that is going to be the range. So now I'll just go ahead and take one example here. So how it is going to work? So consider scenario. So what they specified there. So they just want to order a t-shirt for a team, consider scenario. So we have the weights, we have the height and the weight of all the team members is there. Again, one of the team member is not present on that day. So what normally we do? So we'll have an assumption, correct, who is having the closest height and the weight similar to that person. We are going to do the same t-shirt for him. So this is something like that. So here you can see that there's a height, there's a weight, and we have the details about the t-shirt which they ordered. So these are the people they ordered the medium t-shirt. These are the people they ordered the large t-shirt. And the person, correct, we want to fit into. So he's having a height of 161 and the weight equal to 61. So where he will come here in this particular ladder? So he will be somewhere here. So between 61 and 63, that's the place he will be there. And the weight may be around 61. So that's what he will be able to come. So now if I want to apply the KNN algorithm, so how it is going to work? It will find the distance to all other points. So from this particular point where it is coming, it will find the distance to all other points, and that's what it is specified, the Euclidean distance. And whenever you are using the Euclidean distance, the next step is that I consider my k equal to 5. It will find 5 shortest distances. So obviously the shortest distance here, so this is what you can see, this is 1. The 1.41, this is the first one. and this is going to be the second one. This is going to be the third one. So obviously, correct. This is first, second, third, fourth, and there are 3-4 numbers starting with 3, and out of that, this is the shortest one. So this is the smallest here, and this is going to be the 5th distance. So we have 5 distances here. Since correct, I selected 5 because my k equal to 5. I'm choosing 5 distances here, and out of that one, what I will do, I'll just check out of 5 how many of belongs to M and how many of belongs to L. So out of 5, you can see that one, all 4 belongs to category M and only 1 belongs to category L. So that obviously we are just going to assign the medium t-shirt for this person because out of 5, 4 belongs to category M. So that way the KNN is going to work. It will check the nearby points, the specified nearby points, and out of that one which belongs to the maximum category. So that way the assignment is going to happen. So if you have already done yesterday's exercise, so you can just open the same notebook. You can execute because I'm using the same data set so that you can skip many of the initial steps. I'll show you where there is a difference. I'll execute from the top to bottom, but you can just open the same Excel, same notebook, and you can just run it. So that correct some of the initial steps you can skip. So the first step is going to be, I can just import all the required libraries. So these are the different libraries which I have imported here. Again, after that, I want to load the data set. Obviously, correct, I'm just loading it. Again, what I will do, I'll just create my X and Y. X is my dependent variable. No, X is my independent variable. I just get these 2 columns, the age and estimated salary. So that's what you're able to see. So obviously, correct, we need to check the basic checks, any data set if you're doing it. So you need to take care of the label encoding, one-hot encoding. So you need to check for the null values, etc. So if there is there in the data set, but here I'm just skipping that one. So I know that one, there is no null values here. The total number of records equal to 400. And this is what we have done here. So next, what is going to be the next step? I'll do the standardization here. So before that one, I'll just create Y. And quickly correct, I'll just view the data as well here. So if I want, I can just quickly view the data. So this is what you're able to see. I can just view the data here. So do you also want to do this exercise in parallel with me? If I want correct, I can just wait so that you will get good practice. I'm okay if you want to try right now. I know that the steps are repeating. Either way is fine. Do I need to wait or can I proceed it? At least correct the initial 1 or 2 exercises you do in parallel with me. So these are the different libraries which I am importing it right now. And I hope you have the data set. This is the same data set which I shared. Just copy the script in a notepad as well. So this should go to first cell, second cell, third cell, and fourth cell. Okay. So those who are not clear about the scatter plot, I'll explain. So how the scatter plot is getting created. So I know that there are many statements are here. I'll start with the simple here. First of all, if I just pull this statement. So the first line is related to one set of data. So specifically correct, my scatter plot is created based on my Y variable. So my Y variable, there are 2 possibilities are there, either 0 or 1. So what I'm just trying to predict here, there are 2 values are there. So my scatter plot is created based on 0 and 1. So I'm just creating one scatter plot. So that's what you're able to see, my first scatter plot, which I'm creating for my category. The category equal to 0. So that is what we try to do. Again, the second scatter plot. So we are just going to create wherever the category equal to 1. Again, I just kept both there in the same line. So what it is going to be an overlapping graph. So obviously, correct, if you give matplotlibs two are there in the same line, it is going to be in overlapping. So any point, if you want to split it and if you want to create it separately, we need to use a subplot. Now here you can see this is a label which is specified. So the label which is specified here, and the label is not coming. So if the label is not coming, I can use one more command, plt dot. So here, correct, you can see that whenever I specify plt dot legend, so you are able to see that when the label is coming. So by default, you are able to see the label is coming there in the bottom left. So if you want to position the label in different places, so we can position it. So you can specify the position. You can just go ahead and you can select the parameters accordingly, and we can specify where we want to keep it. So that option is there. So that's about the label. By default, it is coming. And whatever we are just creating the circle, so you want to give that in the red color. So the color what we specified as R, the R is corresponding to the red. So if I want to create a scattered plot, so the basic thing, correct, all these are the additional parameters we are specifying. The basic things what we need to do here, only this is the statement we need to specify. I need to specify my XY coordinate. So that's enough. So if I just give here, I'm able to get the scattered plot here. And we are getting with the default color. So this is the default color it is coming. And the size, correct, the size is also going to be the default size. But in my case, what I did, I give two parameters. One is the color, is the red color. And if I want to give any color, you can just give the full name. If you want, you can just give the red. Again, you can just give blue, etc. The colors you can specify, or you can directly give the first character, you can just specify, you will get the color. So that way there are different color combinations you can specify. And if I want to get a black, you need to specify K, because the B is for blue. So you need to specify black, and obviously white, if you want, you need to specify W. So these are the different color combinations available. So you can just refer the matplotlib document, and there I'll give the link. So from where you'll get all the color patterns. So that is what the color patterns we can specify. This is the label. And the next parameter, what we are specifying here, this is the size of this circle here. So the circles which are drawing here, what is the size? And if you want to reduce the size, you can just give it 50. You are able to see a smaller size here. And again, if you want, you can just give a bigger size. The size will be bigger. And if you're not specifying anything, by default parameter, it will use it. So that's a parameter. So now if I come to these two variables, so you might confuse what it is. So the first thing what I'm just trying to do here, this is the part I just try to get the X coordinate. So whenever, correct, I want to plot a scattered plot, I need to have an X coordinate and I need to have a Y coordinate. So normally I just specify X and Y, but here what I need to have the X coordinate and the Y coordinate. So specifically, correct, I need to have two coordinates. And here I'm just creating the Y coordinate, means the X is going to be the age and the Y is nothing but this is going to be the second parameter which I'm specifying here. That is nothing but my salary. So that is what I want to use it. So here, if I just specify X comma Y, so here, correct, I'll specify X of 0. That will be considered the first column, that will be my X coordinate. And here, correct, if I specify X of 1, it will consider the second column there in the X. You can see that when this is my X dot. Okay, X is an array. I cannot use the head here. So this is the first column, the age and the salary here. So whenever I use X of 0, it is going to extract my first column here. X is an array. It is going to extract the first column here. So similarly, correct, whenever I specify Y of X of 1, it is going to extract the second one. So that's what. So this is going to be the XY coordinate. That's what I am specifying. So this is the coordinate 42. And what is going to be the Y value? This is will be the Y value. And the next parameter, what I need to specify, I need to get that one corresponding to Y value equal to 0. What is my Y here? Y, you are able to see my dependent variable. So this is my Y. So wherever my Y value equal to 0, it will try to get the X coordinates. So that's what you are able to see as part of this statement. So that's exactly going to happen here. So if I execute this statement here, this is what you would be able to get. So if I execute So I'll just execute it here. So this is what you're able to get the XY coordinates here. So wherever correct the value equal to 1. So now if I just go and open my document here, so my data set, and here if I just filter for my value equal to 1, and here correct, I'm just getting the XY coordinates. So this is the X coordinate 59. So my Y coordinate equal to 1,48,335. So that is equal to X coordinate equal to 59. Y coordinate equal to 1,48,335. So next X coordinate equal to 51. So wherever the category equal to 1, 51, and this is the Y coordinate. So next is equal to 55, and this is going to be the Y coordinate. So that's what you're able to get it here. So my first line, it is used to get all the XY coordinate of one category. So that is what correct. I am specifying the category here. So wherever the Y value equal to 1, so whenever I give this condition, whenever Y value equal to 1, it will be true or false. So that should be able to see. Whenever I give this condition Y equal to true or false, the entire data set will be categorized into true or false. And whenever I give X of Y equal to 1, so that means correct, it need to get all the 0th column wherever the Y value equal to 1. So 1 is nothing but wherever. So this is going to give you categorize the data into true or false. It will give you the result for all the trues. So all the true cases, it is going to give you the first column here. So that is X. So that's what it is going to happen. Whenever I use X equal to Y, so this is what the classification is going to happen. And this is the first true correct. So that is what you will be able to get the X of 0th column wherever this is equal to true. So that's what you are able to get it here. So similarly correct, I'm just specifying for 1. So now correct, if I want to get the XY coordinates for the 0th category. So if I want to get it for the 0th category, I'll just change this to wherever the X equal to 0, get the first column, that's the age. Wherever X equal to 0, get the second column, that is my salary here. So that's what you're able to see. So whenever I give this one, I'm able to get the XY coordinates here. This is equal to 0, and the X coordinate is going to be 42, and the next coordinate is going to be 1,21,000. And based on then correct, the graph is getting created. So actually correct, two scatter plot is creating. One scatter plot is created by using this combination, XY combination. And another scatter plot is creating by using this XY combination here. Is it clear how the scatter plot is getting created? I know that maybe we are using multiple equal to etc. may be confusing. So then I'll go to the next statement. So the next thing is we need to standardize the data. So that's the next step we need to do. So we need to standardize the data. Which is the data I want to standardize? I want to standardize my X variable. So what is my X? X is having 2 columns. Obviously, correct, we won't do the standardization or the normalization for the Y. So there are multiple variables are there. In this case, there are 2 variables. I want to standardize this X. So the first thing, so you can execute in parallel, so no problem. So I need to import sklearn.preprocessing, import standard scalar. And after that, what I need to do, I need to create one variable. And just creating one variable standard scalar equal to, I'll just call the standard scalar, open and close bracket. And the next time, just creating one more variable, sc equal to, or maybe correct, I can directly update the X variable itself. I can create the model and update the data. I can use sc.fit and transform. So this is what I can specify. And what I want to transform, I want to transform my X data. I want to standardize it. That's what I can specify here. And I'm just going to print X here. So this is correct. I have transformed the X right now. So this is what I have done right now. So why there is no changes required, why we can keep as it is. So now what will be the next step I need to do? I need to do the train test split. So you can see that one, I have already imported the train test split. So you now need to import it again. So I can just use this train test split and I can do the splitting here. So I'll use the train test split. And obviously, correct, I need to pass the parameter. Which are the variables I want to do the splitting? I want to split my X and Y. So that's what I need to specify. And the X need to be splitted into 2, Y need to be splitted into 2. So obviously, correct, to store the X splitted value, I need to create 2 variables. And just giving the variables as X underscore train. And the Y need to be splitted. I can just, no, X underscore train and X underscore test. So first, correct, I need to give the set of variables which is related to X. You can give any variable. So to understand that one, I just give it as X train, but you are free to give any name. And similarly, correct Y, I'm just giving Y underscore train, comma, Y underscore test here. So this is what you are able to give. And just giving the train test split. So it has done the train test split. So totally correct, there are 4 variables are created, X train, X test, Y train, and the Y test. So these are the 4 variables created. So the total number of records 400. And to ensure that this is properly splitted, I can just display the shape. The shape is number of rows and columns I will be able to get. So the split percentage is 25%. The default split percentage is 25%. So that's the reason the training data set, you are getting 300 records, and the remaining 25% will be there in the test data set. So that's what you can see, X test dot shape. You are able to get it here, remaining 100 records. So now if I want to change this split, so any of the parameters, correct, if you are not sure, you can just go ahead and you can press the shift tab. You will be able to get all the parameters here. And here I can specify the test size. So what is going to be the test size here? So I don't want to go with the default parameter. So I can just go with the test size. And maybe, correct, I want to keep it as 20% here. So now you can see that when 320 records will be the training, and the test, you can see that it is going to be the 80 records here. So I have done my training train test split. So next, what I can do, I can use my algorithm. So if I want to use my algorithm, so I need to import it here, and I want to use the neighbors. So sklearn.neighbors. So this is what I want to import it here. So this is what I can just import it, sklearn.neighbors, import k neighbors classifier. And I can create one variable KNN, and I can just give the parameter here, and I'll just give an open and close bracket. Then obviously, correct. So here I'm not going to use the fit and transform. I'll do the fit here. So I want to use KNN.fit. I'll be using KNN.fit. And that is a place, correct, we are creating the model. How do I need to create the model? What are the data I want to pass it? I want to pass my training data set here. That's equal to X train, comma, Y train here. So these are the X and Y combination which I want to pass to the variable to create the model. And after that, correct, I just display KNN here. So my model is ready. So now I want to do the prediction. So if I want to do the prediction, I can specify KNN dot predict. So predict based on what? Based on my test data set, I want to do the prediction. So which is my test data set? So this is the test data set, X underscore test. That's what I would be able to predict it here. And the result I want to store to variable. You can give any variable name, Y underscore pred. And I'm just displaying Y underscore pred here. So this is what you are able to see. It has done the prediction. So one difference you can see that whenever I did the logistical regression, all the Y pred value was 0. But here you are able to see that one, it is predicting many of the records as 0 and 1. So now, correct, another part we need to check what is the accuracy. So that's an important part. So that is going to give an idea about the accuracy. So what is the percentage, the accuracy, how accurate the predictions. So to get the accuracy, I can use accuracy score. Confusion matrix also we can use it. The accuracy score is directly going to give you the accuracy. So to use that one, I need to use from sklearn.metrics import accuracy score, and I need to use that. So this is what you can use here, sklearn.metrics import accuracy score. And how I can calculate the accuracy? I want to compare the actual and the predicted data. So where is my actual data? So my actual value will be there in the y_test. So this is a variable which will have the actual data, and y_pred correct, it is having the predicted data here. Now, if I want to compare these two variables and I want to check the accuracy, I can use it accuracy score, and I can just specify y_pred, and you can see that even I can specify y_test as well here. So you can see that one I am getting around 53% of accuracy. So here you can see that one, even though it is predicting the category of 0 and 1, compared to the earlier case, the logistical regression, you are seeing that when the accuracy is very less. The accuracy is very less. So what could be the reason? So whatever the system tried to do the prediction here, the predictions are wrong. So that's what correct. The more predictions are wrong here. So that's the reason. So here you are able to see this prediction is matching, but here actually this is 1, but it is predicted as 0 here. The predictions are not matching. So here again, it is 1, it is matching, but here you would be able to see that when the predictions are not matching. So many cases, the predictions are not matching. So here and all, it will be 1, 1, here it is 0, 0. So that's the reason the accuracy has gone down. I hope you had already completed up to scattered plot, and these are the next set of statements. So now I'll just print one more parameter that's called the confusion matrix. So the confusion matrix, so one is the accuracy. It is going to give you the accuracy. And here you can see that on the confusion matrix is going to give an idea how many values are properly classified and how many are misclassified. So here the values which are coming there in the diagonal. So this is properly classified, and these are the values misclassified. Obviously corresponding to category 0, there are 16 records got misclassified. At the category 1, you are able to see there are 21 records got misclassified. If you need to get a good accuracy, the maximum value should come in these diagonal values, and all these values should be very close to 0. Then only you will get the good accuracy. So now the next question, is there a way to increase the accuracy? So we talked about something like a KNN, number of nearby points, we can check it. Again, we talk about something like the Euclidean distance, Manhattan distance, etc. Is there a way to increase the accuracy with any of these parameters? So we already discussed there are different K values, we can try it. Again, we can try with the distance formulas, etc. So if I want to try any such things, so that is what correct. So we need to specify within the bracket. So here correct. So whatever I created right now, it is created with the default parameters. And there are other parameters there which I can use it. I'm not going to use all of them right now. At least 1 or 2 parameters I will use it here. So by default, you can see that one n neighbors. The n neighbors is the parameter which is going to check how many nearby points it need to check. So by default, it is going to check 5 nearby points and it is trying to do the prediction. Again, it is using the distance formula that is called P2. The P2 is the Euclidean distance. So I'll just try to use that parameters right now. And I'll try to make some changes there in my n neighbors right now. So maybe correct, I'll just give n neighbors maybe a different value. So maybe correct, I'll try to give 2. I don't want to check 5 nearby points, and I want to check 2 nearby points, and I want to take the prediction here right now. So maybe correct another parameter which I'll consider right now. So we talked about the distance, right? So the distance is decided by this P. So if you just go below the description, so this is what you are able to see. The P, that's a default, P equal to 2, that's a default, and that is a Euclidean distance. And if I want to try with another distance, that's a Manhattan distance, I need to give P equal to 1. So that's what obviously you need to do. Again, for that one, I need to use one more parameter that's called the metric. And I will use that as well. If you want correct, you can just skip. So by default, anyway, it is Minkowski. So I just give P as 2 here. The P is 2 equal to Euclidean distance, and 1 is the Manhattan distance. That's what I'm just using it right now. Now, I've made some changes in my default parameters, and I'm creating the model right now. I created the model with P equal to 2. No, the N neighbors equal to 2 and P equal to 2 here. So now I'll try to do the same operations here right now. So let's see any difference is there. This is what you can see. So here I can see that when the number of ones was reduced. So here obviously correct more ones were there, but here it is reduced. That's a look I can have. So now if I want to see the original data, I can just specify y underscore test. So you are able to see the test data set. Again, the best thing correct, if I want to compare and if I want to get the accuracy, obviously correct, I need to go with the accuracy score here. I can rightly use my accuracy score here. So by comparing the y test and the y pred here. So now you are able to see that there is a slight increase in my accuracy. Earlier it was around 53. So now you are able to see 61% here. And I'll just quickly print my confusion matrix as well. Any change there in the numbers here. So here you can see that when the number of numbers might reduced here and the numbers might have increased here. So the earlier this was 36, that was increased to 47. So that's what you're able to see. So you need to see the sum of these two numbers, whether it's increasing or not. So this is 47 plus 2, that's 49 here. But here if you see that one 36 plus 7, that is 43. So obviously correct, the sum got increased. Because of sum got increased, you can see that when the accuracy got increased. And this is the value, the sum of this value should have reduced as well. So this is 31. But here if you see that one, it is higher than that. So that way, you can see that when the accuracy got increased. So now correct, instead of giving it as n neighbors equal to 2, so let's try with 1, what is really going to happen. So if I just give n equal to 1, again, I did the y prediction here. There are some changes might have happened. I display the y test. Again, here correct, I just try to print. So there are no difference as such. Again, correct, it is coming down. So now I'll just quickly give 3 here. Here, correct, whenever I try with the 3, I'm getting a better accuracy, 65. So that way, correct, so we need to identify which is the best parameter. So there are different methods where we can give the parameters. The quick thing, correct, so maybe we can create a for loop and we can give the parameter combination. And we can pick the best parameter which is having the maximum accuracy. Or there are other options, are there something like a grid search CV, random search CV, etc. That I'll talk later. So that is what correct. I made some changes in my n neighbors. You can see that one. The same data set, even correct, I didn't do the trend split separately or anything. Using the same data set, you are able to see the accuracies changing. So now I want to try with the other distance formula, the Manhattan distance. I can just give it just 1 here. You will be able to see here. And if I just print my y test and my accuracy score, again, it actually comes down whenever I use the Manhattan distance here. So any questions? The same data script, you can use it, and 2 parameters you can specify. And the list of the parameters, if you want to get it, you can just press the shift tab here and you will be able to get there in the drop down. So if you're not specifying any parameter, it will go with the uniform. It will go with the automatic, the default parameters. So now correct, I created the model. And I'll just try to create the model again with k value equal to 5. That is my default. And this time, correct, I'll try to do the prediction for my full data set. So here, correct, I did the prediction for the 80 records. So now, correct, if I want to do the prediction for full data set, even I can do that as well. So I'll do the prediction for my full data set. So obviously, correct, which variable is having all the 400 records? My X is having all the 400 records here. So that's what you're able to see. So this is the prediction for all the 400 records. And here, correct, again, I want to check the accuracy. I can use the same statement here. This is equal to accuracy score, and I'm using y_pred. This is the predicted value. And here, this point, correct, I won't be able to use y-test because y-test is having only 80 records. I need to use y. Y is having all the records here. I'm getting an accuracy of around 69% here. Again, similarly, I can print the confusion matrix as well. This is what I can specify. So this is the 69% whenever I use the full data set. So based on the data set, correct, the accuracy may vary it. So now here, correct, what I will do, I'll just try to make this as 1. And I'll make it as 1, and I want to do the full prediction. Let's see what's accuracy we're going to get. So this is equal to 1 here, and I'll go with the Euclidean distance. And I want to do the prediction. And I want to print the accuracy here. So here, correct, when I converted this to 1, you are able to see that when you are getting a good accuracy here, around 91% of the accuracy. So that's what you are able to get it here. So that way, correct, the accuracy is going to change drastically. Not the drastically because the lot of deviations are coming because this is a small data set. But the real scenario should not be that many deviations. So now if I want to see the full data set and the predicted value side by side. So this is the data frame 1. And I want to display the predicted value also here. As I specified earlier, I can just concatenate it. So my predicted value, I can just concatenate it. So this is my predicted value, and I will be using, and I will be exporting to an Excel sheet here. So this is what you are able to see the predicted value, and the most of the records, the data is matched here right now. And I will also print my confusion matrix. So now if I just go and open the result which is exported here. So this is the data which I exported. And next, correct, what the confusion matrix meant. So I can explain about the confusion matrix here. I'm getting the value 239. Then this is equal to 18. Then this is equal to 18,125. 18,125. So this is a confusion matrix value we are getting here. So how these numbers are coming. So this part, it is going to related to my actual data set. So this is equal to actual 0. This is my actual 1. Again, if I just go here, this is my predicted 0, and this will be the predicted 1. And if I just add these two values, you'll get 257 here. So this is equal to 143. This is 257. Okay. So it is not necessary that always it should be same. So by luckily it has come like that. So the total what you will get here, this is a 400 code. So that's what you will be able to get here. So what it mean by this 257? So this 257 is, so if you see my data set, so in my original data set, how many records having the value are 0? So that's the count you will be able to get. So if I just go here and check the record, so there are 257 records having the value as 0 here. That's the meaning. Again, this 143, that's how many number of records having the value as 1 here. The 143 records having the value as 1 here. So now what is this 239? So the 239, so this is correct. This is related to the predicted. So how many records are predicted as 0? So that's the next parameter you can see here. How many records predicted as 0? That is 257. It is not necessary that this should be same. It can be always different. Again, how many records predicted as 1? So that's what you are able to get it here. 143 is predicted to 1 here. So that's the number you are able to get it here. Now this is again actual predicted combination. So what it means by that one, that is actually, so in my original data set, this is 0. And in the predicted data set, this is 0. So that means this is the proper classification. So my original data set, this is 0. And the system tried to predict all of them as 0 here. That's the value you are able to get. So you can see that one 239. That's the value you are able to get. So now here, this 18 records, my original data set, it is 0, but it is predicted as 1 here. So other way, I can say that even this is a misclassified record. I'm expecting this should be predicting as 0 because my original data says this is 0, but this is predicting as 1. So this is the misclassified record. And if I want to get the count, you will be able to get it from here. So my actual filter is 0. My YPred predicted as 1. This is the 18 records you are able to see here. Again, similarly, my actual equal to 1 predicted as 0. So what's a good model? My actual equal to 1 and the system should be able to predict it as 1. So that's obviously a good model. So there are 125 records is matching that condition. So that's what you're able to see. But in this record, the actual this is 1 but predicted as 0. So that's a misclassified records. So if you see here, this is actual 1 and the predicted as 0 here. So this is called the misclassified records here. So the 18 record got misclassified. So that's what you will get from the confusion matrix. How many records are properly classified? How many records are misclassified? And which categorical variable having maximum mismatches, etc. So that's the idea you will be able to get. So here both 0 and 1 equal number of mismatches are there. But if you see the percentage wise, you can see that when more misclassification they are in category 1. So out of 143, 18 got misclassified. But here out of 257, only 18 got misclassified. The percentage wise, if you see that one, the category 1, the more misclassifications are here. So this way we can interpret the confusion matrix. So the accuracy score is going to be the summary view. And if you want to get a bit better view, so we can go with confusion matrix. It is going to tell which column where there is a misclassification. So I'll just wait a couple of minutes so that you can just adjust this parameter and you can do the predictions. So you can just play around with n neighbors equal to 2, 3, etc. And you can just create the model again so that you will get an idea. This is one time we can import it. So you no need to import it each and every time. So whenever I created the model for the first time, I just imported. So the next one, this KNN. So here what we use, so we use the classification. So the same model correct we can use for the regression problem as well. So we can use the same for the regression as well. So here whenever we try to import it, skn.neighbors, neighbors, regressor as well, it is there. So I'll just quickly show you how we can do a regression problem with the k-neighbors class, k-neighbors algorithm. So I will use this data set. And here I have two columns. One is the age, and I have the height column we have. And I want to predict the height based on the age. So this is what I want to do it right now. So here correct, I have only two columns. So there is no standardization, normalization is not required. So this age will be the X and the height is going to be the Y column. So that's what clearly we can use it. So I'll just import all the required data set, required libraries here. I'm just importing pandas, numpy, matplotlib, skn.metrics, R2 score. So here correct, I won't be able to use accuracy score, confusion matrix, etc. user to check the accuracy. I'm going to use the R2 score. So the R2 score is again used to check the accuracy for a regression problem. So this is what we have already used whenever we are predicting the salary, again, the profit, etc. as a part of regression problem. So now we try to load this data set. So wherever correct, we can just load this data set. So there are only two columns, age and the height. So that's what we have. So now we can just create the X and Y. So the X is nothing but my age column and the Y is going to be the height. X equal to, so what is my data frame? So this is equal to data dot ilog, and I need to have all the rows and I need to have this column. So which is the column I need? I need my 0th column. So if I want to create the output as a 2-dimensional array, so what will happen if I directly give values and if I display X here, it is going to create a 1-dimensional array. So this is what you're able to see. But if you need the result as a 2-dimensional array, so I can just specify :1 here. So I'm just specifying the starting and the ending column, and I'm just able to get a 2-dimensional array here. So the next thing that I need to create my Y variable. I can specify my Y equal to data dot ilog, and at this time correct, I just consider my first column and my Y variable is getting created. So my X and Y is here right now. Now what I can do the train test split. So I can split the data between the training and the test data set. And that's what correct, I'll do it right now. Again here correct, if you want to plot the graph, we can plot it here. plt.plot X, Y, age and the height. So the data looks not in a straight line, it is like a curved line. And next I'll do the train test split here. So this is what I try to do here. So I'm just doing the train test split. So this is my X and Y. My test size equal to 30%. So 30% of the records will be the test data set. What's the total number of records? So you're able to see around 71 records are there. So 30% will be around 22 records will be there in the test data set. So if I want to know what is the size, I can specify dot shape. It will give 22 records there in the test data set. So now if I want to create the model, I can just create it. So here sklearn.import neighbors. And if I want to check the error or the accuracy, the R2 score is used to check the accuracy. And any point, if I want to check the error, there is one other option is that is called a mean square error, or there is a root mean square error, etc. So that is also we are just going to import it here. So now what we are trying to do here, we just write a for loop here. So that's what we try to do. We are trying to create a for loop here. And we know that whenever you use the classification problem, so that is the difference if we compared with the other example. There also we can apply the same concept. So what we are trying to do, we are just trying to create this model with a set of combination of k values. Because based on the k value, you have seen that the accuracy is getting changed. So one of the places you saw that whenever the k value equal to 5, the accuracy was around 60. Then when k equal to 1, the accuracy was around 90, etc., 90 plus, etc. So that's what you're able to see. So now what we are trying to do as a part of this statement, I'm just creating this model with the different k combinations. I'm just creating a for loop for k in range of 20. So what I was just telling, right, instead of adjusting the k value multiple times, I'm just creating a for loop here. So I'm just creating a for loop. K is ranging from 0 up to 20. And the first iteration, what it will do, the k equal to k plus 1. So either I can use 0 to 20, or I can just start from 1. So there is no issues. If you're starting from 1, so you no need to specify k equal to k plus 1. So by default, whenever I read the range function in Python, it is starting from 0. But there is no point, correct, n neighbors equal to 0. There is no point to create the model. So that's the reason I'm just incrementing k equal to k plus 1. So the first iteration, k equal to 1. And I'm just creating this model here, the neighbors regressor here. So here, this is not a classification problem. This is going to be a regression problem. That's the reason we are using the k neighbors regressor. And here we are just specifying the n neighbors equal to k. So the first time the model is created with n neighbors equal to 1, we'll try to fit the model. We'll try to do the prediction here. And the finally correct, we are just calculating the error. So we can just calculate the accuracy or the error. So there is no difference. So here we are just calculating the error and we are just appending that error to a list here. So initially we created an empty list here and we are just trying to append the error to the list. So now correct, whenever I execute this statement, the KNN algorithm will be created 20 times with different k values, the k value ranging from 1 to 20. And after each and every iteration, there will be an error will be there, and that error will be stored there in the variable here. So this is the list, and which is having the error here. So now to identify which is the right k value we want to choose here, because the earlier example, correct, we were giving 5, we were giving 2, we were giving 1, etc. Again, we are doing a lot of trial and error, correct? So here it is going to execute continuous 1 to 20. And from here, we need to select the one which is giving the least error. So if instead of error, if you are using the accuracy, so you need to select the k value which is going to give you the maximum accuracy. So here the error is coming down 3, 2, 2. Again, it is coming down. This is 1.9. Again, slightly error is increasing. Again, after this point, you can see that when the error is increasing further. So we feel this is the least error what we have. And it will be easy if you plot a graph. Easily we can just identify which is the least error, because otherwise, correct, we need to check each and every number. So what we can do, we can just create a graph here, plt.plot. So easily, correct, we can just identify the errors. You can just identify the point with the least error here. So now if I just create a graph, at the x-axis, what I'm specifying, the different k values. What are the k values I have? I have 20 k values ranging from 1 to 20 here. So whenever I'm using the range function 1 to 21, it will iterate from 1 to 20 here. And it is going to print different RMS value. The RMS is nothing but the different error. So this is the graph, it is coming here. And from here, we identified that one, the least k value. So the least error, what we are getting at this point. So you conclude that, we can conclude that when k is the right value, we can select it to create this model, because this k is having the least error here. So that is what we have done in a different way. We just write a for loop to identify the number. So next, I can go ahead further. I'm just going to create the model again with the k value equal to 12. So that's what I'm trying to do here. I'm just creating the model with k value equal to 12. And I can do the predictions out here. Otherwise, correct, each and every time we need to try with the 5, 6, 7, 8, again 1, 2, 3, etc. To avoid that confusion, we are just writing a for loop, identifying the right k value. We are just creating the model here right now. So now, correct, we are trying to do the prediction. So we have predicted here. This is going to be the predicted value for the test data set. And if you want, correct, we can check the accuracy. So to check the accuracy, I'm using the R2 score. So I'm getting around 98% of the accuracy whenever I tested with the test data set. Whenever I want to test with the full data set, instead of X test, I can specify X. I'm getting the predicted value. And here, correct, I can use the R2 score as well here. So this is equal to Y, and I can just check the accuracy. I'm getting a 0.9841. That's accuracy you are able to get it here. So more or less, the full data set and the test data set, there are not much difference there in the accuracy. It is going to be the same. And we just identified whenever the k neighbors equal to 12, that is having the least error. So here, correct, we use the error. So just opposite to that one, if I want to use the accuracy there, so that also, correct, you can use it. So if I want to use the accuracy, how can I use it? So I'll just create one dummy list. And here I'm just giving the another variable name accuracy value. And here I'll follow the same k in the range of 20, k equal to k plus 1, just creating the model with k, fitting the model, doing the prediction. And here, instead of finding the root mean square error, I'll just find the R2 score here. R2 score. So this is going to be the accuracy. And the accuracy need to be calculated between the y test and the y prediction value. The accuracy will be calculated. And after that, I want to append to this particular list. I want to add to this particular list. So this is what you're able to see. So this is correct again, accuracy. So this is equal to accuracy. And I'll just add here. So this is equal to accuracy for accuracy value for k equal to 1, 2, 3. And I'm just giving ACC here. So here you can see that when I created the model with the different accuracy value, k is from 1, 2, 3 up to 20. And here it is displaying the accuracy. So if you are using the accuracy, you need to pick the variable which is having the highest accuracy. So same thing, if I want, I can plot as a graph here. So this is what you're able to do, plt.plot, the range from 1 to 21. And my y value equal to accuracy value. So that's a list which is having all the accuracies. So if I just plot here, this the graph looks like. And here you need to check the point which is having the maximum accuracy. So this is the point you are able to see the maximum accuracy, that is again 12. So here also you are able to see the 12 is having maximum accuracy, 98.3. So that way I can just find, so this is one of the method to find the optimal or the best k value, and we can just create the model accordingly. So you want to try this one, I'll just give the script again, just loading the data set. So this is going to be my X. This is going to be my Y here. This is my age and height. I'll do the train test bit here. These are few more libraries. And this is the function which are written to find the accuracy. And this is what current we are plotting the error here. And just give a small gap so that you can just try it. So any questions on this? KNN, I just covered KNN regression as well as the classification. The data loading steps, everything, it is going to be the same. Only this part is different. So the way correct how we are creating the. So any step, do I need to explain? You're not clear or you're getting any error?
All right, let's test your knowledge. Here's a question for you. Which of the following is not a common data visualization library in Python? Option A, matplotlib. Option B, Seaborn. Option C, Plotly. Option D, Beautiful Soup. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there, want to master data analytics and automation? Our Advanced Data Analytics with Python course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about data analytics and automation with Python. It's like a toolbox for handling data, from analyzing trends to automating tasks. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is really affordable. Ready to become a data analytics pro? Sign up on our page now. And for more info, check out ZaranTech's website.
So we will talk about the next algorithm. So we discussed KNN regression as well as classification. I hope you're getting the notes every day. So if there are no questions, So we'll go to the next algorithm. So that's what we want to cover is naive-Bayes algorithm. So this comes under the machine learning, supervised learning, and under classification. So we have the naive-Bayes algorithm. So the other algorithms, what we discussed, the logistical regression, then the KNN. So all these algorithms comes under the classification category. So this is the third algorithm we are going to cover under classification. And we will be going to cover another 3 more. And there are 2 categories under supervised learning. One is the classification and another one is the regression. So the regression, we discussed few algorithms earlier. So we discussed about linear regression. So we discussed about decision tree regressor, the random forest regressor, etc. And here, if you see the naive-Bayes, so this is based on the conditional probability. So the rule behind here is that, so there is a Bayes theorem that will be the conditional probability what we are going to use. And here how it will be, so the probability of A given B. So that means the B is the condition which is already confirmed. And if you want to check what is the probability of A given the condition that it is B, that is equal to probability of B given A into probability of A divided by probability of B. So now correct, if you are tossing a coin, so what are the 2 possibilities are there? So you will get 2 possibilities. One is head and tail. So these are the 2 possibilities. So what is the probability of getting head? So that is, there is a 50% chance that you may get head and another 50% chance that you may get tail. So these are the 2 probabilities. So now consider if you want to toss 2 coins. So what are the possible outcomes? So the first coin can be head. Again, the second coin can be head. Again, the next possibility is that first coin be head, second coin be tail. Again, the next possibility is that tail. Again, it can be head. Again, it can be tail and tail. So these are the 4 possibilities what we have. So now if someone asks what is the probability of getting 2 heads? So we have 4 outcomes and out of that it is 1. So the probability is 1/4. So that is equal to 25% chance that you will get 2 heads. So if you are tossing 2 coins and if you are getting 2 heads. Again, what is the probability of getting at least 1 head? At least 1 head. So at least 1 head, the probability is that. So how many places we have head? So you have 1, 2, 3, we have head. And at least 1 head is equal to 3/4. So that is equal to 0.75. Again, what is the probability of getting 2 tails? That's again 0.25. Again, at least 1 tail, that is again 3/4, that is 0.75. So now the conditional probability is given in such that, so the conditional probabilities, so as you can see here, so the probability getting at least 2 heads, that is 1/4, at least 1 tail is 3/4, and the conditional probability is that the second coin being head given the first coin is tail. So what's the probability? So that's actually called the conditional probability. So we want to check second coin being head given the first coin equal to tail. So what they mean to say here is that, so if I just write it here, this is equal to second coin being head, the first coin equal to tail. If I talk about given the first equal to tail here. So if I just go here, so this is what you are able to see. So given the first coin equal to tail, this is a confirmed one. So given the first coin equal to tail, that is a confirmed one. And given this particular scenario, what is the probability of getting second coin equal to head? So since this is a confirmed one, what are the probabilities? What are the outputs we can get it? So what is the chance to get the first coin equal to tail? So the first coin equal to tail, we have only these 2 probabilities. No, these are not the probability. These are the 2 possibilities. Because this is already confirmed. So we have 2 options. One is tail and another tail and head. Again, both we are getting the tail. So now what we want to check here is that the second coin head given the first coin equal to tail. So in this particular scenario, what is the probability of getting second coin equal to head? So in this case, we are not going to consider all the 4 outputs. So we are considering only 2 because this is already confirmed. And in that one, what is the probability of getting second coin equal to head? So obviously correct, this is going to be 1 by 2 or that is equal to 0.5. So now correct, how can I write the formula for this? So the conditional probability formula equal to probability of A given B. So that's what it is. So that is equal to probability of A given B equal to probability of B given A. So that need to be multiplied with probability of A. So that's what you can see here, divided by the probability of B here. So the probability of B here. So if I just try to replace the values here, so what we try to get, what is my A? So I want to check the second coin equal to head. So that's the probability which I want to know. So that is equal to A equal to second coin equal to head. So that is my A here. And what is my B here? So my B equal to the first coin equal to tail. So this is my B here, the first coin equal to tail. And if I try to replace here, so that is equal to probability of A given B. That's again equal to probability of B given A. So what is probability of B given A in this case? Probability of B. So B is this one, the first coin equal to tail, given the condition that probability is probability of A. The probability of A equal to second coin equal to head. So this is what you can see. That need to be multiplied with what is the probability of A. So what is A here? The second coin equal to head. So that is probability of second coin equal to head divided by, I need to divide by the probability of B. So what is my probability of B? So that is equal to probability of B. So the B is nothing but my first coin equal to tail. So if I just try to replace these values, you will be able to get what is the probability of first coin equal to tail. So probability of getting first coin equal to tail. So these are the 4 outputs here. The probability of getting first coin equal to tail. So these are the 2 possibilities. So if you see the 2 possibilities out of 4, so these are the 2 possibilities what we have. So what's the probability here? So the probability equal to 0.5. So that need to be multiplied by second coin equal to head. What is the probability of getting second coin equal to head? So the probability of getting second coin equal to head. So this is what you are able to see. Second coin. So in this case, correct, I'm not going to consider what will be the first output. So we just consider the second coin. So second coin equal to head. So there are 4 outputs. There are 2 outputs are satisfying. So that is equal to 0.5 divided by. So you'd be able to. So you'd be able to see what is the probability of getting first coin equal to tail. So the first coin equal to getting the tail, what is the probability? That's again 0.5 because you can see that one. So these are the 2 outputs. So that is equal to 0.5. So that is equal to 0.5. So these 2 0.5s will get cancelled. And the final output, what you will get here is the 0.5. So this way, correct, the conditional probability is going to work. So here, if you see that one, probability of getting A equal to second coin equal to head, given the first coin equal to tail. So that is probability of first coin equal to tail given the second coin equal to head. So in this particular condition, what is the probability? So the second coin equal to head. So there are 2 possibilities are there. So these are the 2 possibilities. Out of that one, what's the probability getting first coin equal to tail? So these 2 possibilities, if you consider, so this is going to be 0.5. And this is going to be the individual probabilities. So the probability of A is the individual probability. And this is again the probability of B. So that's again an individual probability. So that's what you're able to see here. So this is the conditional probability. And this is the base for the Bayes theorem. So again, the next one is that the one what we consider here is a simple examples. So now if you see that and we have the different conditions. So what are the conditions we want to use here? So the first of all, correct, we want to use the day, discount and free delivery. So these are the different conditions what we have. So here, correct, we want to check what is the probability that the person is going to buy a product or not going to buy a product given these conditions. So we have three. So here, if you see that even the real problem, so we have three independent variables. And what we want to predict whether the person is going to purchase or not going to purchase. So here, this is going to be my A, what I'm just going to predict. So this is my dependent variable. And these are, you can see that when these are the independent variables. So there are three independent variables. Again, these are the three possible values for this variable. That is the day. So we have three options. So that is equal to weekday, weekend, and holiday. Again, the next one, what we have. So we have an option like discount. So discount, they have two possibilities. That is discount is yes or no. The free delivery, there are two possibilities. That is yes or no. So these are the two options which is available. So based on that, correct, so we want to check. So what we really want to check here is that what is the probability for the different combinations? So maybe, correct, if it is a weekend and if there is no discount and if there is a free delivery, what is the chance that the person is going to purchase on that particular day? Or maybe, correct, if it is a holiday and there is discount and there is no free delivery, what is the probability that the person is going to purchase? And what is the probability that the person is not going to purchase? So based on that, correct, so they can just take the right combinations, which is having the maximum probability, and they can just think whether they want to extend the discount, etc. So that's what exactly they meant here. So now if I just explain how it is going to work. So this is a data set which we have, a small data set. If you see around 15 records, if you see, no, 15 to 30 records, if you see, the day we have the different combinations. The day equal to weekday, weekend, and holiday. Discount, there are two possibilities, yes or no. Free delivery, there are possibilities, yes or no. The purchase, there are two possibilities, whether the person is going to purchase or not going to purchase. So what the first thing we need to create here? So we need to create the frequency table. So that's what you can see. So we need to create the frequency table corresponding to each variable. So we have day, we have discount, we have free delivery. Based on that, we need to create the frequency table. So the frequency table, what we are going to find out, what is the number of times each activity has happened, each scenario has happened. So here, if I create the frequency table for the discount, there are two possibilities are there. So either yes or no. So these are the two possibilities. And what we want to predict whether the person is going to purchase or not going to purchase. So the total, there are 30 records are there. So out of that, you would be able to see that whenever there's a discount, there are 19 people who visited on that shop purchased. So out of 30, there are 19 people purchased whenever there is discount. And whenever there is no discount, out of 30, 20 people visited whenever there is discount. Out of that 20, one person purchased. So here, correct, you can see that when total number of records equal to 30, that is equal to 19 plus 120 plus 525 plus 30. Out of that, you can see there are 20 people visited whenever there is a discount, and 10 people visited when there is no discount. And whenever, so when the out of 20 people, 19 people purchased whenever there is a discount. And here you can see that out of 20 people, so the 1% didn't purchase. So obviously, correct, you can see that. So whenever there is a discount, you would be able to see there is a good chance that the person are going to purchase the product, because out of 20 people visited, 19 people purchased. So here, if you see that whenever there is no discount, so there are 10 people visited, and out of that 5 people purchased and 5 didn't purchase. So here you can see that the probability is around 50% probability. So that's what you would be able to see. So similarly, correct, if you create a frequency table for free delivery, there are two possibilities, that is yes or no. So the total number of records equal to 30. So that's what you can see. So whenever there is free delivery, so there are 23 people visited. Whenever there is no free delivery, there are 7 people visited. So if you add all the numbers, it will be 30. So here also it will be 30. And out of 23 people visited, 21 purchased whenever there is a free delivery. Whenever there is no free delivery, no, 23 people visited, out of the 21 purchase whenever there is a free delivery. And whenever there is free delivery, 2 people didn't purchase. So here also you can see that total 7 people visited. Out of that, 3 purchased and 14 in purchase here. So that's what you can get from this frequency table. And the day, if you see, there are 3 options are there. The day, the options what we have the weekday, we have the weekend, and we have the holiday. So these are the 3 options. And overall, if you see, there are 11 people visited whenever it's a weekday. That is 9 plus 2. Weekend, there are 8 people visited. Then holiday, there are 11 people visited. Out of this 11 people, you can see that even the 9 people purchased on a weekday. So that means weekday, 11 people out of that 9 purchased. And out of that 9 people, 11 people visited on a weekday, 2 people didn't purchase here. Again, the weekend, total there are 8 people. Out of that, 7 people purchased. And the holiday, there are 11 people. And out of 11, 8 people purchased. So that's what you're able to see. So now the total number of people purchased across the total people visited, that is out of 30. So we need to add this. So that's what you would be able to get here. So is it clear how the frequency table is getting created? Any questions? So we will be creating the frequency table. After that, what we need to do, we need to create a likelihood table. So if you talk about the likelihood table, so we need to add the probabilities. So this is the likelihood table for the day. So this is the frequency table. We have the combination weekday, weekend, and holiday. So these are the different combinations. And whenever we create the likelihood table, so this is what you would be able to see. So we are just adding. So the frequency table, we have that number, and here we are just giving what is the percentage. So out of 24 people, 9 people purchased on a weekday. Again, the weekend, out of 24. So the out of 24 is the total number of people purchased. So the total number of people purchased is 24. Out of that, 7 people purchased on a weekend. And out of 24 people purchased, 8 were on holiday here. So that's what you're able to get here. And this is going to be 24 divided by 30. So this is an overall probability. And this is a conditional probability. What's the condition here? So the weekday and the person is going to purchase. That's the condition. Again, here this is a weekday. The person is not going to purchase here. So if you just add here, the total number of people purchased is 24 out of 30. And what's the total number of people not purchased? That is 6 out of 30 here. So that's what you would be able to see. Now, if you see the weekday, the probability equal to 11 divided by 30. So that means correct. What is the percentage of people visited on a weekday? So here we are not checking whether the person is purchased or not purchased. So here again, we are not checking whether the person is purchased or not purchased. We are just checking what's the total number of people visited. That is out of 30, 8 people visited. On a holiday, out of 30, 11 people visited. And if you want to know on a holiday how many people purchased, this is the number we are able to get here. So that's what you can see. What's the probability of weekday? So the probability of weekday means what is the probability that the person is going to visit on a weekday? So that is equal to, so here correct, we are not going to check whether the person is purchased or not purchased. So that is 11 divided by 30. And what is the probability of not going to buy? So what is the probability of not going to buy? So here we are just checking what is the probability of not going to buy, irrespective of weekday, weekend, or holiday. So that's what you're checking. This is an individual probability. So if you're finding that one, I need to get it for all the population. That is 6 out of 30 didn't purchase. Again, this is the conditional probability of B given A. So B is weekday, not going to buy. So this is what you can see, my weekday, B is weekday, and A equal to not going to buy. So that is equal to probability of weekday not going to buy. That is weekday not going to buy. That is 2 by 6. That is equal to 0.33 here. So that's what we can create the likelihood table. And the likelihood table we need to create for all the variables. Again, what is the probability of weekday? So the person is going to visit on a weekday equal to 11 divided by 30. What is the probability of going to buy? That is equal to 24 divided by 30. So that's the individual probability we are going to find out. What is the probability on weekday going to buy? So the weekday, the person is going to buy. So that is again 9 divided by 24. That's equal to 0.375. So now if you see the conditional probability here. So if I want to check the probability of a person, what is my A? A equal to buy on a weekday. So that is what we want to check. What is the probability of person buying on a weekday? That is equal to probability of A given B. I need to consider probability of B given A. What is B here? Weekday, the probability of buying. That need to be multiplied with probability of A. So what's the probability of A? The probability of A equal to buy divided by the probability of weekday. So if you see here, the probability of weekday going to buy, the probability of weekday going to buy equal to 9 divided by 24. So 9 divided by 24 equal to 0.375. 0.375 multiplied with probability of buying. So what is the probability of buying? That is 24 divided by 30. That is equal to 24 divided by 30. That is 0.8 divided by the overall probability. The overall probability, if you see, this is 0.367. So that's what you're able to. So this is the probability of weekday. That's equal to 0.367. So the overall correct, the probability of buying on a weekday, you will be able to get 0.817. So that way it is going to. So now correct, we calculated the conditional probability for one independent variable. But consider scenario if you want to consider all the conditions. So here correct, if you want to consider the condition, the day is a holiday, the discount equal to S, the free delivery equal to S. So we want to consider these three conditions. So these are the different conditions we want to consider: the day equal to holiday, discount equal to S, free delivery equal to S. We want to consider these three conditions and what is the probability that the person is not going to buy. So here A, you can see that you're not going to buy. B equal to day equal to holiday, discount equal to S, free delivery equal to S. So if we just try to replace here, you will be able to see that even the probability of person not going to buy, that is 0.178. So if I explain here the probability of A given B, that's equal to not going to buy on these conditions. That's what I want to check. That is equal to all these conditions not going to buy. So that means the day equal to holiday, not going to buy. Discount equal to S, not going to buy. Free delivery equal to S, not going to buy. That need to be multiplied with the probability of A. What is probability of A? Not going to buy. Divided by the probability of B. The B is nothing but day equal to holiday, individual probability, day discount equal to S. Again, the free delivery equal to S. So that's what you are seeing here. So now if you just see discount equal to S, not going to buy. So this what discount equal to S, not going to buy, that is 1/6. That's the first part, 1/6. Free delivery equal to S, not going to buy. So free delivery equal to S, not going to buy, that is 2/6. 2/6. Again, the third one equal to discount equal to S, not going to buy. Discount equal to S, not going to buy, that is again 1/6. That is 1/6 into 2/6. A day equal to holiday, not going to buy. So day equal to holiday, not going. Sorry, day equal to holiday, not going to buy. Holiday, not going to buy. That is 3/6. So that's what you are able to see. So that is 1/6 into 2/6 into 3/6 multiplied with what is the probability of not going to buy. So that you will be able to get anywhere here. That is 6/30. Here also correct, it will be same. 6 divided by 30 divided by individual probability. That is discount equal to S. You can see that 20 divided by 30. Free delivery equal to S. That is how many people visited whenever there was a free delivery. That is 23 divided by 30. Again, day equal to holiday. Whenever it's a holiday, the probability equal to 11 people visited. 11 out of 30 here. So that's what you can see. So the overall, if you calculate it, it's going to be 178.178. So that means whenever these conditions are in favor, the probability that the person is not going to buy, it is 0.178. So similarly, correct, we can calculate it. What is the probability that person is going to buy on this condition? That is 0.986. So that's what you're able to see. So now if you see that one, what is the likelihood of purchase and what is not the likelihood again, what is the likelihood of not going to purchase? So we add both the probabilities, that is 0.986 plus 0.178. The total probability will get it. And we will divide it. So if I want to know what's the likelihood of purchase, that is 0.986 divided by the total probability. So there are 84.71 chance that the person is going to buy whenever these conditions are in favor. So what are the conditions? Whenever there is a discount, whenever there is a free delivery, and if it's a holiday. Again, what is the likelihood that the person is not going to purchase whenever these conditions are in favor? That is 15.29. So that's what you're able to, that is what it is specified here. So this is the base for the naive-Bayes algorithm. And this is explained. And here, whatever we are going to consider here, this is called the posterior probability. And the term, this is called the likelihood, then class prior probability and predictor prior probability here. So these are the different parameters specified. And similarly, correct, one more example is explained here. You can just go through it. So here it is explained what is the probability that the match is going to happen whenever the weather condition equal to sunny or overcast or rain, the humidity equal to high or normal, and the wind equal to weak or strong. What is the chance that the match is going to happen or not going to happen? So that's what we try to do. So the naive-Bayes, again, there are three types of algorithms. It's not a three types of algorithms. The naive-Bayes itself, there are three classifications are there. One is Gaussian NB, multinomial NB, and the Bernoulli NB. So these are the three types that naive-Bayes algorithms are there. So we'll directly go to the example, and the data set which I'm just going to use the same data set which I shared. So I'll be sharing the other data set once I finishes all these algorithms. And I hope you will have the data set. And the initial steps, correct, it is going to be the same. So we need to import all the required libraries. That is, we have imported NumPy, Pandas, Matplotlib, Seaborn. Again, so we have confusion metrics, we have train test split, etc. here. So that's what we have here right now. Next, what we would be doing, so we load the data set here. So can you just open worksheet for the Jupyter notebook so that correct you can just execute all the steps. I'll tell you exactly where you need to change it. So the initial steps are going to be the same. So what we try to create the model. So till correct the train test split, it will be the same. The only place correct where we call the algorithm, it will be different. Sorry, doing in parallel, I'll just wait so that correct you can just open notebook. Or even correct you didn't complete it, maybe you can just open the notebook which I shared. The initial steps will be the same. The only thing that you might need to change this particular part. So can I go ahead? So this is what we loaded the data set here. So now correct, we try to do the same process. We split the variables. So we'll just pick it up X and Y. So this is my X age and the estimated salary. Again here correct, we'll just create Y here. So this is going to be the Y variable. So we want to get the Y. So that means the person is going to purchase or not going to purchase. That's what we have here right now. So now the next step is that we will do the feature scaling. So we are doing the standardization here. So this is going to be the same step. I hope I no need to repeat it because we already done this, the previous examples. And we'll do the train test split. So this is what we did the train test split. So now correct, whenever you're trying to use the algorithm, so there will be the difference will be there. So while creating the model, there will be the difference will be there. So here we need to import the Gaussian NB here. So that's what we want to import it here. So it will be under sklearn.naive-Bayes import Gaussian NB. So that's what we need to import it. So next what we need to create one variable. So this is a variable which is created Gaussian NB. And we just want to call this Gaussian NB here. And the next correct, I need to fit the model. That's equal to GNB dot fit. And I need to fit based on what? I need to fit based on my training data set. So that is equal to X-train and Y-train. So X-train and Y-train should have the same number of records. That's what I need to use it. And I'm just using it here right now. So my model is ready. Now I need to do the prediction. to do the prediction, y underscore pred. So that is equal to GNB, Gaussian NB dot predict. So predict based on what? Based on my x underscore test. This is what I will be using, x underscore test, and I will be printing the predicted value here. So whenever I try to do the prediction, here you can see that on everywhere it is predicting as 0. So that's the first example we saw. The logistical regression, we got around 64% of accuracy. When we used the KNN yesterday, the same data set, whenever the k equal to 1, we got around 90+% of accuracy. So now current you can see that whenever I use the Gaussian NB, you can see everything is predicting as 0. And obviously current, if I want to check the accuracy, I can use accuracy score, confusion matrix, or classification report. So if I want to use the accuracy score here, this is what you can see. This is the accuracy score. So I need to do for the test data set. Again, if I want to do the confusion matrix, I'll do the classification report as well here. All will give you the same accuracy. So this again y underscore test and y underscore prediction. So 71.25, that's accuracy here. And this is what I'll get it from accuracy score. And the classification report also, if you see here, this is the accuracy you're able to get. And the confusion matrix, if you see, it will give you an idea how many misclassified records are there. So this is what you can see the confusion matrix here, y underscore test. So there are 57 records in category 0. All are properly classified. Again, category 1, there are 23 records are there. And all the 23 records, you can see that when it is misclassified. If it is properly classified, you should get the number here. And the recall also, you can just analyze it. The recall is going to tell me how the prediction is related to the actual data set. So here you can see that one. This is related to the actual data set. So here you can see the percentage equal to 1. So that shows that one for the category 0, both actual and the predicted, it is 100% matching. So that means total I have 57 records. It will check out of 57 how many is matching. So all the 57 are matching. So I'm just getting 1 here. And the next category, if you see the recall part, corresponding to 1, how many are matching? So there are 23 belongs to category 1. And how many of them are matching? There is 0. Nothing is matching for the category 1. So that's the reason you are able to get 0 here. And this is the parameter. If you need to see precision, it is coming around 71. So how the 71 is coming? So this is based on the prediction. So what is the total number of predictions which I have? So this is the total number of prediction, that is 57 plus 23. That's equal to 57 plus 23. 80 is the total prediction. Out of the 80, how many of them are matching related to 0? So that means out of 80, that's the total number of prediction to the category 0. Out of that, 57 is matching. So that is something like 57 divided by 80. So that's what you're able to get it here, 0.71. Again, so this category, obviously, it is nothing is matching. So it is 0 here. So this is predicting as 0. Everything is predicting as 0. Category 1, nothing is matching. So this is 0 here. So here you can see that in this, the total number of records equal to 80, and 57 is the number of records belongs to category 0. 23 is the number of records belongs to category 1. And if the model is really good, you would be able to see 1 or close to 1 in all these places. All these places, precision, recall, and F1 score. Again, the micro average, weighted average, etc. All these correct, you would be able to see the value close to 1. And whenever there is a deviation from the values 1, so you can see that when the predictions are not proper in that combination. So that's what you interpret from here. And this is what the prediction I did for the test data set. So now let's check for the complete data set. So this time I just tried to pass X. X is the full data set. You can see that one everywhere it is predicting as 0. So now I just quickly print the accuracy score, confusion matrix, classification report, etc. So this is what you are able to. This is equal to y. This is for the full data set I need to calculate for y here. So there are not much difference. So here there's a 100% matching. So this is 1. Total number of records belongs to category 0 is 257. Category 1 equal to 143. This is the total number of records here. So this is going to be the F1 score. The F1 score formula I'll tell you later. So this will be 2 into precision into recall divided by precision plus recall. That's a formula for F1 score. Again, the exact number of misclassified records, etc., you can go with the confusion matrix. So we can do the prediction. And this is what we try to print the accuracy here. So instead of X test, I can use X, or even correct if you want to try with the X train also. Whatever the data we have, we can try it. So next we'll go to the next one. So first correct, we talk about the Gaussian NB. So the next category, what we have the Bernoulli NB. So if I want to use that algorithm, it's again going to be the same. So what we can try to use here. So instead of Gaussian, we need to import the Bernoulli NB here. So this is what you can say. Again, the process is going to be the same. Just execute it so that it is working. So next correct, I need to create one variable, BNB, and I just call Bernoulli NB here. And I'm not passing any special parameters, open and close at this point. Again, I want to create the model, BNB dot fit. Fit based on what? Based on my training data set. That is equal to X underscore train, comma Y underscore train. This is what I need to use. And my model is ready right now. And I want to store this to variable. I'll just try to use the same variable. If you want, you can give a separate variable as well. And I just try to display here. You can see that my model is ready right now. So now again, if you want to do the prediction, the process is going to be the same, BNB dot predict. So if I want to do the prediction here, I can use Y underscore test. No, sorry, Y, not Y underscore, X underscore test. That's what I need to pass. I can create one variable here, Y underscore thread here. This is going to be the predicted value. So this is going to be the predicted value here. So similarly, correct, if I want to do for complete X, I can do the same. So you'll be able to get the same result. Again, to check the accuracy, you can use classification report, confusion matrix, accuracy score, etc. You will get the same result here as well. So if I want to use accuracy score, confusion matrix, etc., you can use the same because I use the same variable name. So it will work. So there is no difference as such. So now I'll go to the next one. The next algorithm which we have, that's a multinomial NB. So if I want to use it here, so if you any point correct, if you need from the drop down, so you need to press tab 2 times, you will be able to get here. So this is equal to multinomial NB. And again, I can just call this variable and create one variable name MNB. And if I try to do the fit, MNB dot fit here, and obviously correct, you will get an error. So the only thing you need to remember here. So whenever you're using multinomial NB, so you were not supposed to give some negative values. The negative values in the data passed to multinomial NB. So that's the reason we are getting this error. How the negative values has come? Because we did the standardization. So we did the standardization here. So when we did the standardization, the values are arranged between -2 to +3 range, no, -3 to +3 range. So that's the reason the negative values was come. So that is creating the problem. So one thing you can do that instead of standardization, if you want to get the value, a positive value, I can go with the min-max scalar. So if I go with the min-max scalar, the values will be between 0 and 1. So all the values will be arranged between 0 and 1. So if I want to arrange the values between 0 and 1, I can just try the min-max scalar. So this is what min-max scalar. And here I can just call min-max scalar. And I can just specify min max x. And it is going to be min max x equal to same commands I need to use. So here, correct, obviously I need to do the fit and transform. So this is equal to min max scalar fit and transform, and you have printed here. So now you are able to see the values are arranged between 0 and 1. The smallest value in the age column, that will be 0, and the highest value will be 1. And similarly, correct, for the next column also, the smallest value will be salary, also the smallest value will be 0 and the highest value will be 1. So now this is what I have done. I did the min-max scalar. So now, correct, obviously, I need to do the train test split again. So this is my original data set I have done. I hope I have done there in the original data set. No, this is not correct actually. Okay. So this is my X, right? So the X only I just apply the min-max scalar. So you need to get the original data set and we need to apply the min-max scalar. So that means I need to recreate X and Y one more time so that I will get H, because if you see my X right now, X is already standardized data. So that's what I did the min-max scalar. It's better to go with the original data. My X equal to, how to get my X? What is my data frame name here? So the DF1, and I need to extract these two columns. So this is my X here, and I will be getting Y as well. So this will be my X, and I will get my Y as well. And if you want to get Y, so any point correct, if you want to insert a cell above the cell, you can press A. The A is used to insert the cell above. B is used to insert the cell below. So that's the shortcut. You can use it. I can use Y equal to df1 dot ilog, and I need to have all the rows, and I need to get the last column. So how do I get the last column? I can specify the column name, or I can specify the column position, or I can specify the -1 also. So here again, if I just print Y, you will be able to get all the values, and the extract what you're getting here, this is a series. I need the result in an array. So obviously, correct, easily I can use the word values here. It will be converted to an array here right now. It's a one-dimensional array. So after this, I just created X and Y. So now, correct, I need to do the min-max scalar on X here. So that's what I tried to do right now. X min-max scalar. So X is converted between 0 and 1. And again, we can apply the multinomial NB. So before that one, I need to do the train test split. So that's again one task is pending, because this is having all the 400 records. I can do the train test split. So how to do the train test split? I can use, I'll just copy so that at least I can save some time. So I have done the train test split, and the X and Y, the variable name I didn't change. After min-max scalar, okay, I changed the variable name. Okay, min-max scalar, this is equal to min-max X. So that's what I need to use here. And here it's going to be X train, X test, Y train, Y test. And now I can just apply the multinomial NB. So now we can see it is created. The model is created right now. So now the rest of the process, it is going to be the same. Y underscore pred. So that is equal to multinomial NB dot predict. mnb.predict here. And the predict based on what? I want to use my test data set x_test to do the prediction. And this is what you would be able to see the result as here. So all the values you can see, this is 0. Yes, tell me.
The new variable y_predict, instead of defining the new variable, can we use the existing variable?
So you're talking about this variable. Now I cannot use this existing variable. The only problem that this is created after applying this algorithm. So my ypred, which I am using here, obviously correct. It will be different than the other one. So this is, we are doing the prediction by using my multinomial NB algorithm. And the earlier ypred, so that should be created from the Gaussian NB. That's the model applied there. Fortunately, you can see that when the data is same.
Yes,
so that's the reason you feel that when this is same, but it is not necessary that it should be same. When you apply the algorithms, there will be some difference there in the values.
Okay. Good.
So instead of keeping ypred, so here I am using same variable name all the cases. I'll suggest you to use different variable names so that you will not get confused. So because this the result will be getting, even though correct I'm using the same variable name, the result what you are getting from the output of different algorithms. Even correct the X-train also, I won't be able to use it again, the previous X-train, because that is standardized data. And here I did the min-max scaler. After applying the min-max scaler, the X-train, I am doing the train test split. So to ensure that when this data is randomly splitting between 70-30%. And using this data, creating the model. So this is x_test. And now if I want to do the prediction for the full data set, I can pass x here, and I can give another variable name if required, underscore full data set here, prediction. And I can just print the result here as well. So this way we can create the model, and this is what you'll be able to see. And again, correct, if I want to check the accuracy of this model, so you can use the accuracy score, etc. So you can use accuracy score. And this is my predicted value. And the y, which you can use it. And I'm getting 64.25. That's accuracy you're able to get. So wherever you're using y, so that you can use the same, because the y we are not making any transformation. But the x correct, we are transforming it. So ensure that when you are creating separate variables for x or using it separately. So any questions? I'll pause here for 5 minutes. You can just try. So this is the main script for the Gaussian NB. Again, I'll just keep only the main script. So this is the Bernoulli script. This way we can create the algorithm. And whatever correct you use for the accuracy score, you can repeat the same thing. So there is no difference. It will repeat it. You can repeat the same. So this is the Bernoulli NB. And the multinomial NB, if you are using it, so you need to apply the min-max scaler. So this is the script for the min-max scaler. And this is going to be the algorithm which we can use it. So you need to do the train test split again. And we can just apply these are the main script you need to do it. So can you try and let me know if you're getting any output, any script? I want to repeat it if you're not clear. Gaussian NB part, I'll just move it. This is what you're able to see. So this is for Bernoulli NB. This is for the multinomial NB. So we'll start with the next algorithm. So that's a support vector machine. And that is mostly used if the data is bit of irregular. So maybe correct if you want to, if you're having it, the earlier data, what we considered for the KNN. So we were having one class of data here and another type of data or a separate class V here. So if you want correct, we can split this data into two different components by using a straight line, or maybe correct any of the lines we can just try to use and we can split it. But consider if the data is a bit of irregular. So maybe correct, this is one set of data. again here, correct, you can see that on this another set of data. So can we create a straight line and can we split it? Obviously, no. So if you want to split it, so maybe correct, so we need to draw a circle here. So if you want to split it, so maybe correct, we need to draw a circle somewhere here and we need to split it. So that means what is inside the circle and what is outside the circle, that is to be the second group. This will be the group A, group B, etc. So similarly, this algorithm support vector machine. So these are some of the parameters which we can specify. So the one of the parameter we can specify, that is kernel, and it is capable to split the data in an irregular form. So maybe correct if you want to split by using some curved lines, etc. So maybe this can be one portion, this can be other portions if you want to split it. So this support vector machine, we can use it. And here we have the kernels. The kernels, there are different kernels are available. One is the polynomial kernel, sigmoid kernel, and the third one what we have. So these are the different parameters we can specify: polynomial, sigmoid, linear. And the fourth one we can specify, that is RBF. So these are the different kernels we can specify. And in addition to that, there are two more parameters we can change it. That is called the C value and the gamma value. So these are the parameters which we can change it. And based on that, we can adjust the accuracy, etc. So that's about the support vector machine algorithm. And what normally say that one, this will split the data with the help of a bus split line. So that's exactly going to happen. So now correct, if I just go here. So here correct, I have two sets of data. So here this is one set of data, this is another set. If you see that one, we can split this data by using the different lines. So we can use a straight line, we can use another line here, we can use the third line here. So these are the different ways we can split the data. But which is the best split line here? Obviously correct, you can see that one, this is the best split line. How do we say that one, this is the best split line? If you see that one, this is going to the center. And if you check the distance correct, so these are the points which are very close to this line. So these are called the support vectors. And the distance, if you see that one, the distance will be same. So, but that is not the case with this line. This line, you can see that one, this is very close to this point. Again, this line is very close to this point. And the distance correct, you can see that on this point and this line, it's very short. And this point and this line is very far. So here correct, the split is not proper. But if you consider the center line, which is created, you can see that on the distance from this line to this line and this line to this line is same. So that means whenever we use the SVM, we see that when this is going to be the best split line, we can split the data accordingly. So even though correct, there are different ways we can split it, but by using the bus split line, it is going to split it here. And if you just talk some of the terms, so the line what we called as, this is called the hyperplane, because this is the straight line it is coming, but it is not necessary that it should be a straight line always. So maybe correct, sometimes it want to split the data, the image which is specified here. So maybe correct, this is not a straight line. So it might be a curved lines, etc. So that means it can be the other dimensions as well, it is possible. And the distance between the closest point to this line, this is called the margin. And the points which are very close to this splitted line, these are called the support vectors. So it will split the data in the best possible way. And this is the hyperplane that split the data because it is, okay, so this is what you can see, some definitions are specified. So this is again correct, another example which is specified how we are splitting the data. So even though correct, we can split the data in two groups. This is one group and this is another group. So whenever we use, even though correct, we can split by using multiple lines. We can keep one line like this, another line, multiple lines, we can keep it. But obviously correct, this is going to be the best split. Consider if you're splitting like this by using the line. So whenever you keep a person, a new data point comes here. And if the line is like that, obviously correct, this will be part of this group. So obviously the bus split line is very important. And consider this line is coming in a straight line. So how can I split this data? So if I want to split this data, if the data is a straight line, can I split by using a point? It's not possible, right? Because here you can see that one, the left side, there are points are there. The right side, you can see that when there are points here. So this is not the best way to split it because the right side also these points are misclassified. Whenever I want to split it, obviously one side I should get all the blue points and the other side I should get all the yellow points. So because it's a one dimension, I might not be able to do. But if you move to 2 dimension here and with the help of a straight line, I can split it properly. So here you can see that one, if you want, we can represent this line. This point, correct. This can be the x-axis point if you consider. X-axis equal to -1, 1. X-axis -2, 1, -3, 1, -4, 1. Again, here you can specify x-axis equal to 1, 1, 1, 2, etc. This is the representation we can do it. So once this data is representing in this particular form, so we can easily split it by using a line. So all the points above this line belongs to one group, and all the points below this particular line belongs to the other group here. Again, this is again, we can just split it. The data is not there in the particular shape, we can split it as. Now, if you see this particular image, so here there are multiple lines are there. And the best split, you can see that even the line which is going through the center here. So these are the different parameters which I can specify there in kernel. So this is the linear, polynomial, RBF. And in addition to that, correct, I can use the sigmoid as well to split the data. Again, there are parameters I can specify, that's the gamma as well as C parameters. So the gamma value will be ranging from -0.0012 to 1. So that's a normal range, we can do it. Again, so this is correct, the gamma value, it is 0.001 to less than 10. This is the range we can use it. And this is going to be the C value normal range. I'll just show you the difference when I change this parameter there in the algorithm. We'll try to apply the SVM there in the same data set. Just try to import the libraries here. Again, I try to load the data here. So the next step is that I need to create my X and Y. So this is my X, this is my Y here. And the next part of what I will do, I'll just do my feature scaling. Again, this is going to be the same step. And after that, correct, I can do the render split here. So I have done with the 20% of the split. 80 record will be the test data set here. So now if I want to apply my support vector machine, SVM, so this is what I can use it. And here I just use the kernel equal to sigmoid. So that's what I'm just using it. And by default, kernel is going to be RBF. So these are the default C value equal to 1, kernel default equal to RBF. So this is what you're able to see. So here I'm not going to use the default right now, and I'm using the sigmoid kernel right now. And my model is ready. And if I try to do the prediction, I'll just try to do the prediction for full data set, ypred equal to, so this is the model name, classifier dot predict. And I'm doing the prediction based on X here. And this is what I'm printing here. So here you can see that one, I'm getting the result for both 0 and 1. But whenever I use the naive-based algorithm, everywhere it was predicting as 0. But when I change the algorithm, you can see that when the result is coming both 0 and 1. So now the next question is that, will it give more accuracy? So it is not necessary that it should give better accuracy. So obviously correct, the actual and the prediction, it should match. Then only the accuracy is going to increase it. So how can I check that one? I can use the accuracy score, confusion matrix, or the classification report. So here, correct, I can just check the accuracy with the help of my accuracy score here. And you can see that on 57% of accuracy here. So that means correct, the accuracy is coming down. So that shows that when there are more misclassified reports are there. So to understand more which category we have more misclassified records, so we can use the classification report or the confusion matrix. So if we check the classification report and the confusion matrix here, and you can just analyze it. So which predictions having more issues? Obviously, you can see that one. Most of the predictions are coming proper for the category 0 because I'm getting the precision and recall 67 here. But you can see that one corresponding to 1, the values are coming as 40 and 41. So that shows that when the predictions are not proper there in the category 1. So that's what you're able to see here. So again, if I want to know the exact number of records which is having an impact, you can just check there in the confusion matrix. So if you do Y and the Y pred here, and if you just give the confusion matrix, you would be able to see that when 85 records are misclassified for category 1. So if you see that when misclassification is more than the properly classified. Properly classified is 58, misclassified is 85. So that shows that when that's the reason this number is coming down. So even correct, it is coming less than 50%. The reason is that the misclassification is more than the proper classification. But here that is not the case. 171 is properly classified, 86 is misclassified. What's the total number of records equal to 257? So here equal to 143. Out of that, only 85 misclassified and 58 is properly classified. So that's what you can see here. So this is what correct whenever I use the kernel equal to sigmoid. And again, correct, if you want to compare line by line. So what we can just create a data frame out of this with the original data and the predicted data. So this is what you can just create a data frame. The side by side, you can see the values. So this is my predicted column. So Y pred, and the Y pred, if you see that one, this is an array. So Y pred, if you see that one, this is an array here. It's a one-dimensional array, and I cannot concatenate that with the data frame until and unless I'm not converting that to a data frame. So this is a step. I just try to convert it. Again, correct. If I want to convert this to a data frame, I can just give pd.data frame. It will be converted to a data frame. So whatever correct, if you want to convert it, you can just give here as pd is for the pandas.data frame. So here it will be converted to the data frame here right now. So now I have my df1. The df1 is my original data. So this is the data which I have. So now if I want to get an additional column with all the predicted value, what I can do, I can just concatenate these two. So how can I concatenate it? So the command which I can use it pd, that is pandas.concat, and I need to open and close bracket. And inside that one, the data frames I need to give within a square bracket. So this is the df1. I need to concatenate with this. So either I can just give full name pd.dataframe ypred, or maybe correct, I'll just create one variable y df. I'll just give one name here. And this is what I just going to specify to make it a bit simple. And this is one correct. I'll just keep that in the square bracket. So now this is going to concatenate it. And here, one more thing, correct, if you use the concatenation operation, what will happen? It is something like acting like a union. The concatenation is going to happen row wise. So that means df1 will, all the records will be coming. The first 400 records will be there. And below that, ydf will be getting added. So that's what my original data set equal to 400. You can see that when the total number of records has gone to 800 here right now. So that's not expected, right? I want to see an additional column here. So if I want to do the concatenation side by side as an additional column, I need to specify axis. Axis equal to 1. So then correct, it will add like a column here. So this is going to be the purchase column. This is going to be the predicted value. That's what you added here. Since correct, this is coming from an array, there is no column name is not there. So we can specify the column names, etc. So that's what, while converting it pd.data frame, we are specifying the variable and we are passing the column name as well, y prediction. And we are creating the data frame and we just concatenate it here and we are displaying it here. So that way, correct, the data frame concatenation is working. So similarly, correct, we can apply the joins. As we covered, we can join the inner join, left join, etc. by using the merge statement. So now if I want to display the 10 records is not enough. If I want to view around 50 records, I can view here. So this is what you can see, the purchase column, 0, 1 is coming, and the predicted column, this is what you're able to see. So these are correct, the properly matching. These two are, if you see that one, this is misclassified. Actually, this is 0, but predicting as 1. Again, here, this is misclassified. Actually, it is 1, but predicted as 0. These all are misclassified. Again, these all are misclassified. All these are actual 1, but predicted as 0. So there are many misclassifications are there. So here it is predicting as 1, but actually it is 0. So because of this misclassification, even though the data is coming 1 in multiple places, you're not getting the proper accuracy. The accuracy is 0.5725. So that's what you're able to see. So this is what we use the sigmoid kernel. So next, correct, we'll try to use the next one. So this is what we use the sigmoid. So next I can use the poly. It's a polynomial one, I can use it. So my model is ready. And I'll try to execute the same steps again. So this is equal to polynomial, classify.fit, creating the model, try to predict for the complete X. And we are just checking the accuracy here. So here you can see the accuracy is 64%. But you can see that everywhere it is predicting as 0. So that's the reason corresponding to 1. We can see everywhere it's coming as 0 here. So all the values are predicting as 0. So that's what you can see. And if you want to check the value, you can just give here as widespread. You can see that all the values are 0 here right now. So next, I'll just go further. This is polynomial, sigmoid. Then I can split by using a linear curve as well. So this is the linear option which I give. I'm getting the same accuracy like sigmoid. I just give the polynomial. Everything is predicting as 0 here. So this is the second parameter, third parameter which I specify. So the rest of the steps, correct, is going to be the same. Only the parameter you need to modify here. Next parameter which I want to give, that is RBF. So the full form for RBF is, it's going to be radial basis function. So whenever the data is very irregular, we can use the RBF function here. Not the RBF kernel, not function, sorry, RBF kernel. So here if you see, everywhere you can see that this is predicting as 0. So these are the parameters we use for polynomial, poly, sigmoid, linear, and the RBF. So if you compare all the algorithms, so the core point which we need to learn, how we can call the algorithm. So that's correct. Compared to all the algorithms, each algorithm, only couple of sentences are different. So the sentence which is different here, this is the 3 sentences you need to learn from each algorithm. So the rest of the steps, what we did is common. So these are the 3 sentences you need to learn. So the logistical regression, from where you need to import it. sklearn dot linear model import logistical regression. Again, from where we need to import KNN, from where we need to import neighbors. Then from where we need to import support vector machine, etc. So that's only difference. If you are able to do this, so that is more than enough. The next it's going to be, we need to give this function SVC, open and close bracket. And even correct, so you don't need to by heart any of this. So once you give SVC, only thing we need to import it. So here correct, I can just give SVC. Again, if you want to know what are the parameters, except you can press the shift tab here. So there is one kernel is there, And if you just scroll down, you will come to know what are the kernel options I can give it. Linear, poly, RBF, sigmoid, pre-computer, etc. Correct. All these things we can just give it. So like that, even if any syntax is not coming, etc., you can just get from the drop down, etc. The only thing you should know what's the name and from where you can import it. Once you know it, you will be able to get. And once you do it correct, the rest of the statements, we can see that when this is same. The process is going to be the same. So now I'll just show you some difference. The other two parameters which I specified, that is C and the gamma value. So how we can pass that parameters. So before that one, I'll just try to plot this data. So by using a color mark here, import some of the colors, and here come up here. And so these are the default. So these are the default colors which I'm trying to use here. Now correct, I want to plot the graph by using a function, just only for plotting the graph. So now what I do, I just create my model again with sigmoid. So why do I use sigmoid? Correct. So if I use the sigmoid, at least I'm getting the prediction. So I'm just getting the prediction there in both categories, 0 and 1. The other cases, correct, I got the prediction only one category. So that's the reason I just try to create the model again with the sigmoid. And after that, correct, I just want to plot the graph here. So if you know the data, how it looks, yesterday we plot the graph, the scatter plot, and we know how the data looks. So you'd be able to see that when the data is fully scattered here. So this is the actual data set. And in addition to that, correct, I'm just trying to do the predicted part as a shaded portion. As a shaded portion, I want to display the predicted part here. So that is what I'm going to use the decision boundary. The decision boundary is the function which is created. So that's the function which is created here again. So this is correct again to plot the shaded part. So this is what we are able to see. So whenever I created the model, I'll keep it together. And I just plot the decision boundary here. So when I created the model with the sigmoid, so the output looks like this. So whatever the dots is coming, this is the actual data. And the shaded part, you can see that one, this is going to be the predicted shaded part. So this is corresponding to 0, and this is corresponding to 1. The green part, you can see that one. Obviously, only less number of records there in the green part. So that's the reason if you see the sum of these two numbers, this is the predicted value, right? The predicted sum, it will be small number compared to this. So that's what you can see. And obviously, both the groups correct, both 0 and 1 is there. So both the cases, you can see the misclassification is there. So now I just try to adjust my C parameters. So now correct, instead of this sigmoid, if I try to use RBF, let's see how it looks, RBF. RBF, you can see that when the prediction is happening only one category. So then you should not get shaded part at all, because the shaded part is for the prediction for category 1. So if you see here, this is what you are able to see. The complete part is the red color. So that means the complete prediction is in one color here. That's what you're able to see. So this is a combination of prediction and the actual value created here, and the predicted value like a shaded part. So now what we are trying to do, we want to adjust the C value here. So by default, whatever the C value, that's what we provided. So now correct, I just try to give my gamma and the C value here. So I'm just giving my gamma equal to 0.001 and the C value equal to 1 here. So earlier, correct, whenever I use the sigmoid, so you are able to get two classes of data. So whenever you are not giving this parameter gamma and C, it was going with the default parameter, and you are able to get the predictions there in two categories. Or let's try to give a default value here for gamma. C. See the default value equal to 1 and gamma. Okay, correct. Again, if I just try to give gamma value equal to 1, gamma equal to 1, C equal to 1. So here, correct, you can see that one. This is going to be the prediction one. So now what will happen if I try to reduce the gamma value? What the system will try to do, the system will try to include as much as record there in the category 0. As much as record in the category 0. So that means, correct, how it want to, if it want to include as much as record there in the category 0. So out of that one, correct, both the category, if you see that one, 0 having the more number of records than category 1. If it want to include more records in category 0, obviously, correct, it need to reduce the green shaded part. So that's what it will try to do. It will try to accommodate more values to category 0. So obviously, correct, the shaded part need to reduce it. So that's what you would be able to see. Earlier it was 1. So maybe, correct, I'll try to give 0.5 here right now. So let's see. So there is not much difference. So maybe, correct, I'll just give 0.1. So if you see the 0.3, it reduced further. Earlier it was 1. And when it become 0.3, correct, you can see that when this green color part is getting reduced. And with what condition it is getting reduced, the system tried to incorporate more values to category 0. So that's what it is happening as a part of gamma parameter. So next, correct, if I try to increase the C parameter, what it will try to do? It will try to penalize the misclassified records. What are the misclassified records? The misclassification is happened there in the category 1, because many of the green records are misclassified. It is classified as 0. So that is what, correct, if you try to increase this C value, so maybe, correct, I'll try to give it as 10 here. Again, you would be able to see that when this part is coming up. So that means, correct, this green color shaded part is coming up. So that means to a certain extent, I can see that when one is to incorporate the value more to one class, and here, correct, is try to penalize it. So these are the parameters which we can adjust it. The based on that, my predictions value is going to change it here. So here, correct, I'll just keep this gamma. So maybe, correct, I'll just keep the gamma equal to 0.5 and the C value equal to 10. Obviously, you can see that when a better higher area is coming. So now, correct, if I just try to reduce the C value, obviously the penalization part is coming down. So obviously the gamma is going to take more advantage here. So that's what it is really able to, you can see here how the values are getting changed. So these are the parameters which we can adjust it. So that's what it is specified. Control the distance of influence of a single training point. A low gamma value indicate that a large similarity radius, which will result more input being grouped together. So that means, correct, if there's a low value of the gamma, that means, correct, it will try to classify the 0 records in a group more. It will try to classify 0 records in a group. What will happen? Obviously, correct, there will be more misclassification there in one. So that is really happening. Again, the high value points that one need a heavy close each other to be considered as the same group. Okay. Again, the C value, if C is small, the penalty for the misclassified points is low. So the decision boundary with the large margin is chosen here. So this is correct. Whenever you give a small C value, the misclassified records penalization, it's small here. So that is going to be the problem. So what you can just adjust the C value and the gamma value, and you can see the difference. So how it is getting increased and how it is getting changed. So in this example, correct, I have given some of the C values. So this is with the C gamma combination. So this is equal to 0.001. This is equal to 1. This is what you can see. Again, here correct. So next I'll give C equal to 1, my gamma equal to 1. So another combination which I get. Let's evaluate it. Again, this is another. So I'm not changing the kernel. The kernel, if I change it again, the values will change. I'll keep the same kernel, only C and the gamma, which I just adjusted. So the first one you can see is gamma equal to 1, C equal to 1. So this is what you're able to see. Again, here the gamma I kept constant, but I reduced the C value here. Earlier the C value and the gamma value was 1. So now correct, I reduce the C value. So gamma is constant here right now. So obviously correct, the gamma C value I reduced it. You can see that and everything is predicting as 0. So obviously correct, whatever they try to do for penalize for the misclassified records, that is reduced, and you can see that when everything is going to blank right now. So now correct, here you can see that when I'm giving, so both are 1, you can see this, the equal mix is coming. So now correct, I just try to give a high value of gamma and a very high value of C here. So obviously correct, since the gamma is very high and the C is correct, again it's very high, this is what you're able to see. So now I'll just keep my gamma equal to 1. Let's see how it looks. Again here correct, still there is a gap. So now correct, if I just try to give high value for gamma and C, you can see that when these points are coming almost closed. And this is a misclassified record, 54%. So here also it is 54%, 159 and 98. So there are slight difference in the number of records. Obviously correct, it will be there. So here you can see that when this is more wider here, but again it is not that wider. Even the correct, this is touching each other from all 3 sides. That is equal to gamma equal to 100, C equal to 10. That's what you can see. So now correct, both are 1 here. This is what you are able to see. So you can just adjust these parameters and you would be able to change the accuracies accordingly. Now correct, I just try with the RBF as well. So the earlier one which I tried with sigmoid. Again, the gamma equal to 100, C equal to 1000, and I'm getting around 93% of accuracy here. So let's see how the decision going to look. So here correct, you can say the sigmoid, you know that when it is going to create very irregular shapes, right? So whenever it wants to split the data in an irregular format, so we can use the sigmoid function. So whenever you use the sigmoid, so this way correct, the split is daily going to happen. Not the sigmoid, sorry. If you use the RBF, RBF is used to split the data whenever the data is not in a proper form. So we cannot split by using a linear or the sigmoid curve. So this way correct RBF looks like. So just giving very high value for gamma and very high value for C. So now correct, if I try to reduce this gamma equal to 1 and the C equal to 1 here. Again, I'm getting 64% of accuracy. And let's see how the decision boundaries. So specifically correct how the split is going to happen, the shaded part. So here you can see that one I'm getting only in one category. So now I'll just try to increase this to 100 here. So you can see that in this way, different groups are getting created. So based on that, you can see that all these values are changing here based on this parameter. This is again 0.5. The 0.5 correct, again, it's a negative impact because the gamma I reduced it. So it will try to increase the 0 value. It will try to increase the 0 value proper classification. Now again, this was the one, I'll just make it as some 500 here. Again, everything is 64.75. So this is what you can see how the classification is going to look like. So that's what the different parameters we have. So given corrects one data set itself, we need to try with the different combinations. So based on that, the predictions will vary, the result set will vary.
All right, let's test your knowledge. Here's a question for you. What is the purpose of the yield keyword in Python? Option A, to define a generator function. Option B, to raise an exception. Option C, to import a module. Option D, to create a class. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there! Want to master data analytics and automation? Our Advanced Data Analytics with Python course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about data analytics and automation with Python. It's like a toolbox for handling data, from analyzing trends to automating tasks. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is really affordable. Ready to become a data analytics pro? Sign up on our page now. And for more info, check out ZaranTech's website.
Okay, so this is the decision tree. And the concept behind the decision tree is that the data need to be splitted in the form of a tree. So here, this is a small data set which we have. And what it is specified. So we have the data for around 14 days. And based on some of the parameter, we want to check whether the match is going to happen or not going to happen. So there are two possibilities. We want to check whether the match is going to happen. So we have around 14 records here. And these are the different scenarios we are considering. One is the outlook. So the outlook, if you see, there are three combinations are there. The outlook equal to sunny, overcast, and rain. Humidity, there are two possibilities. One is high and the normal. And wind, there are two possibilities. That is, wind is weak and strong. So based on that, we want to check whether the match is going to happen. So how the decision tree is going to work? So if I just plot here, so the decision tree is going to work like a tree-like structure. So there will be a root node will be there. And the root node will be splitted based on different scenarios. Again, there is one level below that. Again, that also splitted. And it is not necessary that the level should be same. So maybe correct. So this can be the leaf node here. Again, in this side, if you want, we can split it. So 2 or 3 levels we want, we can split it. And the last node which is coming here, that is called the leaf node. So if you see the terms, so what is this? This is a root. And here you can see that this is the branch and this is the leaf node. So it is not necessary that always it should be binary split, only 2 split. So there might be chance that it can be split more than 2 as well. So that way, the tree structure is going to work. So now, correct, if you see the example here, how it is going to work. So the first, correct, if I consider the outlook column. So the outlook, there are 3 possibilities are there. If you start splitting, so the first parameter which I consider here, so it is going to be the outlook column. And there are 3 possibilities that I can think. So here we have sunny, overcast, and rain. So we are here rain, it's equal to overcast, and this is yes here. So these are the 3 possibilities which we have. So now the correct next question is that, do I need to split this further? Do I need to split this further? So do I need to split this further? So that would be the question. So if you see the data set here, so the first parameter, if you see that one, so the outlook, you can see this is sunny day. And the output, I'm not considering the other variables at this point. I'm considering only the outlook and the humidity right now, not the outlook and the play right now. So here you can see there is a sunny day. The play is not happening. Sunny day, the play is not happening. And here you can see that on the sunny day, the play is not happening, match is not happening. So here you can see that on sunny day, the match is happening. So here again, the sunny day, the match is happening. So here again, okay, so there are 5 outputs are there, 1, 2, 3. So here no match, here no match, then here no match, then here there is a match happening, here there is a match. So total, if you see, there are 5 records which is related to outlook equal to sunny, and the 3 days match is happening, 2 days no match happening. So that's what you are able to see here. So now if I see the next parameter here, overcast, so you can see that when the match is happening here, again the match is happening, 2, again the match is happening, again the match is happening. If you see all the 4 scenarios, you are able to see that when the match is happening. So the first one, out of 5, 3 no match, and the 2 matches happened. Again, second scenario, all the cases you can see that when the match is happening. Again, the third one, if you see, this is yes, rain, again yes, rain no, then rain yes, rain no. So here you can see that one, this is a mix of yes and no. So what the system will try to do, or as per the algorithm, if you are able to get a 100% result, so here if you can conclude with a 100%, in this case you can see that when the overcast, all the cases you can see that when the match is going to happen, then what the system will do, it will not split it further. So that is going to be the leaf node. So it will not, so there is no need to check what would be the humidity or the wind speed. Irrespective of that, in this data set, you are able to see that when the overcast, all the days you are able to see the match is happening. So that shows that when irrespective of humidity and wind, we can conclude that when if the outlook equal to overcast, the match is happening. So that's what you are able to get it from here, 1, 2, 3, 4, all the cases. So that means the outlook is the case, and that is going to be the leaf node, no split further. So now if you see the sunny, you can see that there are 3 cases no match, then 2 cases there is a match happened. So what we need to do, we need to see this combination, the outlook and the humidity combination. That's what we need to see. So here if you see that when the outlook equal to sunny and the humidity equal to high, no match, again sunny, humidity equal to high, no match, then it's a sunny day, humidity equal to high, no match, then sunny day, the humidity equal to normal, there is a match, sunny day, there is humidity equal to normal, there is match. So here, correct, if you see these 2 combinations, you can make a conclusion. So whenever this combination equal to sunny day and the humidity equal to high, you can see that on all the cases, there is no match. So that's what you can see here. Sunny day it is high, sunny day it is high. Again, the sunny day it is high, no match happening. So that's the conclusion we can make it. So the first case, when it is an overcast, so we no need to consider the second column. The first column itself, we are able to conclude if the day is an overcast, 100% the match is going to happen. So no split is required. But in this case, so sunny, so that's the case. You can see that when some of the days the match is happening and some of the days it's not happening. So that's the reason we are going with the 2 columns here right now, outlook and the humidity. So whenever you see the combination, whenever the sunny day and the humidity equal to high, there is no match. So that means all the cases you are able to see. Again, the sunny day, the humidity equal to normal, all the cases, you can see that when the match is happening. So that means we have 2 scenarios, the match is happening here. So that's a conclusion. So here, the sunny day, 2 possibilities we need to check, high, then this is equal to normal, and this is no need to split it further because we are getting 100% result here. So now if you see the rain, the possibility here, if it is equal to high, rain and the humidity equal to high, there is a match. Rain, humidity equal to normal, there is a match. Again, rain, humidity equal to normal, there is no match. So if you see this combination, obviously you cannot make any decision because here 2 statements are there. The rain, humidity equal to normal, there is a match happen. Again, rain, humidity equal to normal, there is no match. So obviously, correct, this is not the right combination. The outlook and the humidity, I cannot consider the right combination because I'm getting both the results if you see. So now if you see the combination, the humidity and the wind speed, So the wind equal to high, weak or strong. So we don't need to worry about the sun. It's already reached the pure subset, the pure set we got it. So now if you see that one, the rain, if you consider the rain weak, you can see the match is happening. Rain and wind equal to weak, the match is happening. Rain, wind equal to strong, no match. So that means this is a combination we can see. So the rain and the wind equal to weak, all the cases you are able to see that what the match is happening. So rain, the wind equal to strong, no match. Like rain, wind equal to weak, there is a match. So that means there are three cases the match is happening, and the rain, wind equal to strong. Two cases there is no match happening. So that means correct. If this is the combination, we need to see outlook and the wind. And if you see this combination, it's a rainy day and the wind equal to weak, 100% you are able to see that one, the match is happening. And the rain, the wind equal to strong, 100% there is no match. So that means, so that way correct, so we need to conclude it. So that way the decision tree is going to work. And here if I just go further, outlook, there are 14 records are there. And there are 9 days the match is happening, 5 days no match. So how this 14 days are splitted here? 5 related to rainy day, 4 is related to overcast. Again, 5 is related to sunny. So that is 5 plus 9 equal to 9, 5 plus 4 equal to 9, 9 plus 5 equal to 14. So that's what you're able to see. Again, we conclude that when it's a cloudy or the worst overcast day, 100% there is match happening. So we are not going to split it here. Again, it's a sunny day, 2 days the match happened, 3 days no match happened. So we are going to split it into further. So based on the humidity equal to high or normal. So we are getting a pure subset. Again here, so we cannot use the humidity part because that's again giving contradict. We are not able to get the proper result. So we are going to use the column that's a windy and we are able to get the proper result here. So that's what again represented here. The outlook, the first we are going to split based on the sunny. Again, there are 2 days, 2 yes and 3 no's. So we need to split it into further. It's an overcast day. All the days the match is happening. So it's a pure subset. We are not going to split. This is what we are going to split it further, the rain. So there are 3 yes and 2 no's. So we need to split it into further. So now the next question will be that on what basis I choose outlook? So why can't I start with wind? Or why can't I start with humidity? So why should I always start with outlook? So can I start directly with humidity equal to high? Then I can split based on the wind. So then after that, can I split based on the sunny day? So that means correct outlook column. So that is decided by the 2 parameters, which is at the decision tree. So that is called entropy and Gini. So these are the 2 parameters we need to consider, and that is going to decide based on which column we want to do the split. So based on which column we want to do the split first. So the entropy is used, and we will find the parameter that's the information gain, and which column is having highest information gain, that will be the first split. So if I just explain about the entropy here, this is what you are able to see my data set, all the 14 records. And here you can see that when this is 9 days, the match is happening. 5 days, there is no match. So total 14 and here. And this is the formula for the entropy here. The entropy equal to sigma 1 to C. C is the number of classes. How many classes we have? So we have 2 classes here. And this is minus pi log 2 pi. So this is what we need to consider here. And if I try to specify the entropy of the population, so if I just write the formula here. Okay, so this is the formula for entropy. And if I want to find for the entire population first, so you can see that there are 2 possibilities, that is yes or no. So the overall entropy, if you want to find out here, or the entire population, we need to check how many yes or no. So there are 5 no and 9 yes is there. That's what it is specified, 9 plus that is S equal to 9 and 5 equal to no. So if you apply the entropy, so what you need to specify here, minus P. So P of I, what is the probability of S? So what's the probability of S here? So minus of probability of S. The probability of S is equal to 9 divided by 14, log to the base 2, 9 divided by 14, minus, what is the probability of no? The probability of no equal to 5 divided by 14. So total you are able to see there are 14. Out of that one, 5 are no. So that is equal to 5 divided by 14, log to the base 2, 5 divided by 14. So that's what you are able to get the entropy. We are going to get is 0.94. So that's overall entropy you are going to get it here. And if you want to calculate it, so if I want to replace the numbers here, so this is going to be minus 9 divided by 14. So that is equal to 9 divided by 14. That is equal to minus 9 divided by 14. Again, multiplied with log 2. Log. So this is equal to minus of 9 divided by 14. So that need to be multiplied with log 2 9 divided by 14. Log 2 9 divided by 14. Again, this is a sigma, you can see that one. So the formula equal to sigma. So that means we need to add this one where the category equal to no. So that means again it is going to be minus. So this is equal to 9 divided by 14. So corresponding to no, we have 5. So this is going to be 5 divided by 14. 5 divided by 14. So that need to be multiplied with log 2. Again, that is again 5 divided by 14. So if you just try to calculate it, so you'd be able to get the result. So this is what you're able to see the result, 0.94. So 9402, that's the entropy for the entire population. So now what we'll do, we'll just try to find the entropy for outlook. So the outlook, there are 3 possibilities are there, that is sunny, overcast, and the rain. So that's what we try to do. So corresponding to sunny, there are 5 records are there. And out of that 5, there are 2 yes and 3 no. So sunny day, correct, if you see, there is no here. So that's equal to sunny day, there are 3 no, 1, 2, 3 no, and the 2 yeses are here. So that's what you're able to see, the 2 and 3 no. Again, if you try to find the entropy of sunny here, so what is the probability of yes in case of sunny? So sunny, there are total 5 days, 5 days the match up. Total there are 5 records are there. Out of the 2, the match happened. That is equal to minus of 2 by 5, log to 2 by 5, minus of 3 divided by 5. So that's the days correct. Out of 5 days, the 3 days match didn't happen. Log to 3 by 5. So the entropy here, you can see that 0.971. So similarly, correct, we can find entropy overcast. Again, entropy for the gain, entropy for the rain. We need to find the information gain. So we need to find the information gain here. So the information gain, if you want to find out, that is equal to entropy of the overall population minus the formula we need to apply. The entropy of the entire population minus sigma population minus what is the probability of no match, that is equal to 5 divided by. So what is the probability of sunny day here? So sunny day, there are 5 records are there out of 14 into entropy of sunny, it's equal to 0.971 minus what is the probability of overcast? Overcast, there are 4 records are there, that is equal to 4 divided by 14, entropy of overcast. So the overcast, you can see that when this value will be 0 because all the values correct, you can see that on this That is equal to 4 divided by 4 log to the base 4 divided by minus corresponding to known there are here you can see that one 0.94. So that's the entropy of the sample, the entire population, minus 5 divided by 14. So 5 is the number of records where the outlook equal to sunny into entropy of sunny. So that's equal to 0.971 minus how many records? The overcast, that is 9 divided by 14 minus 0 into 0. Again 5 divided by 14. So what is going to be the entropy of rain? So the overall, this is the value you are getting here, 0.24. So that's going to be the information gain you are going to get for the outlook column. So similarly, we need to find the information gain for the humidity. So the information gain for the humidity, this is the number you are going to get. So that's equal to 0.1516. Again, if you see the information gain for the wind, so this is what you're able to see the information gain. It's equal to 0.04. So we have the information gain, which we are going to get from all the three columns right now. So that's what you can see the outlook, the information gain equal to 0.24. Humidity, the information gain equal to 0.15. Again, the wind, the information gain equal to 0.04. So overall, you can see that one, the highest information gain is coming from the outlook column. So this is what you are able to see 0.24. The other case, humidity, you can see it's 0.15. Again, it's equal to 0.04. So the system will try to do the first split wherever the highest information gain. So that's the reason we can start with humidity outlook column to split it first, because the highest information gain is coming from this particular column. So the first split will be based on the outlook column. So next, what the system will try to do. So now correct, we conclude that one, the first split we need to do based on the outlook. So now the system will try to get outlook, what are the different combinations are there. So we have sunny, we have the overcast, we have rain. It will try to get the details related to the sunny. How many records are there? There are 5 records. And it will try to find the information gain for the next column. So that means when it's a sunny day, what's the information gain we are getting from the humidity, and what's the information gain we are getting from the wind. So this is correct. We are not finding for the overall population. So this is for the outlook and the humidity and the wind. So now if you see here, this is going to be the information gain for the humidity 0.97. Again, information gain for the wind, you are able to see that one 0.0192. So if you compare these two, so which column having the highest information gain? So that is going to be the next split. So here the humidity are getting 0.97 and here you are getting 0.01. Obviously correct, the 0.97 is having the highest information gain. So whenever it's split first based on the sunny, next it is going to split based on the humidity column. So that's what it is going to happen. So next correct, the overcast, there is no need to split it. Again, the rain also, it will check what's the information gain you are getting from the humidity, what's the information gain you are getting from the wind. The humidity, we are getting the information gain equal to 0.01. And the wind, you can see that the information gain equal to 0.97. So that means whenever the outlook equal to rain, the next split is going to happen based on the wind, because the highest information gain you are able to get from the wind column. So, but whenever the outlook equal to sunny, the highest information gain is from humidity. So that's the reason when it is sunny day, the next split is based on the humidity. But if it's on rain, the next split is happening based on the wind column, because the highest information gain is there. So that way, the decision tree tried to split the data based on the entropy. So similarly, correct, we have one more option is that's the Gini, and this is the formula which is related to Gini. So the same way, it will find out the Gini gain, and wherever we'll get the highest information, based on that, it will try to split it. So that way, the decision tree, the splitting is going to happen. Otherwise, I'll directly go to the exercise. So we'll take up the same data set and we'll see what is the accuracy, etc. We are going to get it from here. So we'll just try to import all the libraries here. So we are just trying to get NumPy, Pandas, Matplotlib, Seaborn, confusion matrix. Then we try to get the train test split. All the required libraries we just imported first. So next we try to load the data set. So this is what you are able to see. So we can load the data set. So the same data set the social network adds. So after that, corrects, we need to create the X variable. The X is my independent variable. So I'm just considering 2 columns here right now. That's the age and salary. So any questions on decision tree, how it's working, the technical perspective or the formula, how the entropy calculation, etc. Now we have X here. So we try to create X. I just pull 2 columns here, age and the estimated salary. Next, I'll pull Y. So Y is my last column, which I want to use it here. So next, what's the next thing I'll need to do? I need to do the feature scaling. So I'm just trying to do the standardization. So sklearn.preprocessing import standard scaler. So we just try to standardize the data. And you can see that the data has come in common standard. So the next what we need to do, we need to do the train the split. So splitting the data between training and the test data set here. So 20% is going to be the test size. So obviously there are 400 records. And if you just see xtrain.shape here, 320 records, and the test data set, the shape will be 20%, that is will be 80 records. That's equal to x underscore test dot shape. 80 records are there. So now I can use the algorithm. So if I want to use the decision tree, again I can import the, so till this point, all the steps are same. So if you want to work on decision tree, so what I can use from sklearn dot tree. So from the tree currents, we need to import the decision tree. So that's what I try to import it here from sklearn dot tree, import decision tree. Okay. So the decision tree also, you can see that there are 2 algorithms are there. One is decision tree classifier and the decision tree regressor. So this, whenever the output, if you want to predict it's a regression problem, so we can use decision tree regressor. And here this is a classification problem. So we want to predict a 0 or 1. So that's the reason we are going to use decision tree classifier here. So that's what we need to use, decision tree classifier. Then we can create one variable dt. Any variable you can just give it here dt. And here we just try to specify decision tree classifier. And here one of the parameter we can specify. So that means the criterion is the parameter we can just specify. The criterion is going to decide so whether we want to use entropy or we want to use Gini. So what's a method we want to use to split the data to create the tree. So by default it is Gini. So that's going to be the default method. And I just executed this. So next correct, I need to create one more variable dt. And I can specify dt dot fit. So I need to fit the model based on my training data set. So I can use x underscore train here. So this is the main difference. Now this is the, so all other statement what we executed, that is common for all the previous algorithms. And this is the place where we need to import the algorithm and we can use it here. X train, and it is going to be X. So this is going to be Y underscore train. So we can use X train and Y train, we can create the model. So now if I just try to print display dt, so this is what you're able to see, decision tree classifier. So now if you want to predict it, I can use dt.predict and predict based on what? I can use the test data set to do the prediction, x underscore test. So this is what you're able to see the prediction. So basically correct. In this data, whenever I use this algorithm, you can see that when the result is not happening, only to 0 or 1, only to 0. So we are getting the result in both the categories here. So now we want to check the accuracy here. So because we know that when we use SVM and when we use the sigmoid, etc., the system was able to do the predictions in both the categories, either 0 or 1. But at that point, you notice that when the accuracy is very less, the accuracy is very poor. But here, if you want to check the accuracy, we can just check it. So we can use accuracy score. sklearn.metrics import accuracy score. So this is what we have. So then we just can use accuracy score. and I want to test the accuracy for the test data set. So this is what I can use it. Here I didn't create the variable y underscore pred. So this is going to be the prediction variable. And I'll just try to display y underscore pred here. And this is what you're able to see the accuracy. We are getting an accuracy of around 56% here. So now what we'll do, we'll just try to do the prediction for the entire data set. So here, if I want to do the prediction for X test, I want to do for X. X is going to be the entire data set. Now we'll just try to quickly check the accuracy here. So at this point, we need to use Y. And here we can see that one, we are getting around 91% of accuracy. So that's what you're able to see here. So now if I want to know what's the number of misclassified records, so we can use confusion metrics and we can use the classification report also. So this is equal to confusion metrics. So how many records are misclassified in each category? So here you can see that when corresponding to category 1, there are 21 records misclassified. Corresponding to category 0, there are 14 records got misclassified. So compared to 0 and 1, more misclassification is there in category 1. So now if I want to check how the split or the prediction is for both 0 and 1, so we can use the classification report. So we can check the percentage there in the classification report, and this is what you're able to see. Overall, the 91% accuracy. And here you can see that on my precision and the recall are good for category equal to 0 compared to 1. Because compared to 1, 0, the predictions are good. The number of misclassified records are very less compared to 1. So that's the reason we are getting good numbers here. And this is what you're able to see for 0 category. So precision equal to 90 and the recall equal to 0.85. So that's what you're able to see. So now if I want to export this data to an Excel, etc., again, if I want to compare column by column, so this is what we can do. We can just create a data frame. So my predicted value, I can just convert to a data frame here. And the same thing, I can just concatenate to my original data set. My data set equal to df1. And we are just displaying the result. And if I want to display at least 50 records here, we can just display. And here you can, the number of misclassifications are less here. So here one misclassification. So here there is a one misclassification. And all these correct, you can see this is properly classified. This is a misclassification, but all these ones are properly classified. So there are misclassification. Again, this is again properly classified. So that's the reason we are able to get a better accuracy, around 91% of accuracy. So that's what we are able to get here. So now we know that. So we can use two parameters. One is Gini, and the second parameter we can use is entropy. So we can quickly see if we use entropy, are there any difference there in the accuracy? Again, if you want to plot the graph also, whenever we are doing the split based on the decision tree. So yesterday, correct, the SVM, we have seen how the prediction is happening. So now, correct, if I try to plot the graph, so this is what you're able to see. The graph looks like this. So wherever the color is green, so that will be the predicted area corresponding to category 1. And wherever this red color, that's a predicted area corresponding to category 1. So here, correct, this way the predictions are happening. So it will try to accommodate as much as records and properly classifying it. But the earlier one, whenever we're using support vector machine, so the area was coming like this. So yesterday's example. So here the splitting is happening in a different way. So that's the reason the number of misclassified records are less. It will try to accommodate as much as green there in the green shaded area. So here and all, but in between anyway, there are misclassifications are there. So this is a misclassified record. again corresponding to 1, there are few misclassification as well here. So all these are, this is a misclassification for red. So that way you are able to see. So now if I want to create the same model with entropy, so this is what we use the Gini, and if we try one, we can use entropy here. sklearn.tree, import decision tree classifier, and we are just crawling decision tree classifier and the criterion equal to entropy. So my model is created. Next, if I want to do the prediction, so I can use keep red equal to, so this is my model name classifier dot predict. So predict based on what? The entire X I want to use for the prediction. And I'll just try to print the result here. This is what you're able to see. So here also both 0 and 1, the predictions are happening. So if I want to check the accuracy, I can specify accuracy underscore score here. And I can just compare with Y, and I can use this keep red here. So this is going to be the predictions which we want to use it here. So the 91% accuracy. So the earlier you are able to see bit higher accuracy. So this is equal to 91.25, but here it is 91%. So 0.25 less here. So when I use the decision tree with criterion equal to entropy. Next, I can put the classification report. So there won't be much difference. It will be almost same. So 91% you are able to see. Again, the confusion matrix also, if you see, there might be 1 or 2 records will be, change will be there in 1 or 2 records. So here, I just get the values here. So these were the numbers, 14 and 21. So even correct, there is no difference as such. No, why I'm not getting no difference? Because I used the wrong variable here. So there should be some difference because I have seen there is 0.25 difference in my accuracy. So this is what I need to use it here. Right? And there is some 1 or 2 records, there is a difference. So here 21 is same, but earlier there were 15 misclassification here. No, currently there are 15 misclassification for the category 0. Early it was only 14. So that's the reason, because of this one record change, you are able to see a difference of 0.25 there in the accuracy. So now if I want to plot the graph corresponding to this, so this is what you're able to see here. Again, this area, it looks more or less same, not much difference. So no difference as such. So this way the decision tree is going to work. And you also want, if you want, you can try. I'll just give you the main components which we want to try and we want to execute it. First, you can import the library here, the code libraries. Then obviously you need to load the data set. Then create X and Y. So this is my X. Then this is my Y here. And I'll just create the model. And I'll try to do the prediction. And finally, we want to print the accuracy. So can you try at least this part? I just kept only the important portions here. I just skipped all the standardization, etc. The basic things. So at least you need to import all the libraries, load the data set, then split between X and Y. So this is my X. Again, it's going to be Y. Then create the model and do the prediction. And at least print the accuracy. So these are the important statements which we can try. So I'll just wait here for 5 minutes. We can just try at least these important steps. So these are the steps where we are importing all the required libraries. So we are just loading the data, then creating X variable, creating Y. We are creating the model here, and we are trying to do the prediction. when we are just displaying the accuracy here. Okay, so here directly try to use X and Y. Even you can skip the train the split. So mainly correct, I want you to execute these steps. So any questions? Are you getting any error? Any issues? So the next one is the random forest. So the random forest is again, it's an extension of decision tree. And it's an ensemble learning algorithm. So that means it's not an algorithm by itself. It will be running on top of the decision tree. And multiple decision trees are going to create it here. So that way the random forest is going to work. So the same data set, so there will be multiple decision trees will be created, and the output we are going to receive. So here, correct, if I just specify, so the random forest, the multiple decision trees will be created, and the final output you are going to get. So here, correct, this first decision tree is going to predict yes, and the second decision tree is going to predict as no, and the third one is going to predict as yes. So the first is predicting as yes, second is no, third is yes. So you can see that out of 3, there are 2 yes and 1 no is there. So the final output, what you are going to receive will be the value which is repeating maximum. So that's the case for the random forest classification. And in case of random forest regression, it is going to be the average. So because the regression, you cannot expect both will give you the same. All the decision trees is going to give you the same. The values will be different. The final output, what you are going to get, so that's going to be the average in case of regression. But in case of classification, what is the output which is coming as maximum? That is going to be the final output. The multiple decision trees will be created on the data set. And the advantage here is that since we are creating multiple decision trees, so there won't be, so the model will be more perfect because we are tested with the different data sets. The multiple models are created and there is less chance for the overfitting. So that's advantage to a certain extent. If you go with the random forest, so the overfitting can be addressed. So now consider these are the 14 records. If I want to create 3 decision trees as a part of random forest, so definitely correct, we need to create 3 data set. So system will try to use the entire data set. It will try to pick up random records and the random data set will be created. So it is not like that if you have 1000 records and if I want to create 3 decision trees, it is not going to use the first 300 records for the first decision tree, next 300 for second, and the final 300 for the third decision tree. It is not like that. It is randomly pick the data, and the data, it can be repeated as well. The data will be repeated as well. So it will pick the data. And the concept is called the bagging. Bagging is the concept which we can use it. The replace with repetition, the data will be picked up, and the decision trees is going to create it. So here you can see that when the first one is going to predict no, second one is going to predict yes, third one is going to predict yes. The final output you are going to get is yes here in this case. So now this is what you are able to see how the data is getting picked up. So we have 5 set of records. So you'd be able to see that on my first decision tree, it is going to pick up second record, 0th record, second record, 4th record, 5th record, 5th record. So here you can see that when the record 5 is coming 2 times here. So the record 5 is coming 2 times here. Obviously correct, 1 record is missing. So which record is missing here? The record 1 is missing here. So when I create the second data set for the second algorithm, so you are able to see that when the record 4 is repeating here, 1 is repeating. So obviously correct 2 will not be picked up here. Record 0 and 5 is not picked up here. So this is the data set which is used to create the second decision tree. So here you can see that when this is the data set, it will be used to create the third decision tree. So you can see that when 0 is coming 2 times here, 1, 2, 3 is only once and 4 is only once. So the record 5 is missing here. The 5th record is missing. Again, here you can see that one record is missing. So we have 3 is coming 2 times. 2 is coming 2 times. 5, 1 is there. 0th record is missing. 4th record is missing here. So that's what you're able to. This is a decision tree created based on this data set. This is the decision tree will be created. And whatever the data set, what we create, it is called the bootstrap data set. And the final result, it will aggregate the result from the multiple decision trees, and you will get the final result. And the entire process is called the bootstrap plus aggregation. The bootstrap is the data set what we created, aggregate the data. The entire process is called the bagging. So bagging is the process which is used here as a part of bootstrap aggregation here. So that's what you're able to see. So any questions on random forest, I'll directly go to the example here. So random forest also we can create multiple decision trees. And obviously correct, since there is a decision tree is involved, we can specify the entropy and Gini parameter also here. So the which format we want to create the decision tree. So here again, we try to import all the libraries. So we are importing NumPy, Pandas, Matplotlib, Seaborn. So we are importing confusion metrics. We are importing trend split here. So we are just loading the data set. So that's what you're able to see. All the 400 records here. So next what we'll do, we'll try to create the independent variable X. I'm just pulling this age and the estimated salary, the 2 columns, my X is ready. So next what I will do, I'll just create Y. So this is what you can see, the Y variable we created. I'll just pull the last record and the Y variable is getting created. So now we standardize the data. So we can import standard scalar, min-max scalar, or the normalizer. So whichever is required, we can use it. So once that is done, so we'll do the trained split. So we are splitting the data between X train, X test, Y train, Y test. So the data X and Y, the X will be split into 2 X train, X test. Y will be split into 2 Y train, Y test. So now correct, if you are giving only one variable here, so you need to specify only 2 output variables. So since correct, I have specified both X and Y, I'm just giving 4 variables. So consider correct if you're giving only one variable here. So you need to specify only X train and X test. Now we try to create the model. And this is what we are creating. We are creating the random forest classifier. So it comes under the category ensemble. So if here also, if you see that there are 2 algorithms are there, one is the regressor as well as the classifier here. So from sklearn.ensemble, we can just import it here. And while importing, you can just get from the drop down. So here you can see that with the random forest classifier and regressor. So regressor we already used. And this is called the random forest classifier. And we can create one variable. RF is going to be the variable here. And we can just call the random forest classifier. And I can just give open and close bracket. So there are 2 parameters. Quickly we can give it. One is how many decision trees needs to be created. So if you're not specifying anything, it is going to create 100 decision trees. So that's what you're able to see. If you're not specifying anything, it will create 100 decision trees. Again, if you specify, the specified number of decision trees will be created. That's what the N estimators. Again, the criteria, if you're not specifying anything, it will be using Gini. So maybe correct, I don't want to create 100 decision trees because my data set is only 400 records. So maybe correct, I can just go with maybe 10 decision trees. I can specify that. And N estimator is equal to 10. So 10 decision trees needs to be created. And the next parameter, so that's the entropy or Gini. So let it create with Gini for the time being. So I'm not making any changes right now. So now if I want to do the fit, I can specify RF equal to RF.fit. And the fit based on what? X underscore train and X underscore test. So these are the, not X, sorry. I need to use Y underscore train here. So these are the two variables which I can use it. My random forest is ready. And you can just display RF here. So you can see that when the random forest is getting displayed here. Now, if I want to do the prediction, I can do rf.predict is equal to random forest dot predict here, and predict based on what? X underscore test data set. So I can see that when the prediction is coming in 0 and 1. So now if I want to check the accuracy, sklearn.metrics is import accuracy score. So just create one variable y underscore pred. So the predicted value will be there. And this is going to be the accuracy you can see. So here I need to specify y underscore test because I have the predicted result only for 80 records. If I give y here, I am expecting the prediction for all the 400 records. And this is what you're able to see here, 65% of accuracy for the test data set. So now correct, if I just try to do the train test split again, so maybe correct the accuracy will change because the test size is getting changed. I'll execute it again. And this is what you're able to see. It becomes 60 right now. Again, I'll just do the train test split, execute the model, do the prediction. And here again, 51. So because correct, the number of records are very less. So it shows that when, if I want to use this model, so we need to have sufficient number of records. So that's the reason it is changing very frequently. And I'll try to do the prediction for the complete data set. That is equal to X. And I will check the accuracy here. So here you'll be able to see that when the accuracy is almost consistent, there won't be much deviation. 89.75, that's accuracy you're able to get here. So even though correct, if you do the train test split again, do the prediction again, and this is almost consistent. So there are not much deviations here. Because then we are getting the deviations because of the test data set, and the test data set, the number of records are very less. So compared to decision tree, the accuracy is 2% less, but that should be okay here. So now if I want to do the classification report, we already got. So this is what we have the accuracy score. We will get the same accuracy for the classification report also. 400 records, 257 record category 0, 143 category 1. This is what you're able to see. Again, this is going to be the confusion matrix. 31 records misclassified for category 1, 12 record misclassified for category 0. So that's what you can see. Now, if I want to visualize how the split happened, I'll just plot the graph here as well. RF is my algorithm. And here you can see that in this way the splitting has happened. So there are slight difference, the decision tree and the random forest. The look and feel, if you see the earlier one. So this way the decision tree split has happened. Again, the random forest, there is a slight difference the way how it is getting splitted. So here and all clearly you can see some differences. But overall, the accuracy, if you see, there are not major difference between the decision tree and the random forest. So here we used Gini and we created 10 decision trees, n estimator is equal to 10. That's what we have done. Again, correct, we can adjust this parameter and we can check the accuracy. So now correct, if I want to try with entropy, so there are two possibilities. Either I can try with entropy or Gini. So if I want, I can go with the entropy here. So this is what I am using, the criterion equal to entropy, n estimator is equal to 10. I want to create 10 decision trees. Then I just try to do the prediction, doing the prediction for all the data set. Now I can check the accuracy. So that is my accuracy score, 0.8975. That's going to be the accuracy. And this is going to be the classification report. And this is going to be the confusion matrix here. So here you can see the accuracy equal to 89.75. And earlier what was accuracy? 89.25. So there are 0.5 difference in the accuracy. So not that major. So maybe correct if you change the N estimator, that also may change. So maybe correct 1 or 2% accuracy difference, that is normal. So that's what we have here right now. Now again, if I want to plot the graph for this, so we can just plot the graph. Plot decision tree, decision boundary x comma y classified. So this is what you're able to see. So the graph also not much difference. So here and all there are slight differences are there. So here and all some lines are coming, but here it is not there. But overall, if you see that one, not much difference. So the sun inside part, if you see there are not much difference. So that's the reason that the accuracy is almost same. So now I'll explain about. So do you want to try this algorithm? Decision random forest. So if you want to try random forest, I'll pause here for 5-10 minutes. You can try that as well. I'll give you the main statements which you want to execute it. So obviously, correct, you can copy from the previous step all the required libraries. So then load the data set here. Again, the next is going to be X and Y. So step creating X. Again, creating Y here. Now try to create the model. So these are the 3 steps we need to try. The rest all correct, it is going to be the same. We can use X and Y here. Because I didn't specify the step for the train test split. You can use X and Y, the full data set. You can do the prediction. So this is going to be the prediction value, and you can check the accuracy as well. So these are the steps to check the accuracy. At least I'll specify the important statements here. See, there are no errors. So we just try to, I'll explain all the parameters which is related in the classification report. First, I'll display all the predicted value here. So y underscore pred. So this will have all the predicted value, all the 400 records. And I'm just going to create a data frame out of this. So that's what we are doing it here. Ypred equal to pd.data frame. And this is the predicted variable. And while converting, creating the data frame itself, we are specifying the column name. So we are not specifying the column name. By default, the column name will be 0. So if I just print here without the column name, you would be able to see that it will be 0 here. So the column name will be 0. So that's the reason we are specifying the column name. The column name equal to y red. So if you specify here, the data frame will be created with a specified column name, or the later also correct, you can specify the column name. So the column name is specified. So now correct, I want to concatenate with my original data set. I'll just try to do df1 dot. This is the data frame, both are concatenating. And here correct, I want to add this as an additional column. So I want to do the concatenation based on the column 1. And the finally correct, we are printing the result. So this is what you're able to see. So now I want to export this data to an Excel. I can specify result dot. If I want to export to an Excel or CSV, you can specify to Excel or to CSV. So here I want to export the result to an Excel sheet. I can specify to underscore Excel. And I need to specify the location where we want to export it. So if I want to export, I can export to Excel, CSV, etc. So this is the place I want to export it. It's equal to rf.excelSX. So you are able to see the result. So this is what you can see: the user ID, gender, age, then estimated salary, purchase column, and this is a predicted value. And here, correct, by default, the index is coming. And if you don't want to get the index, here you can just specify index equal to false. The index will not come. So I want to get my confusion matrix as well. This is my confusion matrix. Again, so this is equal to classification report. Again, this is going to be the confusion matrix as well. So if I write the confusion matrix, it will be 246. Then this is equal to 11. Then this is 30 and 113. So 30, 113. So I already explained what are the values will come here. So this is corresponding to my actual data set. And the actual value equal to 0, 1. And this will be corresponding to predicted. So this is equal to predicted. And this is equal to predicted 0, 1 here. So this is what you're able to see. And the total number of records belongs to category 0. It will be the sum. That is 257. Again, the total number of records belongs to category 143. So that already we checked in the last class. So how it is working. So corresponding to 0, if you see, 247. And the actual equal to 0, predicted equal to 0. If I want to check the combination, that will be 246. That's what you're able to see. Actual equal to 0, then predicted equal to 1. So if I want to know that combination, so that's equal to 11. So that's the 11 record you can see here. So now if you want to add it, this is what you're able to see here. This is the total number of records. The 400 is the total number of records what we have. So this is the actual date value, this is a predicted value, this is the total number of records. So now if I talk about my classification report. So first of all, correct, what we are displaying here, this is the total number of records, the 400. So that's what you're able to see comes under support. Here it is going to display the total number of records, which is used there in the classification report calculation. And this is the number of records which belongs to category 0, 257. Number of records category 1, that is equal to 143. So now correct how the precision and the recalls are getting calculated. I already specified that one. This recall is calculation with relation to the actual data, and the precision is calculated with relation to the predicted data. So before that one, if confusion matrix, if I want to explain here, the confusion matrix, if you want to explain here, so we know that when the accuracy will be, we need to add all the diagonal value divided by the total number of records. And official terms, so what they will call this particular column. So here, correct, this is called the negative and this is positive. So this is called the true negative. So this column is called the true negative, and this column will be called as. So here, correct, it is tried to predict as 1. Just assume that when the prediction is 1 equal to false, positive, and whether it's a real positive, it's not real positive, right? So the actual data, this is 0, corresponding to category 0. So this is actually misclassified record. So that's the reason it will be represented as false negative. So when you refer any of the official books, the confusion matrix will be explained based on true positive, true negative, false positive, false negative, etc. So whatever is coming in this particular cell, the first one is going to be true negative. It's going to be the false negative. Again, here if you see that one, so this is again negative, and this is going to be the false negative. sorry, this is it is not negative, this is positive, sorry. This is false positive. And this will be the true positive here. The true means correct, actual and the prediction are matching here. So this way, if you refer any of the official books, they will be explaining about the confusion matrix. So that's what it is specified. So this is equal to true negative, equal to false positive, it's equal to false negative, and the true positive. And the formula for the accuracy, so we need to add both the true values. That's equal to true positive and true negative divided by the all the number of records. That's what you can see. So obviously we know that when if you add these two numbers, you will get 359 divided by equal to 359 divided by 400 is the accuracy we are going to get 89.75. So that's the accuracy you are able to get it here 89.75. So now if we come across this a recall. So recall is with respect to the original data set, the actual data. So the recall, if you want to calculate it, recall can be calculated for 0 as well as 1. So the recall corresponding to 0 will be the total. So this is correct. We need to consider it's going to be the true negative divided by the total number of records. So this is the total number of records you need to see. So this is a recall corresponding to 0. Corresponding to 0, it will be 0.96. So whatever is coming here, 0.957, that will be rounded and you are displaying as 0.96. So similarly, correct, if I want to find the recall for category 1, that is equal to the true positive. So wherever the actual and the prediction are matching, corresponding to category 1, so that is this value, divided by the total number of records which belongs to category 1. So the actual number of records belongs to category 1. That is nothing but the 143. So that's what you can see. 79 is going to be the recall for 1. That's what you are able to see. So this is 79 and this is 96. So that way the recall is going to calculate it. So this is the relation to the actual data set. So the next parameter we want to calculate, that's the precision. So precision also we can calculate with respect to 0 and 1. So this is equal to recall. This is what you are able to see the precision. So the precision is calculated with relation to the predicted value. So this is what you are able to see the total number of records where so this is correct. The actual and the predictions are matching the diagonal values. Actual 0 and the prediction 0, 246 records. So both the cases, the numerator will be same. Only the denominator is going to change, the precision and recall. So that is equal to this value divided by how many records predicted in the category 0. So how many records predicted in the category 0? This is what we have. That is equal to 0.899. So that's what you are able to see. The precision. So 0.891. That's what it is representing here as 0.89. This is the precision equal to 0. So similarly, correct, if I want to find the precision for 1, that is equal to this value. So where correct actual and the prediction are matching, 113 divided by the total number of records belongs to, the total number of prediction for category 1. The total number of prediction for category 1 equal to 144. So that's equal to 0.911. So that is equal to 91. That's what you can see here. So this way the precision is calculating. So the precision have the relation to the predicted value and the recall will have the relation with the actual value. So that's what you're able to see here. So that way we can calculate the precision and the recall. So the next one is going to be F1 score. So the F1 score also we have for both 0 and 1. So that's what you can say, F1 score also for both 0 and 1. 2 multiplied by precision into recall divided by precision plus recall. So now if I want to find the F1 score for 0, I need to write 2. That need to be multiplied with precision into recall. So this is correct, category 0 precision. Now this is recall multiplied with precision. This is what you're able to see. You want to calculate here, this is equal to, if I multiply 2 into precision into recall. So this is equal to precision multiplied with the recall for category 0 divided by precision plus recall. So this is equal to precision plus recall. So this is precision, recall plus precision. So that's equal to 0.9230. That's going to be the F1 score for category 0. So F1 for category 0, that's equal to 0.92. That's what you can see. Again, similarly, correct F1 score for category 1, that's again equal to 2 need to be multiplied with precision into recall. So this is correct, the precision into recall divided by precision plus recall. So this is recall plus precision here. So this is what you're able to. So this will be the F1 score for category 1. And I'm getting 0.8464. So that is correct, 0.846. So that is rounded to 0.85. That's what you're able to see here. So this way the F1 score is also calculated for both 0 and 1. So the next we want to calculate the average. The macro average is nothing but this will be the average. So what the precision and recall is going to tell. So how my predicted values are matching with the each category. So the accuracy is going to give you the overall prediction, but individual classes correct how the predictions are going to happen or how it is related. So that's what you're able to get it here. So this is the macro average. This is going to be the average of the precision. So this is going to be the average of recall. And here correct, this is going to be the average of F1 score here. So 92 plus 85 average equal to 0.88 here. So the next parameter what we have, it's a weighted average. So the weighted average of precision equal to, this precision need to be multiplied with the number of records plus this precision need to be multiplied with the number of records divided by the total number of records. So that's what you will be able to get here. So if I want to find the weighted average here, weighted average for 0 and 1, so that will be equal to the precision. So that is correct, the precision corresponding to 0 multiplied with the number of records. So this is equal to, this is a precision multiplied with the number of records which belongs to category 0. How many records belongs to category 0? 257. Precision for 1. This is what we have. Multiplied with the number of records belongs to category 1. That is 143 divided by the total number of records. So that means correct, it is going to give an idea how it is behaving for the full data set. So the total number of records equal to 400. This is what you are able to see. 0.898, and that will be rounded and it will be displaying as 0.90. So similarly, correct the weighted average for recall. If I want to calculate it, so I need to find the recall for category 0 multiplied with the number of records for category 0, that is 257, plus the recall for category 1 multiplied with the number of records belongs to category 1, that is 143, divided by the total number of records. The total number of records equal to 400 here. So that's what you are able to see here. That is equal to 0.8975. So that's again rounded and it will be displaying as 90. So similarly, correct, if I want to find the weighted for F1, it is going to be the same. So this is going to be the F1 score for 0 multiplied with the number of records corresponds to 0, 257, plus this is what we have multiplied with the number of records belongs to category 1 divided by the total number of records. That's what you would be able to see. So the total number of records equal to 400 here, divided by 400 here. So that's equal to 0.89568. So this is what you're able to see here. And that will be rounded to 0.90. So that way all these values are getting calculated. The precision recall, F1 score, how the macro average, how the weighted average, etc. getting calculated here. So you can go through this presentation as well. It is explained about true positive, true negative, etc. And the formula for F1 score, how weighted average needs to be getting calculated, etc. Okay, so these are the 6 algorithms I want to cover for classification. So we covered logistical regression, KNN, naive Bayes, support vector machine, decision tree, and the random forest.
All right, let's test your knowledge. Here's a question for you. Which of the following is not a valid way to read a CSV file using pandas? Option A, pd.read_CSV. Option B, pd.load_CSV. Option C, pd.read_table. Option D, pd.read_Excel. Take a moment to think, and when you're ready, choose the correct option. Remember, each choice holds a key to unlocking the answer. Good luck. Type the correct answer in the comment section. Hey there! Want to master data analytics and automation? Our Advanced Data Analytics with Python course is here to help. You can take it at your own pace on our platform. In this course, you'll learn all about data analytics and automation with Python. It's like a toolbox for handling data, from analyzing trends to automating tasks. Our course covers everything you need to know, from the basics to more advanced techniques. It's made by experts who know what they're talking about. Your teachers are pros who've been doing this for ages. They're here to help you learn and answer any questions you have. And don't just take our word for it. Our students love the course too. People just like you have found our course super helpful. Best part? It won't break the bank. This awesome opportunity to learn is really affordable. Ready to become a data analytics pro? Sign up on our page now. And for more info, check out ZaranTech's website.